when I went around inviting people for this workshop, many people thought that this is not related to them. But the whole purpose of this, and it is actually very ambitious, to organize a workshop of 17 days. The 4 workshop series, 3 are 5 days and 1 is 2-day workshop. But I feel by the end of this workshop or the previous workshop, at least the participants have gone back convinced that this is something important that they have missed. The second important thing is, when I even talk to the resource persons, they also tell me that, Arnab, I have no domain expertise in underwater. And all of them have gone back to say that my work is most related to underwater. Somebody like a historian. We've had 2 historians who have come and spoken, and one of them will come again in this workshop series also. People in geopolitics, people in international relations, they seem to be saying that we have nothing to do with underwater. And they've gone back convinced that their aspect is most important. I mean, now if you look at the Sagar vision of the Honorable Prime Minister, which is I think the most important policy vision given by our Prime Minister, the Sagar, security and growth for all. People who were involved in this whole conceptualization. Ambassador Javed Ashraf was in PMO at that time. Now he's India's ambassador to France. Ambassador Mukul, who was India's ambassador to Mauritius, where Honorable Prime Minister went and announced it. Shri Hemang Jani was OSD to the Prime Minister at that time, who was in the know of what this whole concept and what is the larger vision at the apex level. They all have been part of this workshop in the last 5 days. I have been lucky that I have spent almost now 1 year of connect with them, and I have discussed various aspects. So I want to assure the participants here is that you are going to be the first movers of this initiative. Mr. Hemang Jani right now is the Secretary of the Capacity Building Commission. Capacity Building Commission is a new initiative of the Government of India. There are 30 million government servants today, including all of you, Navy, Coast Guard, various other forms of the way the government delivers governance to its people and beyond. Capacity Building Commission has been tasked to make sure that these government servants have the right knowledge, right skill and right attitude. And I think the Government of India is now very, very serious about not just doing work, but the way the work is done. Not delivering governance, but even the way the governance is delivered. I'm sure all of you agree with that. And Mr. Hemang Jani is responsible for that transformation. He came and spent 2 days with us in Pune with 3 of his team members. And I cannot speak on their behalf, but what we heard from him in our platform, I think UDA framework is an important component of the whole vision that they envisage in terms of transformation of the entire governance mechanism. Ambassador Javed Ashraf joined us from France. He is now the ambassador of India to France. He joined us from there, and from what I could make out from his presentation to us, UDA is extremely, of course, he spoke more from the strategic security perspective, but definitely I felt that they are convinced that UDA has a very major role to play. Ambassador Mudgal is more strong proponent of the blue economy, Today, when we look at the blue economy, India is at a very, very different level. And it is not just the security and the growth, but it is also the skilling. The reason we have put skilling as a more important front runner in terms of we driving UDA is that many people in the country forget about the core people who are involved. Navy has, of course, done a lot. Navy is driving this in a very different level. But various other organizations which support the whole blue economy or the strategic security, I think there is a lot of distance to be covered in terms of their awareness. And I would like to have a conversation with my naval colleagues who have come here, and I'll come to Army a little later. And I would like to convince them that there is far bigger dimension to the UDA than what we've been dealing with. Now, coming to the Army, I made a request to the Army commander here that, sir, this is an event that is happening and you must definitely send people for this. And he was extremely kind to send 2 of you are here, and I think 1 or 2 more will be joining in a couple of days. Look at the transboundary rivers, Brahmaputra and Indus. Look at the various water bodies. Even in the border areas, in a conflict situation, you have to deal with a lot of water bodies. There is a lot of underwater domain awareness that will be required. And I had the fortune of discussing at the highest level. And there is definitely a lot of positive response to what I presented to them. So in this week, we will also look at a couple of dimensions of that. So the way we have planned this particular workshop, in the previous workshop, as I said, we talked about the larger global context, how this is getting importance. We had this is, as you are aware, this is the Decade of the Ocean Sciences announced by the UN. And the UN agency which is driving this is the Intergovernmental Ocean Commission. So we had the head of Intergovernmental Ocean Commission, Dr. Vladimir Rubin, who came on our platform and discussed what are the different activities and different mechanisms that they are trying to put in place to make sure that there is better governance in the ocean. We also had a whole lot of other people talking about the different aspects. As I said, traditional knowledge is very important. We in India are a civilization which is more than, I think we can safely say 10,000 year old, right? And there are so many things that we have done right. And if we have done so many things right, how come we are not making use of that? We seem to be depending too much on the West for many of our know-how and the technology. So we at MRC are also looking at how some of the traditional knowledge and traditional practices can be mapped onto the modern science and technology. So I will request you to go through that particular video. This entire workshop is also online and it will be available. Every lecture will be available. The video will be available to you. The concept note that I have shared, you can just click on that. There are 2 places that you can click, one on the profile of the speaker and also on the title. When you click, you will get a video of what has been spoken. So I would request all of you to please go through, even if you have missed the previous one. So there were so many traditional practices that we had which are extremely relevant. Yes, only problem we had with traditional practices was that they were not able to, it was not scalable. So if the modern science and technology can help scaling up those practices, I think we are doing well. But we must definitely evaluate them in the present context and then take it forward. Then we had also Professor Ajay Dandekar, who came and spoke about the whole water management from a historical perspective and from a geostrategic perspective. Again, it was a very fantastic perspective that he gave. Now, this week, we have multiple speakers. Now, when you look at the underwater domain, the most viable way of making it work is the digital transformation. I'm sure you will agree with me. But the digital transformation itself requires a huge infrastructural transformation. The computational infrastructure is of a different level. So we have a series of speakers today. In fact, after the inaugural, we have Dr. Ashish from CDAC, who will be talking about the high performance computing and what the national program, national mission for supercomputing is all about. He's been closely associated. Thank you, sir, for being here. Then we also have my very close friend, dear Dr. Venkata, who will be joining us online. He'll be talking about quantum computing. Then we also have tomorrow, not tomorrow, day after, Manas, Devan will be talking on the metaverse, the whole virtual reality domain that has come about now. And then the core data analytics for UDA, which will be done by one of my team members from Australia. He'll be joining online. He's an expert on AI and data analytics. So we have tried to cover one aspect of the whole computing infrastructure. The second part is some of the users. We have Commodore Soman Banerjee, who will be bringing a very different perspective from a global order perspective. In the sense, we are talking about now our connectivity, global connectivity, internet connectivity is about 97% is through the underwater submarine cables, right? So have we really looked at, and there have been cases where a couple of countries were cut off for more than 2 weeks. Can you imagine being cut off 2 weeks? So this is an underwater domain awareness, a very top level strategic security dimension, far away from the hard power military perspective that we understand. Second is the Nord Stream gas pipelines that are there, and there are many such aspects. So Soman sir will be talking about that, and he's worked with the Vivekanand Foundation. He is a PhD from JNU on the subject, and he'll be giving a very different perspective on that, a user. And I would like all of you to ask questions because he has been involved in a very top level policy making and how the global order is being defined. Then we'll have also now the European Union is looking at the Indian Ocean very, very seriously. So we have Ambassador Raj Srivastav, who is India's ambassador to Croatia. He'll be talking about the Indo-EU opportunities and what are the prospects. So he'll be taking a session on that. And several other industry captains will be there. We'll have representatives from Bharat Forge who are into defense in a very big way, defense and aerospace. We'll have from L&T, it will be represented by the top leadership. So we have tried to give a larger perspective, and even there'll be Commandant NDA will be joining us and giving us, because he's a naval admiral who's part of the naval leadership. So he'll also give a different perspective to what the Indian Navy and otherwise how important the UDA framework is about. Today, as the start of the workshop, we are trying to put together a panel. Again, we'll try to give you a different perspective. So I'll request Admiral Varma sir to give a welcome address. Admiral Varma sir is somebody who's been my mentor for more than 25 years now. He was the Chief of Material in the Navy for the young student. Chief of Material in the Navy is the senior most technical officer in the Navy who determines the technical vision as well as the logistic vision of the Indian Navy. After that, sir took over as the Director General of the Nuclear Submarine Project, the ATVP. So it was under his leadership that India's nuclear submarine was launched in 2009. And he was involved in various technology projects, mega projects, not just the ATV, but otherwise also he has been the whole indigenization initiative of the Indian Navy. He has been a major visionary there. He has been instrumental in the user academia industry partnership, how the academia like IITs can contribute to the Navy's requirement, users like Navy, Coast Guard and various DRDO, and how the industry can come together with the user at the academia, and under his leadership I also got an opportunity to contribute to some of these things. So I'll request Admi Varma sir to keep, we'll change the concept, format a little bit, sir. I'll request you to give your talk and then we'll continue from there, sir.
I've been asked to make the welcome address today, and therefore I'm going to just do exactly that. Uh, we have today with us Dr. Shenoy, Satheesh Shenoy, who will be giving the keynote address. Dr. Arnab will tell you more about the UDA, so that you have appreciation of what it is. Dr. Lakshmi Krishnakumar, she's I mean, I will leave it as a surprise, because uh, she's going to tell you how underwater is linked with humanities through the lens of poetry. I'm told that Shri Kishore Mandya will join us later because he's not there. And then the indomitable Praful Talera will give the vote of thanks, because without him, nothing finishes. So this is day one of the second workshop in this series of realizing the PM's vision of Sagar. Now, before I go further, how many of you have actually found out what is Sagar? Yeah, I think every other day you hear the word Sagar, you hear about even during the G20 you heard about this. So I think it's important for you to know security and growth for all in the region. This is the vision of the Prime Minister, where he's trying to take everybody around the Indian Ocean, all the nations. How many of you know how many maritime neighbors we have? I'm sure the Navy guys will know, hopefully. But there are about 38 to 40 neighbors we have who are neighbors. It's only the water that's a different thing. So they actually are our boundaries. So we need to involve them, to ensure that we have security, because security cannot be just one way. And of course, growth in the region, so that everyone is prosperous and there will be less problems at sea. So, Sagar, the PM's vision of Sagar, by building the necessary capacity and capabilities under a synergized and cooperative framework. I think similar definition was given by Arnab. Now, coming to UDA, the UDA framework, which Arnab will say, is best suited. Now, what is this framework? As I understand, is basic to see underwater. That means sense what is there, because you can't see, you'll only hear through sonar. So it is sense, analyze the inputs that you get, and share it with others. So that is the thing about the whole framework. It's so simple, but it's pretty complex. So it is the best suited for pooling of resources and synergizing of efforts of the various stakeholders. Now, the main stakeholders, all of you know, national security, that's why you have people in uniform sitting here, industry, who will transform our research and science into into the actual issues, and of course, marine environment, because unless you have a clean ocean, I'm talking clean from all parts, right? You won't even be able to sense anything out of it. As Arnab has already mentioned, because I attended the last session, the last workshop, we had a fruitful 5-day interaction. And as he said, it is for policy intervention issues last week. Probably we had, in my opinion, one of the best resource persons that we could think, as right from the executive secretary of the IOC, UNESCO, to the last speaker, which is Hemang Jani, who is the Capacity Building Commission chairman. secretary rather, secretary is chairman. Well, he's the person who's doing it. And the good thing about all these was UDA found a place in each of these presentations. I would like to specifically say about the capacity development and awareness module of the IOC, which is one of the very important. There are some eight modules. So one of the modules where uh, the Mr. Doctor, what's his name? Vladimir Ryabinin, right? He very clearly said that I see a place for the underwater domain awareness in this area. So we already have found a place there. Now we need to get there. And for which what we have to do? We have to build the capacity, we will build the capability, we will have to get people ready. And this is one of the things to basically tell people, hey, there is something there where even international people would like to engage India. I believe that as we go on, we have the entire spectrum of multidisciplinary and multifunctional experts and strategists on this platform, right? The number of institutions that have been represented in the series of workshops is remarkable. As I said, from international, national, even, and I would also say that the papers being presented by the fellows of the MRC are really, gone in depth, or for the tools that have been made by them in the UDA. So it will be very good that if we participate and get to know how far we are already in to achieve this. Now, true pooling of resources and synergizing of efforts is what we are talking of UDA, and that has been on display the last week. Nation building requires such massive collaborations to drive new ideas. This is a new idea, like uh, I think it's new, but for Arnab it is old because he's been at it for the last 6 years, I think. So it's a new idea for a lot of people. Everybody knows that the oceans, everybody knows is underwater, but to look at it as one whole water body, not only the ocean, the rivers, the source, uh, and other water bodies, as is a concept of the UDA. Now going forward in workshop 2, which is where today is the first of the thing, it is the technology intervention, as it says, the technology interventions, because now we've seen the global, national, geopolitical, and we are convinced that there is a place for UDA. Now, so how do you go about it? You can't keep writing and giving talks, right? It has to be with technology interventions. The underwater space is very complex. Those from the Navy will understand that. And it is a complex task. However, the commitment to achieving this under the UDA, as I mentioned to you, has been and is commendable. And India taking a lead in this part of the Indian Ocean region, being a major power, will otherwise somebody will come and fill the space. So we taking that and ensuring that knowledge remains with us and we lead the thing along with our neighbors is a must, and that we are at it is really commendable. The digital, yeah. Now the digital underwater is certainly inescapable. What do I mean by this? All that you sense, this, put together, analyze, etc., you have to have digital transformation. It has to be in digital format so that you're able to, interact with the data, learn from the data, let the data learn on its own, do some analytics to produce results that you're looking for. I find that there are a good line of enabling sessions, so I don't want to take the their thunder. Let them speak about it, right? Um, and also some strategists who are going to define the problem statement. In everything, we all know what to do, but how do you define the statement? And it should be with clarity and match it to the dynamics of the ecosystem so that you come up with outcomes that are possible. There will be talks on artificial intelligence, robotics, quantum computing, high performance computing, metaverse, data science, and more will be discussed along with many other important aspects. These are the tools which our youngsters should be skilled, because these are not, in my opinion, they are not the tools of the future. They are tools of the present for the future. And as you go on it, so we all know that AI is no more something that I am going to do. It is already done. All of you are aware of ChatGPT these days, which making things so easy. So things are already being in the common use. So definitely it should come in our curriculum. Senior industry representatives will also be joining to present the larger translation of research inputs into practical user-defined solutions. User stakeholders will apprise us of the challenges and opportunities in the field of deployment. Senior policymakers at the operational and acquisition levels will brief us on the future requirements of technology. I'll just go a little further and say the third phase, which Arnab alluded to, will be even more exciting. It is engagement with the committee through field interaction and with the communities, and also witness the deployment of the technologies in the field for the communities to understand what the ocean is and what is their requirement and how they can contribute is what's going to happen there. So as I said, I'm happy to welcome all of you today, both present here and online. Dr. Satheesh Shenoy, an authority on digital oceans, who's a former director in COIS, that is Indian National Center for Ocean Sciences, Hyderabad, and former director of NIOT, Chennai. So anything to do in underwater, he's the man, he's the person. And he has decided to emerge from the deep ocean to be with us online. Shri Kishore Mandya, who will be joining us later, is an authority in sustainable development at the global level, having been a member of the cabinet of the UN Secretary General, besides other high-profile appointments at the international level. So they would be here as part of this inaugural session. And as I mentioned to you, Ms. Lakshmi Krishnakumar, a Shakespearean scholar, writer and theatre director, synergizing the arts and the science fields, and seeing the scientific world, the underwater world, through the lens of poetry. Thank you for those who are here in person, and Dr. Shenoy, who's joining us from line. I'm sure your interaction will motivate the young audience on this nation-building project. I think I'll stop there because basically it is more important for the keynote address and the other speakers. So I'll thank you very much. I hope I've been able to make some sense to motivate you people that there is something called underwater. There's a lot there, not just taking your snorkel and diving, but there's a life there. And that life has to be integrated with our life. Thank you.
Thank you, Admiral Varma, sir. As always, your understanding of the domain and the various aspects of technology, and also from a techno management and techno administration perspective. And MRC has gained a lot from your experience and your mentoring. Thank you so much, sir. So I'll now give you a little brief exposure to what this UDA framework is all about. And I'll be happy to answer questions if at all somebody wants to. You can even stop me in between and seek clarification. Okay. So when we say the underwater domain awareness, very simply it is to monitor what is happening below the surface of the water. But that's not enough. I mean, when we say the framework, it is about bringing policy intervention, technology intervention, and capacity and capability building. Now, typically, why do we want to do this? To achieve safe, secure, sustainable growth. Safe is safety from any natural disasters. Security is, of course, any man-made threat, both internal and external. Third is sustainability. When we talk about sustainability, it is not just ecological sustainability, but sustainability in a much larger sense. Many of our projects become unsustainable or unviable because of poor planning, because of not having the right dimension. I will give you more details on that. And of course, growth. Except my friends in the Navy, I'm not sure if you know, in India, we have presently 20 lakh square kilometer of exclusive economic zone. And now we have made a case, instead of 200 nautical miles, it will be increased to 370 nautical miles. We have applied for it, and I think the International Seabed Authority will, in most likelihood, accept that. So the terrestrial India and the maritime India will be almost of the same size. And if we add the freshwater systems, it is a huge asset that we have. But what is the contribution of the maritime India to the GDP? It is not even 4%. So if we really want to be a global power, if the maritime India or the underwater India does not contribute to the GDP, then I think we are really not making optimum use of our assets. So that is the seriousness with which we need to look at it. Next, please. And why are we talking about, I've used the word Indo-Pacific region. Now, this Indo-Pacific region has a certain importance. Today, if you look at this map, the entire global interactions are happening in the tropical waters. In the last century, it was the Pacific and the Atlantic, right? But today, in the 21st century, the global powers, the global power play is happening in the tropical waters. The tropical waters have a very different characteristics. And particularly when we talk about the underwater, it is a very, very different scenario. My naval friends will bear with me. Anything that you have to see underwater uses a sonar. The sonar performance in the temperate or the polar region, and that compared to the tropical region, the performance degradation is of the order of 60 to 70%. Mark my word, 60 to 70%. So if we are importing technology from the West, it really does not make sense. A lot of work, it is inescapable that we have to have indigenous effort. So that is the defining aspect of the tropical waters. Now the second aspect is siltation. The tropical waters have a very different level of siltation. The whole underwater behavior is very, very different. I'll come to it in a little bit more later. Next slide, please. Now, if you look at the very definition of the Indo-Pacific region, I mean, today in all strategic discourse, Indo-Pacific is being used. Even in my initial thing, I said EU focus on the Indo-Pacific. The Indo-Pacific by definition is the tropical waters of the Indian Ocean and the Pacific Ocean. Now, if you have to be a relevant player in the Indo-Pacific region, you cannot be there if you do not understand tropical waters. And it is not just the hard military power, it is also the blue economic agenda that we need to drive in those waters. So again, understanding the tropical waters is very, very important. So the UDA framework that we are driving is extremely conscious of the tropical conditions that we need to operate in. Next, please. Now let me take you to the, now there are army officers here, so I wanted to put this slide right in the beginning. Now this is a map of China. I'm not even talking of them as an adversary, but I'm talking about a big power in our neighborhood. If you look at this map, the north of China is completely dry. And you look at these tunnels, which is about 1200 kilometers and 1100 kilometers. These are underwater tunnels that they have built to transfer water to serve their cities. Strategically, what does it indicate? They have a huge water crisis, but they also have the resources and the know-how to transport water. Now imagine in the last COP, they have assured the world community that they will transfer 15% of the thermal power. The COP is a commitment for net zero, right? So they have committed 15% shift from thermal to hydro. Where do you think this hydro power will come from? It is the Brahmaputra, which flows 1600 kilometers in Tibet and then 900 kilometers into India. They've already started building dams. And those are on the right, if you see, or for you while you're facing it on the left, these are the proposed tunnels that they are looking at. Some experts at a very high level have said they are all rocky areas. How can they build tunnels? I mean, these are tunnels will be required about 1000 kilometers tunnel. It's not viable. In India, Delhi Metro has been built. There are the tunneling technology at a different level. It is easier to build tunnel in hard surfaces or hard material than in soft material, right? Or even India, we have got these technologies now. And China is definitely at a much different level. So whether it is resources, know-how, or the intention or the motivation, everything is in place. Are you with me on this? So we need to worry. Going forward. Now, if you look at India in the 21st century, we have a declared Sagar vision, security and growth for all in the region. Can you imagine the Sagar vision without the underwater? What is Sagar vision without the underwater? All the resources that we are talking about, all the other uses of the maritime domain or the water surface, underwater will have a major component. Now, to support the Sagar vision, there is announcements like the Sagar Mala and the inland water transport. If you look at the inland water transport, it is 20,000 kilometers of waterways that have been planned. There are 116 national waterways that have been declared. 5 are already being used to some extent, but now they have announced another 111. Inland Water Transport Act has been announced 3-4 years back. Navigability of these waters is a very serious issue Particularly when you talk about Brahmaputra. I don't know how many of you know the width of the Brahmaputra is, average width of the Brahmaputra is 5 kilometers. At places it is 8 kilometers to 10 kilometers wide. And it changes course almost on an annual basis. And it's an extremely shallow river. You imagine we investing, and the national waterway number 2 on the Brahmaputra is 900 kilometers. Now, if we do not have navigable waters, what are we talking about? So don't you think we need to study the underwater in a very different level? We are rushing to the Nordic countries for support on the IWT. Do the Nordic countries understand what are tropical waters? Even do they understand the siltation pattern? Now, Sagarmala, we are talking about a port-led growth. Even something like JNPT, the siltation is so high, we are spending 150 crores for desilting or dredging in the JNPT. It makes the project unviable. Is dredging the only solution for keeping the channel navigable? There are a lot of studies, even the advanced ports, they have started using a lot of acoustics, continuous acoustic monitoring to make sure the dredging cost is reduced. And particularly dredging doesn't make sense in the tropical waters. The flow is so high here, the Brahmaputra loses 4,000 meters after it enters India. When a river flows with so much speed, I don't think we can keep it navigable by just dredging. Sediment management is a very different domain. It has to be understood. The sediment transport pattern has to be understood. You will see a couple of presentations by our MRC fellows, and I would like all of you to get involved and ask questions so that you understand what is the new concept that we are talking about. It's not new concept, but it is probably we're saying it differently. Now, Deep Ocean Mission is a very, very ambitious initiative. It is not only, now we talk about EV, for the benefit of the young students, I would like to say, now this whole EV initiative that we talk about, the amount of rare earth metal that is required to sustain the EV movement, EV initiative, cannot be met from the resources on land. 6 times more assets are available undersea, and the whole global community understands that. But then there are challenges. So when we are in a platform like COP or any other platform, we are worried about the sustainability concerns. The International Seabed Authority, they have explored the availability, but now for the exploitation, there's a huge debate going on whether that should be permitted or not. How will you keep it sustainable? I mean, if you dig the deep oceans also, then how will you ensure sustainability of this earth? So there are those kind of, but what my proposal here is that with better underwater domain awareness, we can still probably drive a better sustainable initiative. We can come to it in a while, we can discuss it in a while. So now we are looking at the Northeast in a very different way. It is not only the not the Look East anymore, it is the Act East policy, but there is a huge potential for the Northeast to contribute for the development. I'll discuss it in a while. And when we are talking about development, we must also keep the socio-economic and socio-cultural perspective. I mean, traditional knowledge is just one part of it. Unless we take the communities along, we will go horribly wrong. So we at MRC are also looking at how to be inclusive in terms of when we talk about the digital ocean or the digital transformation, how to keep the communities also on board. We'll talk about some of the projects. And then typically anything underwater has to be acoustics. Speed of sound in air is 345 and speed of sound in water is 1500 meters per second. So sound is or acoustics is the only signal that propagates efficiently underwater. So you cannot do anything without acoustics. So if you have to drive underwater domain awareness, it has to be acoustic capacity and capability building. What it is, we'll talk about it. Next, please. Now look at this map. Let me shift your focus to freshwater systems. This map represents the availability of freshwater resources in the country. Today, as we talk, we are 20% short. And if we continue the way we are, we'll be 80% short in the next 10 years. But it is not the availability alone, it is the distribution of water, if you can see. The Northeast is the only surplus region in the country. Today, when we talk about the semiconductor initiative, I mean, there is now a national initiative on the semiconductor requirement, right? But the semiconductor industry requires huge amount of water. Where will the water come from? Can you put a semiconductor industry in a place where there is shortage of water? Now, a lot of industries from Taiwan wanted to shift to India. Where can you put them? Northeast was considered, but then there are other challenges there. So, I mean, when you look at the larger decision making, these are some of the things which have to be kept in mind. Next, please. Now, it is not only the availability of water, it is also the quality of water that is available. If you look at this map, you can see the biological and chemical contamination is at a different level. Lot of the water, groundwater that is available is not usable. The second is the unequal availability of water to the different communities. I mean, India is a very diverse country, right? Many of us are very privileged to have fresh water flowing in our taps. I want to bring two aspects here. One is the same quality of water is being flushed through your washrooms, and the same water comes to your kitchen also. If you are 20% water short, how is it possible? Number one. Number two is that, do we have a sense of what water is coming in your tap? Today there are commercially off-the-shelf equipments available which can give you 28 different parameters of the fresh water. It's just a framework that is required. Don't you think there should be a mobile app which should tell you what is the water quality available on your tap? Every advanced country does that. And with this kind of distribution of water quality, don't you think it's important that we know? Most of us are buying water and drinking, right? I mean, we have reached a stage where we have started buying water, we have started buying air also. In Delhi or many other places, if you don't have an air purifier in some part of the year, I think you're not doing well, right? So what you're paying for the fresh air that you need to breathe. So we are making it an unlivable world. Next. So we have to put certain systems in place. So the digital transformation is the only viable method to make it happen. How do we have a better understanding of the underwater domain? Now, maritime domain awareness is a term which became very popular in the last 25 years, I could say. It was 20 years plus. After the 9/11 in the US, the global community driven by the US started talking about MDA in every forum, right? Our naval friends will bear with me. In India, it was after the 26/11, right? In every forum, strategic forum, we started discussing MDA. But what is MDA? MDA is an event-driven thing. 2 events, we became very conscious of it. But the larger worry is it remained a security-driven thing. And it failed to be inclusive enough to involve the other stakeholders. Other stakeholders are science and technology, environment and disaster management, and of course, blue economy. So it remained on the surface. I mean, the traditional MDA, even, I mean, I'm not saying myself, when Commander Bores from the US Navy wrote a paper titled Maritime Domain Awareness, Myth versus Reality. I would request you to have a look at that paper. He has not only talked about the hard facts, he has also talked about attitudes. मुझे सब पता है. He's written in those many words. Many of us feel मुझे सब पता है. आपको सब पता है तो मेरे लिए आपको बताने के लिए कुछ नहीं है. He's written it that way. You please, it's available on the net. You can Google it and read that paper. But what I'm trying to say is that the classical MDA has failed to look below the water. And we need to look below the water. Next, please. So if you just look at the stakeholders, next. Now, if you look at just from the maritime security perspective, whether it is internal security or external security, the underwater threat is becoming a very, very serious issue. Both, I mean, even for the river systems, my friends in the army are involved in providing security in the freshwater systems. Even young kids today in the college are playing with underwater robotics. And imagine some of them going into the wrong hands and what it can do. Even we had the Kasab incident, and I think we do not expect the next guy to come by a surface boat. There is a huge possibility. Then this migration, I mean, the Rohingya crisis is only a tip of the iceberg. We've had the boat people has been a phenomena which is more than 600-year-old. And to counter these people is not easy. Their motivation, they are rugged people, it is very difficult. So if they turn against you, which is a very, very serious possibility in our East Coast, we need to look at this from a very different perspective. So internal security can have a very different dimension. So we have to have, I mean, what I'm trying to drive here is even our paramilitary forces and other forces who are responsible for internal security, Navy has a certain role, then other organizations have a role. We need to look at this very differently. We are trying to work with multiple organizations. I cannot talk about it in detail, but I think there is a lot of possibility. Next, please. Now, if you look at blue economy, the Indian Ocean region is the hub for energy security. There are economic engines on the far east, and the energy is available on our west. So the entire energy flow is through our waters, and it can become a very important choke point. Now, if you look at the fisheries, we are looking at the ocean for food security also, right? Now, if you look at the ocean for food security, there is a credible research report that says since 1996, the fish stock globally is on the decline. But on the other side, if you see the bycatch, fishing today is 60% in the unorganized sector, globally, not in India. Globally, fishing is in the unorganized sector, so the data is also not easily available. I mean, the data which I said, fish stock is on the decline since 1996. This took a researcher in Colorado University more than 15 years to come at this number. So, but the bycatch in the underwater domain is of the order of 80%. Sir, please come here. Sir. So, how do you reconcile? On one end, we have less resources, and the other end, 80% is the bycatch. I hope you understand what is bycatch. Anybody doesn't know what is bycatch? When you put a net, a trawler, it picks up, say, 100 tons of fish. You pick up what you want and the rest you throw in the water. What you throw in the water is 80%. So mechanized trawling has a lot of disadvantage. How will you regulate that? Don't you think we need underwater domain awareness to regulate fishing? Then you offshore rigs are there, their requirement of underwater because they need use a lot of underwater technology. And also the deep sea mission. We are a partner to the Ministry of Earth Sciences for capacity building for the deep ocean mission. But there's a lot of work to be done, a lot of data analytics to be done. Next, please. Now, even if you look at the the river system, I mean, I talked about the Brahmaputra, the traditional fishing, those communities have no support. And with the growing industrialization, they'll be completely marginalized. Their practices will remain small because financial institutions are not ready to support them. Can we not build technologies? Can we not bring frameworks that can bring more certainty to their practices and give them more support? To make them inclusive, to bring them into the mainstream. And you can see dredging activity now, these are becoming very, now India is a very unique country where we have freshwater dolphins. Now the inland water transport is a very ambitious project. But we have freshwater dolphins in the Ganges, the Brahmaputra, the Indus. And what happens to these dolphins who are blind and they use what is called acoustic vision? So in a conservation, I mean, every World Bank project has a separate budget for environment impact assessment. But acoustic habitat degradation is not part of the environment impact assessment. Now the global community is waking up, and I think we are very proud to say that the International Maritime Organization has accepted our paper. And now based on that paper, they have made India a nodal country for the underwater noise in the Indian Ocean region. Next, please. Now, environment, as I said, there are large-scale strandings that are happening. The Maharashtra coast alone in 2018 had 80 big whale strandings. And I have written a paper that this was because of the anti-piracy operation that started in 2009. We can go into the details later, but this is acoustic habitat degradation, and it has been well accepted globally. Then disaster management also. There are so many dimensions of disaster management. I am not here to say we can prevent natural disaster, but we can certainly minimize loss of life and property. There's far more underwater domain awareness required in our entire disaster management plan. Next, please. And again, I mean, disasters in the river systems also. How do we, like the dolphins, when you say, we've been spending a lot of money on dolphin conservation, but acoustic habitat degradation has somehow not figured in this. I was very surprised. 2006, I was still a serving naval officer. I was called by the Chilka Development Authority to look at, they have a very unique species called the Iravathi dolphin. The Iravathi dolphins are facultative dolphins which live in freshwater for 6 months and seawater for 6 months. And they are blind, they use acoustic vision. In the early 90s, in their wisdom, they said that community involvement is very important for conservation. So they said that we'll encourage dolphin tourism in the Chilka Lake. And earlier there were no mechanized boats in the Chilka Lake. Now the government gave licenses for mechanized boats in the Chilka Lake. And that was a bigger problem because these mechanized boats generated a lot of sound. And even the propeller also could damage because of accidental thing with the dolphins. The numbers kept on going down, but when I met them in 2006, Chilka Lake was a very unique place in India where boats were given licenses, first time. And now the government cannot go back. So it just continued like that. What I'm trying to say is that these are very different dimensions which we need to understand. The technology can bring, or the research can bring these information, and policy making can be far more effective. Next, please. Now, of course, science and technology, as I said, we have 20 lakh square kilometer of EZ. We don't have any appreciation of what kind of ecosystem that exists underwater. We have no idea how these different components of the ecosystem interact with each other. So how do we drive sustainable growth? There's a lot of study required to be done, scientific study required to be done to understand the ecosystem, then only we can move ahead. Now, even from when we say digital transformation, can you put so many sensors in the entire underwater domain to even understand what's going on. I mean, when we say UDA or the acoustic capacity building, there are two basic formula which I can say. To see, to understand, and to share. To see is the basic sensors, whatever. It can be acoustic, optical, whatever sensor. And the platform which will carry the sensor. That is the to see. Now, platform can be a ship, submarine, any subsurface platform, AUV or anything else. To understand is whatever data you have collected, you have to first do the pre-processing, bring the data to some level of analysis, and then whatever application specific processing and also post-processing. And the third is to share. Now, when you say share, this is very important because it has to be user specific. Now, the user can be vertical and horizontal. Vertical could be at the top level, policymaker need a different kind of inputs, mid-level managers need a different person at the ground, operational level require, practitioners require different type of data. So they need to be given the inputs at a particular, then diversity, at the horizontal level also. Whether it is a community or a stakeholder, defense, whatever sector that we are talking about, everybody must get the inputs that they require. Now the problem here is that it is so fragmented, everybody is trying to set up their own systems, it doesn't work like that. I mean, as a developing nation, will never be able to, even the Americans could not figure it out in a way that it is desired. So we need to really put together a whole lot of, so I was in Tokyo in 2014 and I saw the systems that they've built. How the academia collaborates with the research organization, with the organizations that deploy ships, and the data collection is done in a very seamless way. Our academia has to get into real world problem solving. We can't be completely lab based. So how do we build that connect? There could be certain interfaces where data can be, real life data can be collected and it can be brought in, where our students can, at different levels, can analyze that data and give certain inputs. Next, please. Now, this is the framework that we are talking about. This is the UDF framework that we talk about. If you look at the horizontal construct, it represents the 4 different stakeholders. Whether it is security, blue economy, environment and disaster management, and pure science and technology. They may all have very unique requirements. But the core will remain acoustic capacity and capability building. Now, if my sonar in Russia gives me a certain, a particular sonar gives me 32 nautical miles, the same sonar in India gives you 6 nautical miles. So whether you want to use it for deep ocean mission or a naval requirement or an environmental monitoring, the sonar has to first work, right? Even your deployment strategy also will depend on the sonar performance. I meet a lot of researchers who buy or they rent a sonar and go and deploy it. If you do not have the sense of what range you are getting, what kind of data will you get? There are a lot of scientists, researchers who are going out to sea and collecting data, and we have a problem of multidisciplinary or interdisciplinary work. So if they do not understand acoustics, if they do not understand the tropical waters behave differently, a Western vendor is too happy to sell his equipment. Will he show performance in our waters? I don't think so. So it requires us to build acoustic capacity in a very different level. If you look at the vertical construct, we have very little understanding of our own waters. So a lot of sensing is required, application specific analysis is required, and then the regulatory or the policy should come. In many cases, we have imported policy from outside. It does not work in our waters. We don't know what the reference is. We keep giving waivers to certain policy or the larger, whether it is a deployment strategy or whatever it is, and we have no sense of what is happening underwater. So there's a lot of work to be done to first understand. Now, even for the young students, it's a multidisciplinary framework. Every cube within the bigger cube represents a specific project which our young students can, whether it is a science and technology students or a liberal arts students or a law student or whatever, you have some relevance to some part of this cube. You can contribute. whether it is for communities. Even a finance student can be part of this. We've had more than 400 or 500 students who have worked with us, and all of them are of different disciplines. Next, please. Now that larger UDA, I have divided into some smaller ones. I can make some 100 such smaller things. This is for underwater radiated noise. The ships, when they operate in water, they generate certain sound. And because the ships generate low frequency sound, this propagates thousands of kilometers. Now, from a naval perspective, acoustic stealth is a very, very important aspect. So one of the biggest stakeholder here is Navy or, the military. But as I also said, now there is a large scale strandings that are being seen. So acoustic habitat degradation has become very important. Now the conservationists, marine conservationists have also started taking a lot of interest. The environment impact assessment has to make this part of their thing. Even the shipyards and the shipbuilders need to look at this so that their ships are much less noisier. The European Union Marine Strategic Framework document now has made it not mandatory, but they have made it important that ships have to have the acoustic habitat degradation check. The radiated noise of the ship has to be monitored. It's like you have a pollution control, PUC certificate when you put a vehicle on the street. Now that is going to be mandatory for a ship. For a ship entering the European Union, this is going to be important. Just to give you an analogy, any vehicle that you, before getting it out on the road, without the PUC, your vehicle cannot be registered, right? If that happens to a ship, that you cannot enter a certain area, just imagine the business opportunity that exists, right? But what I'm trying to say is that so many of them can come together. The scientific community will have, like the way the communication industry picked up, when there were so many stakeholders who were interested, who were ready to put money, the technology development was so fast and so much resources were available. So similarly here also you can see so many stakeholders, they can come together, put money and develop this domain. We have developed the entire wherewithal how this can be done automated. Right? Next please. Second is sediment management. Now, as I said, the siltation is very different, right? So who are interested? Inland water, port management, and also in the army, if you have to deploy, you have to build temporary bridges, you have to build, or you have to deploy heavy vehicle in water bodies, shallow water bodies on marshy land. Don't you think you need information on the sediment bearing pressure? If your vehicle gets stuck, how will you deploy? If you have to quickly deploy certain assets in certain areas, you have to have a proper input on that. This is what we are talking about. We'll have Romit who will be talking about sediment classification, and we'll have Rishika. Romit is from IIT Delhi final year, and even Rishika is IIT Delhi final year. They have come to us second time, and both of them are working on, one is working on sediment classification, and the second one is working on sediment transport. So I would request all of you to look at their project. And so in this entire thing of policy, technology and capacity building is being built up. What kind of courses are required? Who are the stakeholders? Everything is being mapped. Yeah, next please. So this is the larger user academia, user industry academia partnership. Already in India, there are certain schemes that are already available. Make in India, Startup India. All we need to do is insert this UDA into that. There are certain core areas, specialization that is required, or core expertise that are required. Whether you are a computer engineer, you are an electronic engineer, UDA is nothing different. You can contribute to the UDA framework. So we get a lot of students, as I said, More than, I think, 300 BITS Pilani students have worked with us. 200 IIT students have worked with us. TERI also sends us students. Many young, we run this UDS summer school, so almost 500 students have altogether gone through some of these programs that we initiate. Next, please. So these are some of, the mapping that we have done, and you can see quarterly there is a huge change. That is the uniqueness of the tropical waters. Next, please. I mean, another form of the data. Next. So this is something I would like to draw your attention. The automated identification system that you have, which gives you details of the shipping traffic and also the details of the ship, that has been used. Online, that data is fed to an algorithm that gives you the noise that each of the ship is making. I mean, we have divided the entire area into small grids of 1 lat long, and it can be scaled up or scaled down. And that data is then, or that radiated noise at source is then passed through the underwater channel. So another algorithm generates the real-time underwater channel condition at that time and how this data passing through the underwater channel will behave, and this is the map that you get. You can see what will be the underwater, low frequency underwater noise. This is below 1 kilohertz. And this will give you a sense of what is the noise underwater at a particular instant. This is for 100 hertz, but this can be done for the entire spectrum up to 1000 hertz. But what is important is that what do you make of this map? From a conservation perspective, you can see on the west coast there is huge noise. This is almost 30 dB from the dark blue to dark red. You can see the scale on the right side. Now, what does this give you? From a conservation perspective, of course, you will have marine mammal stranding in our west coast, right? But this is also, so this won us a global innovation challenge for conservation. We were invited to France, and based on this paper, it went to IMO and we've got some recognition. But the same thing what we have done is also used it for any underwater deployment. Electronic students will know signal to noise ratio, right? If you know the noise, what is your signal, you can build up the SNR. And now you know if you deploy any underwater system, whether it is a submarine or whatever, you know where you should be deployed. And we have taken it further to even do the detection capability assessment and also the vulnerability assessment of this platform. So, I mean, very basic thing can be mapped on to a very different level. Just all that you need is real-time data coming online, which is possible in today's world. The computational ability that we have allows you to do this. Next, please. And this has been done in the 3D, not on the surface alone. Next, please. Now, another thing is something, I mean, I can give you a lot of examples, but I'll just stop with this. Snapping shrimp is one very unique creature that we have in the tropical waters. They produce sound of the order of 200 dB, reference 1 micropascal. The biggest mammal on earth, the blue whale, generates 196 dB. The whales are in single digits, snapping shrimps are in millions. So imagine few million snapping shrimp generating sound. So when we had the first chakra that came to India in 1988, when it was deployed, the entire sonar screen got blanked out. They did a brainstorming and one of the master chiefs said, "Sir, blast transmission karenge, theek ho jayega." They did that and of course theek ho gaya tha. But the captain wrote in a blog that this is possibly snapping shrimps. The Scripps Institute of Oceanography in the US, when US was supposed to launch Nautilus in 1952, in 1946, the Scripps Institute of Oceanography in US did a snapping shrimp mapping of the entire world. You imagine in 1946 what was the level of technology, right from designing the transducer to everything they have done. But today you don't need to worry about so many other things. So in their study, they found out that the tropical waters are the habitats of the snapping shrimps. So when I started this Maritime Research Center, we did this as a project. But in the initial stages, we realized that there are 14 subspecies of snapping shrimps in our waters, in the Indian subcontinent. And each of these 14 subspecies have very unique vocalization patterns. So in the next stage, when we went to the soundscape mapping, we had to go into the depth of all the 14 and what are the triggers for them to vocalize. Earlier, me and Sridhar thought it is a 6-month job, we'll do it very quickly. It took us more than 2 years, and with almost, I think, 7 researchers contributing to it. And then we came out with this, and we were very happy that we have cracked it. So you can give an area, if you have to deploy something in an area, you can get what will be the possible noise in that season and that part of the year. So I was discussing with one senior person, and he said, Arnab, what are you doing for the community? So I didn't have an answer. So we converted this whole thing into a shrimp farming tool. Shrimp farming also goes through the same cycle, right? So the entire data can be used, and so we made that, but we didn't get enough investors for that. So somebody said, why don't you convert it to seaweed farming? And we got a very big funding for the seaweed farming tool we did. What I'm trying to say is now we have the larger framework, which can be now taken on to various other species also. So there will be a presentation by Shlok Namami tomorrow, I think. He will talk about this particular tool. And this is a very good tool to connect with the community. Our communities, coastal communities or riverine communities get excluded from the so-called jargon of development that we talk about. But these are the tools, this is their inclusion into the digital transformation. Next, please. So you can see, I mean, I've given some data, some graphs. Next. So this is that, one is the habitat mapping and the second one is the soundscape mapping. Next, please. So typically my last 2 slides, for acoustic capacity and capability building, outreach, engage, sustain. Outreach is some such workshops where we interact, we try to convert you, if you are not converted already. And once that is done, then we get into a little more specific engagement with you. What can we do for you? Where can we collaborate? And this is also for young students. How can they be part of it? We offer internships and fellowships. They can join us for an internship. If they feel this is interesting, they can even graduate to becoming a fellow and build a career in this. I can assure you one of our students has gone to Carnegie Mellon. She didn't come from an IIT, but many of our BITS Pilani and IIT students have gone for their PhD to the Ivy League universities all over. And of course, in the sustained part, now we are engaging with the government at multiple levels, Niti Aayog, NSA and various other government agencies, and we are working with them for a larger policy change, for a larger technology intervention. Ministry of Earth Sciences has been very kind to us. They have given some projects to us. And now that is where we will be able to make a sustainable change, bringing certain specific interventions, right? And we are working towards setting up a center of excellence where we'll have 5 centers. Next, please. So a center of excellence will have these 5 centers, a research center, which will be a multidisciplinary, truly multidisciplinary research center, incubation center, skilling center, academic center, and a strategy center. We have more than 10 courses which have been approved by AICT. So we are in a position to run them. Skilling also has been approved, and we already have set up a skilling center. So this workshop is part of the skilling ecosystem. In Koregaon, Bhima, we have a center. We will be initiating our UDS summer school this time from our own center. We have done it thrice before, but UDS summer school, this time we'll be doing it in ours. Earlier we have done in collaboration with Pune University and Mumbai University, but this time we'll be doing it in our own center. And you'll get a flavor of exposure to the field. And of course, we are working on multiple policy. We have contributed to certain national policy initiatives also. Next, please. Thank you. So I'll request Satheesh Shenoy sir to kindly make his presentation. Dr. Satheesh Shenoy sir is joining us from Hyderabad. He has been instrumental in the entire digital ocean framework for the Government of India. He was Director NIOT Chennai. Later on, he took over as director in COIS, Indian National Center for Ocean Information Services. And Sir has been instrumental in a lot of technology initiatives, lot of collaboration with global organization, and now Sir is emeritus professor at the Ministry of Earth Sciences. Shenoy sir, thank you so much for joining us. Over to you, sir.
Thank you, Dr. Arnab. Let me first apologize for my inability to join this workshop in person in Pune because of some commitments back in the family here. I am unable to travel right now. However, Dr. Arnab told me to join online, so I am very happy, and I thank the director of MRC as well as the organizing team for giving me an opportunity to be part of this workshop and deliver a keynote address. I don't want to take longer time, and I want to just restrict myself to talk about underwater domain awareness, its importance, and the requirement of acoustic capacity building or training. Because the major purpose of this series of workshops, the workshop series 1 was just concluded last week, and today the second workshop is starting with this session, and then there will be one more workshop as part of this ongoing series, which has been organized by MRC Pune. And let me use this occasion to congratulate MRC Pune for taking up such initiatives, because it is very important that the acoustic capacity or to deal with the acoustics or underwater sound as well as the underwater domain is very limited in the country, and MRC has made a beginning. I am very thankful to MRC for this beginning. Marine domain awareness, which Dr. Arnab spoke in detail, which is defined as anything and everything associated with the maritime domain that could impact the security, safety, economy, or the environment. So when we say these four words, security, which covers the strategic importance, safety, that also not only the safety from the human intervention or the attacks from enemies, it also includes the natural disasters like storm surges or tsunamis, harmful algal blooms, etc., etc. And economy uncovers living as well as non-living wealth which is available in the ocean, and the environment. As you all know that the recent IPCC report further highlights the importance of the oceans in controlling our climate, and how ocean is regulating the ongoing climate change as well as the weather patterns. So ocean cannot be ignored from any of our day-to-day life requirements. So the marine domain awareness is rightfully defined as anything and everything associated with the marine domain has to be understood well, and the capacity has to be developed in that direction. So maritime domain has been defined as all areas and things of or under relating to, adjacent to, or bordering on a sea, ocean, or other navigable waterway, including all maritime related activities, infrastructure, people, cargo, and vessels and other conveyances. I think in that connection, the previous speaker, Dr. Arnab, talked extensively about Brahmaputra river navigation and those kind of aspects. So all this comes under the maritime domain, and because of that, it becomes part of um, maritime domain awareness. In addition to transport of majority of goods, as we know that 90% of the goods have been transported across the oceans or by the ships, because the ships transportation is one of the cheapest and most safest comparatively of the means to transport the goods and material. And they are also used for the export of terror. The best example is our Mumbai attack cases and contraband across the globe. As we read almost every week in the newspapers, the contraband has been confiscated at so and so port or from the so and so ship. So these are becoming larger concerns for a strategical importance as well as for the societal importance itself. The effective MDA thus necessitates proactive and counteractive focused activities in the oceans across the water column and coordinating among all stakeholders. So that is required because it is a vast subject. It spreads to different areas, and it has of interest for several stakeholders. If you look at the India's maritime estate, I call it maritime estate because that's almost part of our country itself. India has a coastline of about 8,100 kilometer, including the islands in Andaman and Nicobar Islands as well as the Lakshmi Islands, and exclusive economic zone of 2.37 million square kilometers. These waters around India are used for transportation, fishing, dumping of industrial waste and sewage, extraction of oil and gas, etc. And ports located along the coastline are the vital hubs for import and export of goods. Thus, they are the vital centers of our economic development itself. And the beaches along the coast are important centers for recreation as well as for several other purposes. And if we look at our offshore oil fields, we have oil fields on the west coast to the Bombay High region, as well as on the east coast. The Krishna Godavari region has deeper oil fields in the offshore region for us, which are of about 2,000 to 3,000 meters deep, compared to the Mumbai offshore wells, which are less than 200 meters. And to extract oil from these kind of deep wells, the technologies have been developed, and we are successfully extracting that oil and natural gas from those basins. In addition to that, it has been estimated that India has a large deposit of gas hydrate. Gas hydrate is nothing but the solidified methane gas, and under cooler conditions, under low temperature and high pressure of the water column, the methane solidifies and gets deposited all along our the shelf region. But the issue is how to extract that gas hydrate or the solidified methane, because once it is taken out, the pressure is really has become less and the temperature increases. Then this methane burns itself. It's a highly inflammable gas, as all of you know. So the technologies are not yet viable or not yet developed so that we can commercially extract this gas hydrate. But one of the estimate or one of the paper which I read some time back, it says that the gas hydrates along the Indian margin is more than 1,500 times the country's current natural gas reserve, and only 10% of production can meet India's energy requirement for 100 years. That's a wonderful statement. That's why I remember that. If all other means of energy sources gets depleted for India, I think we have hope. We have a reserve. Of course, right now we are unable to extract this gas hydrate because of various reasons. But this reserve is, I think, has to be left for our future generation, so that India will not starve for energy, even if all other oil and natural gas as well as other sources of energy gets dried up on the land. In addition to these interests along the in the EZ as well as on the shelf region, we also have interests in the Central Indian Ocean, because there are the India has identified and surveyed these ferromanganese nodule deposits in the Central Indian Ocean basin, and as per the agreement with Seabed Authority of UN, about 0.75 million square uh, kilometers of area in the Central Indian Ocean has been leased to India to demonstrate its exploitation or mining of those nodules. And the National Institute of Ocean Technology is almost there which has developed that technology for the mining. Of course, it is only a demonstrative mining right now, not at the industrial scale. But I think we are doing well even for demonstration, because these nodules are sitting at a depth of about 5,000 meters or 5 kilometers below the water column. And you can imagine kind of the pressure, hydraulic pressure, which has to be withstood by the equipments or the mining equipment to mine these nodules. And also there are a lot of conditions, like you should not disturb the flora and fauna of the region, the environment should not be disturbed, etc., etc. So it is not that easy to go and mine these nodules from the seabed without doing that. So that's a challenge in developing those technologies. So these lease area registered by UN's International Seabed Authority is estimated to contain about 7 million metric tons of manganese, copper, and nickel, and each worth about 1100 billion rupees. So that much wealth we can, if we have a capability to mine those nodules and bring back to the mainland and process them, because the industry is growing, because these metals, manganese, copper, as well as nickel, these are getting depleted from the land resources these days. So the one day it will come that we have to depend on oceans for this manganese and nickel, and having such a reserve with us will do a lot of good for our country. Though right now we are not in the business of mining those those minerals. In future, it will do very good for us. In addition to that, the UN has India has leased the hydrothermal sources, which are along the ridges. Ridges are the regions where the plates move apart, and those are the regions where you will see the mountain chains under the ocean or on the seabed. So such a region in the southwestern Indian Ocean has a lot of these hydrothermal deposits, They are nothing but the mineral deposits or the sulfides, mineral sulfides, various mineral sulfides, which come out from the, because the plates are moving apart, they come out from the Earth's magma and gets solidified and deposited on this in these sulfide deposit areas. In fact, the temperature of those areas are very high, about 300 or 400 degree centigrade. And if you go and look at them more closely, as that one of the panel on the left side shows, they look like chimneys from where the black smoke is coming out, and very high temperature in that region where these sulfide ores are coming out. So there are other scientific questions as well of very interest, because they are again at the depth of about 4,000 to 5,000 meters deep in that region, and the temperature can go as high as 350 degrees centigrade. Uh, and the interesting part is that there is life in that area around these chimneys, and there is no sunlight. So, if there is no sunlight, how the photosynthesis or life supporting process can take place, or there is a chemosynthesis which is supporting the life there, and how that life is surviving in these chimneys. There are some crustaceans and some kind of life which has been recovered from these chimneys. They, how they are sustaining under this high pressure and high temperature, and without sunlight to prepare their food. So these are very interesting scientific questions which some of our people are engaged in finding answers for that. And coming to the marine domain awareness, you cannot use the radio waves in the water, because the radio waves get they are electromagnetic waves, and electromagnetic waves will get quickly absorbed in the water, because water is a conductor, and you cannot pass the radio waves through that, and you cannot use your telephone or such instruments to transmit the sound from or data or sound or whatever it is from one end to other. So only solution is the acoustic waves are the means for underwater communication, because the lidar, for example, lasers have very limited range, less than 70 meters, whereas the sound can travel for hundreds of kilometers, or perhaps even 1,000 kilometers, if there is the sound is propagated through a SOFAR channel. The SOFAR channels are nothing but a natural channel which gets formed in the sea or the ocean, because of the way the temperature and salinity in that region is structured. So if that structure favors the formation of a SOFAR channel, you can you can transmit the sound well over 100 or 1,000 kilometers, and you can listen from one end to other in the SOFAR channels. So that, but beyond the SOFAR channels, it will be a shadow region, like when we drive our vehicles. If there is a vehicle very close to you, you will not see neither in your rear view mirror nor in the side mirrors, unless you just slightly turn your head and see that vehicle. You will make a lot of mistake. So similarly, there are beyond these SOFA channels, these are all shadow channels, and a enemy want to hide in the ocean, and if he knows how the sound structure of that region is behaving, then he can hide such a way that he will not get detected so easily. So that's the challenge in this area. So considering the complexity of underwater acoustics, interdisciplinary expertise is required to deal with that and to take advantage of marine domain awareness for economical, strategical, and defense purposes. So the capacity building in underwater communication, monitoring, and scanning is the only way out. So unless we develop the interdisciplinary capacity to handle this complex situation of some marine domain awareness, awareness, and the factors involved in that, unless we develop our capacity, I don't think we can make much headway in that. Though the institutes like IIT Kharagpur, National Institute of Acoustics in Thrissur in Kerala, National Institute of Film and Fine Arts in Kolkata, the Film School Mumbai, Department of Music, University of Mumbai, Sri Aurobindo Center for Arts and Communication, School of Arts, New Delhi, etc., are offering engineering courses in sound engineering. The institutions that offer courses or conduct research in underwater acoustics are very, very rare in India. So we have several departments and institutions. There are fine; these are all very fine institutions. They are offering courses in how to deal with the acoustics of a stadium, acoustics of a auditorium, acoustics of different types of fine arts, etc., etc. We don't have a dedicated institute or the institutions which are offering courses or conducting research in underwater acoustics in India, except a few institutions like National Institute of Ocean Technology, Chennai, and IIT Madras. They conduct research and occasional training courses in ocean acoustics observations and modeling. Other than that, there are no regular courses where one can do a MTech course or do even regular PhD research in this area in our institutes. So IIT Madras had offered a MTech course in solid state technology with underwater transducer technology, because that was a sponsored course by DRDO, that was during 1980 to 1994, which has been discontinued after that due to maybe some other reasons. I have no idea about that. But right now, no such MTech course is existing in IIT Madras. And IIT Delhi Center for Advanced Research in Electronics is carrying out R&D in acoustic signal processing. So there is some limited activity which is going on at IIT Delhi. And Naval Physical and Oceanographic Laboratory, NPOL, Kochi, conducts extensive research on sonars, sound propagation and attenuation at sea, observations and modeling. Perhaps that is the only national institute right now which is concentrating more on, because of their requirement, because for the defense purposes, the sound propagation is very, very important. So perhaps because of that reason, I must say that that's the only national institute which is extensively engaged in research on sonars, which are equipments which use the sound propagation and reception and other means. So they have developed the hull-mounted sonars for ships and submarines, towed array sonars, and airborne sonars developed by them are being used extensively for naval applications, and they are carrying with their research to improve their capabilities as well as their designs. The other institute after NPOL that comes to my mind is Maritime Research Center, or MRC Pune. That, though it is not a national center, it's a non-governmental center. That also does extensive research and training in underwater acoustics, especially the underwater noise. If I, as per my earlier interactions with Dr. Arnab, what I understand is MRC is more concentrating on deciphering underwater noise and making sense out of that noise. Maybe right now MRC has taken up several other aspects as well. NIOT Chennai, they have developed a system called BOSE, or Buried Object um, Buried Object Detection Sonar. That has underwent several successful sea trials in terms of its operability, detection, etc. And as I understand right now, it has been the technology has been transferred to some of the private industry, and they are manufacturing, or they'll soon manufacture this for several applications, not only for naval applications, even for other civilian applications like searching something buried at the seabed, etc. And NPOL Kochi has developed several technologies and products like 3G underwater acoustic communication system, what they call UVACs, to communicate between submerged and surface platforms. Near field acoustic characterization system NACS to determine the in situ performance of sonar systems, etc. And these systems, they are not available for civilian use right now, as if I am not wrong. They are mainly developed for the naval applications, and these systems are being developed, are being manufactured, and right now used for our naval applications. Maybe they may even choose to export them to other countries for the naval applications. So the application of underwater acoustics is also important for the survey and exploration of ocean bottom to detect and characterize the geophysical features, mineral deposits, fish stocks, noise pollution of the oceans, etc. Because as you know that the sonars and side bottom scanners, etc., they are the tools which are operating on sound waves, which are used for geophysical surveys, as well as the ocean mineral deposit survey, as well as for sonars are used for fish stocks, to determine how much fish stock is available, etc., etc. And the commercial activities like precise drilling of oil wells, underwater recreation, diving, shipwreck hunt, etc., need precise inputs from underwater acoustics for survey and communication. I not only for survey and communication, they are also required to fix, for example, if you are engaged in oil drilling, and you have made a hole there, and if you had to re-enter that hole, precise determination of its location is very important. So even for determining the location or pinpoint the location, these acoustic transducers are used extensively for such purposes. So thus it is necessary to expand the awareness of underwater domain to such a level to know what is happening in the undersea realm of our maritime areas, especially from the security perspective, defending our sea lines of communication, coastal waters, and varied maritime assets against the proliferation of submarines and mine capabilities intended to limit the access to the seas and littoral waters. So the challenges in the underwater domain are vast. It is one side, it is economic interest. Second is for the communication purposes, and the third is the more important is for the strategic purpose itself. Underwater domain awareness is uh, uh, required for every purpose, from scientific research to economic explorations, as well as for the strategic importance of the country. If you look at the Dr. Arnab also displayed a similar map which shows the dense commercial shipping going through this our Indian Ocean, and the those red and yellow shows more dense passage of ships in the along the shipping routes, and the blue are showing the lesser density shipping routes, and this is growing day by day, because more and more goods, oil, as well as the bulk cargo, etc., are being transported through the by the ship route. And in addition to that, the growing naval presence in the Indian Ocean, especially the China and US and other countries, their naval presence also is increasing in the Indian Ocean uh, day by day. So the need for underwater monitoring of acoustics, modeling of underwater acoustics, and development of underwater communication are not only necessary, it is unavoidable now. So it is, if we don't do that, we can get caught unaware. So we have to give a huge push for the development of capacity in this area of underwater acoustics. So NIOT has developed the capabilities to monitor the ambient noise, or whatever we call ambient sound, including the sound of the marine mammals. I don't know whether this will play. Let me try, because they have recorded the sound of a whale, hunchback whale, which is part of the ambient noise. The challenge is that there are several sources of sound in the ocean, from the mammals to the ships, then the naval ships, etc., etc. So how you will detect the noise from the naval ships, and how you can filter that noise? That is the biggest challenge. Then only you can use this acoustic tool to analyze the sound. Whatever, if you put your ears down on the ocean, whatever sound you are hearing, and from there you have to filter out and listen. As I understand, though I don't have greater details on this project, as I understand, DRDO has initiated a large project for continuously monitoring the sound and the environmental variables like temperature, salinity, wind, humidity, etc., on a continuous scale in the Indian Ocean region, or at least the waters of interest for our Navy, and recognize the sound spectrum through data analysis, and develop a modeling system that will enable the detection of unwelcomed sources of sound and the unwanted objects. Unwelcomed sources means the if a enemy ship enters our region, we should be able to detect that without the enemy knows we are listening, and we are following them, and detecting these underwater vehicles. These days, the gliders, which can navigate without making any sound, and like drones. So gliders are nothing but the underwater drones. They can cause several damages. So that kind of objects, unwanted objects, we should be able to detect, and take necessary actions, either to capture them or to destroy them. So for that, the underwater acoustics and its knowledge plays greater role. So we can expand our monitoring capabilities. We can use the existing platform itself. This map shows the data buoys which have been deployed by National Institute of Ocean Technology under the Ministry of Earth Sciences. We have several data buoys, so we can attach with little modifications in the technology. we can attach the sound sensors to detect the acoustics in the waters around India and utilize those platforms. These platforms we can use and make the continuous measurement. As I understand, I think the NPOIL is going to make use of these existing platforms, as well as maybe they may deploy few extra depending on their interest to for continuously monitoring the environmental variables as well as the marine acoustics. In 2015, Prime Minister of India gave a strategic vision stating, we seek a future for Indian Ocean that lives up to the name of Sagar. Sagar is security and growth for all in the region. That is what our vision is, that we should be secure and we should be able to grow economically as well as in terms of human development index. We should and environmental safety, etc., etc. So that represents Sagar, and PM has given a lot of backing for this vision, that the ocean research as well as the all activities utilizing the ocean should grow sustainably, and we should take advantage of the seas around us. To achieve that vision, to ensure security of seas, to ensure the sustainable management of resources, and for the sustainable development of the Indian Ocean, it is necessary to invest heavily in enhancing the marine domain awareness through continuous monitoring, regulating the activities through research and capacity development. To start with, initiating master's and PhD level courses in a dozen universities institutions in marine acoustics, underwater communication, sensor technology, etc., will help in tying up with the minimum requirement of expertise for reasonable enhancement of marine domain awareness. I think we should think in those lines, that we will initiate certain marine the masters programs, MTech and or MS programs in the universities, and also encourage the PhD level research in that. I think in that context, the training workshops organized by MRC, though it will not solve the entire issue, at least this beginning made by MRC, especially for IORA countries, towards the capacity building by engaging the international expertise in ocean acoustics and related fields, deserves appreciation and compliments and support. So I really appreciate the efforts of MRC in grossly promoting the capacity in this direction. Though this is only a beginning, and this is no way going to replace the requirements of masters and PhD programs in the country, but some noble beginning has been made, and that deserves appreciation. Thank you.
Thank you so much, sir. Really appreciate your presentation to bring us to a level where we can appreciate the larger dynamics of the acoustic capacity building. Thank you very much, sir. Now I'll request Lakshmi Krishnakumar to kindly come on stage.
So hello everyone. I'm going to take you back a few centuries, if that's okay. And this is not exactly what is underwater, but has a lot to do with sound. So let me just begin with this, and the next slide, please. Okay. So spot the difference. I'm just kidding. That's not what it is. So that is one education style, and this is another education style. So I tend to be moving. So that is the first one you saw was the style of education, and this is another style of education. So what is the difference? One is showing it as something that is wholesome, which, the earlier slide, please. So where, there's a lot happening around that tree. It's not just a single tree. There's water, there's light, there's fruits, then there's habitat around it, and then the next is just the tree. So this is the education style we have inherited from the colonial rule. That is sort of specialization and looking at just the one thing, and there's no interconnectedness. So we can go to quantum physics, which talks about interconnectedness, but let's go back to our ancients. I'm calling the literature from ancient India and the writers as ancients for now. And we'll also be looking at Shakespeare literature. I'm a Shakespeare scholar, so I can't leave Shakespeare behind, I'm sorry. So let's go with the next one. Okay, science in art. So is there science in art? No? Yes? Yes? Okay. Any poets here? Even if you've written one poem? No? Okay. Is poetry not for you? Okay, let's go ahead. Is there science in art? That is a question. That is Shakespeare. Next, over there. So what is literature, according to you? Just one bit of art. What is literature? Is it just these phrases that is very commonly used, and these beautiful phrases, a lot of imagery over here, like wild goose chase, wear my heart upon my sleeve, all that glitters is not gold. These are very, very familiar, very well-known quotes. Thank you. Also given by, this is on, right? Also, these are all Shakespeare's quotes, and we use it in our daily life. Sorry about this, I keep moving. So yeah, so these, or again, is there, we can go forward. Is there science in Shakespeare's work? Next slide. So is there science in Shakespeare's work? So let's see. Next slide, please. So, oh yes, there is. That's a heart beating. So is it biology? No. So Shakespeare wrote in what is called the iambic pentameter, which is 5 beats, heartbeats. Da-dum, 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 da-dum. So he wrote in 5 heartbeats, and that is called iambic pentameter. So that is a bit of science, but still not science enough, I suppose. Next. Closer. It's, okay, then maybe I'll try and stand here. Okay, so next slide, please. So beat and rhythm. So what is beat and what is rhythm? Anybody? Musicians would want to say anything? There's a difference. So a beat is a regular and steady pulsation. And you feel that. So you would be listening to music and you would know that beat continues till the end of the song. But a rhythm would be different, and it'll change, but the beat will stay constant. And so the monotony is cut with the rhythm. So that is how beat and rhythm are different. And next, please. So this is an example of iambic pentameter we were talking about, Shakespeare's. So Romeo and Juliet is Shakespeare's well-known play. And this is Juliet and Romeo, their conversation when they're meeting for the first time. And this is part of a whole sonnet, just the 2 lines. So that, can you see, I have marked da-dum, da-dum, da-dum underneath, as those are the 10 syllables So I, pill, that will be a unstressed syllable and stressed syllable. So that will go up to 10 syllables. And then the heartbeat would be 5. That is why it is iambic pentameter. So that's that. Next. So when it comes to Western or English metrical scale, it is periodic in nature. It's always stressed, unstressed, or unstressed, or stressed. It's always periodic. There are no surprises. It's always going to be one of those. And periodic, this is it. And now let's look at the metrical template of our ancients. So this is how it is. It's quite complex, but extremely sophisticated. So it has what is called monomoraic or laghu, which is short, but it's marked with L because L, so short, and then bimoraic or dirgha, which is long, and that is marked with D. So henceforth, you will be looking at a lot of L's and D's. So it is short and long syllables. And then there would be periodicity and aperiodicity. And this is the ancient metric templates. So next one, yeah. How do the poets of ancient India compose? Now, they did that orally. So Sanskrit, as we have it today, it was an undesired form. It was not supposed to be a written form. We have it as a written form much later. So it wasn't supposed to be written. So that is why it is extremely sophisticated, because it had to be passed down to people without people making errors. So it was passed in terms of beats and in terms of the number of syllabic rhythms. So we know what is beats and what is rhythm by now. And going forward, so this is beats in poetry. This is how it is supposed to be done. This is mathematics. Write the numbers 1 and 2, and each subsequent number is the sum of the previous 2. Anything rings a bell? Anyone? What this is? Okay, next slide, please. The nth number gives the number of the possible ways of short and long. No, next slide, please. So here, so 1, 2, and 3 is 2 plus 1, 5 is 2 plus 3, 8 is 5 plus 3, and it goes on. What is this? Do you know what it is? It's called Fibonacci numbers. But this existed in India 100 years before the Fibonacci numbers, and this was by Hemachandra, who's a poet. So do you see science and art? So he wrote it for poetry, but this is sophisticated maths, and this is Hemachandra numbers, but in India, we still continue with the Western style education, and so we learn maths in a different way. So art and science seems very far apart, and this is what it is, Fibonacci numbers or Hemachandra numbers. Next, please. Yeah, so Shakespeare's blank verse, iambic pentameter is also known as blank verse. So now let us apply this maths to Shakespeare's verse. So if n is equal to 5, then the moire of Shakespeare's iambic pentameter is 8, because that is the position and 8 is the number derived from that. So that is 5 dadams. So if we apply the Indian metric style to that, that is an example. And here's something for you. So are you aware of Professor Manjul Bhargava? He won the Fields Medal in mathematics. So that is the Nobel equivalent of mathematics. And he did not like maths the way it was taught in schools. He spent more time, his grandparents lived in Rajasthan. So he spent more time in India, and he was taken to maths because of how it was understood. And so daisies, if you look at daisies, this is nature. Now, nature and art, daisies always have petals in Hemachandra numbers. So this, next one, yeah. So this daisy, if you count, I have counted, it has 21 petals. So it is all daisies will always have Hemachandra number of petals. So that. Now, we are moving from that to syllabic rhythm. So how do we calculate that? This is not the same n, this is a different n. So 2 to the power of n. This is the syllabic rhythm. How do you get the syllabic rhythm? So n is equal to 10. So then what is that? That is 1024. So if Shakespeare's the syllabic rhythm would be 2 to the power of 10 because it is iambic pentameter, syllables 10 syllables, and therefore it could be written in 1024 ways. That is what the ancients found. So going forward, this is what it looks like. And anybody, what this could be? It is there on the sheet of paper for you to look at. This is Pingala's Meru Prastaram, or Pascal's triangle. Again, we know it is Pascal's triangle, but this is older. So this also mathematics, but it came out of poetry. So there is science in art. Okay, going forward. I know, I have said it enough. Now go on. So this is I think it is there. I won't spend a lot of time around this. This is again trying it on Shakespeare's text, how it will be and what are the possible ways that could be written. Next, please. Well, okay, now why did ancients use metrical templates? So these were, like I said, these were orally transmitted. And Panini, a grammarian, he used to call people who wrote down anything, which was later on, he did not approve of that. He said everything had to be transmitted orally. That is a more sophisticated way to do it. And if you wrote it down, what we would call an illiterate, that is what he calls likhita pathaka. You're someone who can read and write. How stupid is that? So we say, you can't read and write, you're an illiterate. So this is what it was. Look at the contradiction. So that is where we are today. But I think we'll be getting into a world of sound again, because sometimes when I spend time with my nieces, you know, they say, oh, come, I'm going to show you how to dance. And these are little girls. And I'm thinking, okay, they take my phone, they open YouTube, then they want to start putting these songs. They don't type. They use voice assisting. So they name the song, and then that's on. And I'm thinking, my goodness, they don't need to read and write. So there is a way out. Sanskrit, the language. Now, this is now, you know, the way we are today, we need approval by a white man. So the white man said so. So now we can believe it, maybe. So he's a linguist and an Indologist, William Jones. He finds Sanskrit way more sophisticated. He says it is more perfect than the Greek, more copious than the Latin, and more exquisitely refined than either. So there it is. So he has said it. So maybe it is important now. And then, so the oral factor. Now, this is a quote by, I can say, my guru, Professor Vishwanathan, who's a Sanskrit scholar. So who talks about the effect of sound itself. Why is sound so important? And he talks about how it has become very ritualistic and part of religion, which was not the purpose. So this is not religious. And it has got to do with the sound and the impact it has on us, people. So sound is very, very important. And like we know with certain frequencies and how sound is used, glass break, we've seen that. So how it affects us as well, sound. So this is where that is. He talks about it, and now it's just become something else. We mispronounce it, we don't take it properly, and it's gone to another realm altogether. Next, please. So this is Now again, coming to the Sanskrit text, this is from Meghadutam by Kalidasa. And this is the first line of the poem. And this is called Mandakranta meter. Now, Mandakranta and Meghadutam is to say that the clouds were slow and speedy. So it could be both. So that is why it is called Mandakranta, and this is what he created. And all the 120 stanzas had the same meter. That is what was used. And again, Shakuntalam, in his plays, again, William Monnier, who's translated that to English in Shakuntalam, he says within the first 24 lines of the play, 11 metrical templates were used. And he regretted that he couldn't translate the prosody, but he could only do the literal translation of it. So there's a lot that is there in the literature as well, and also there's a lot of science there. Next, please. Okay, now let's get into technology, because this is about technology. There's error detection code and error correction codes, which we talk about. And you will find this in our poetry, in the verses, because these had to be given down, passed down, and it had to reach us. So how would they do it hundreds of years ago to make sure that it got to us correctly? So in Shakespeare's text, we could perhaps find error detection code, because iambic pentameter, if there are lots of discussions around Shakespeare's text, because these were not texts given by Shakespeare, these were produced by printing people, and this could be memorial reconstructions, this could be, sometimes the missing line could be an error made at printing houses. So we can maximum go and say, oh, there is a mistake here, but what is the correct word used and how can it be corrected, or what is wrong? We can't know. But here, not only can we detect, we can also correct the error if it is passed down wrong, and a Sanskrit scholar would say, oh, this is wrong, I know what to do, this is how it can be corrected. So mnemonics were invented, and this is Yamata Raja Bhanasalaga. This is the mnemonic. Mnemonics are, the short forms or things that we use, so we remember something. We memorize, that is, oh, this is what it is going to be. So this is how it was. And now I'm just going to, I've given values here. Ya is short, so that is laghu, like we discussed then. So L, and ma is long, so that is dirgha, long. So 2 is the value assigned. So like that, these are the value assigned to each of these. Next, please. Yes. Now this is, so if we say ya, then the combination would be 1, 2, 2. So because it is the first 3 sequence, all the sequence, first 3, then the next 3, and 3 like that. So ya would be 1, 2, 2, ma would be 2, 2, 2, and so on and so forth. Okay. Now the next one. Now let us look at a code, how it is used. It says bhujanga prayatam chaturbhirya kare. Okay, now it means the gait of a cobra is 4 times ya. So bhir ya kare. So the gait of the cobra, the movement of the cobra, you can see there are 4 curves. It doesn't have to be always 4 curves. It depends on how long or short the snake is. So, but here, I'm just giving an example, but bhujanga prayata is a meter. Now, when a poet gets, or a scholar gets a bhujanga prayata meter, and something is wrong, he'll know exactly what is wrong, because this itself dictates what is correct. So, the next one, please. So the quadruplets of ya was that. And now this is all another one altogether. This is a linear snake which has all the mnemonic on it from 1 to 10. And this snake itself has a name. It's called Sakala. It is called everything. And it has a lot to do with philosophy, which if you want, you can go and read. Let's go to the next one, please. And here, the Sakala snake also curves itself into a wheel-like chakra, which is actually reminding of Kala, time, going round and round. But here, when it does that, the whole dial becomes again in sets of 3, because the 1, 2 is swallowed by the snake. So it is exactly the dial that we were talking about. So this is the Sakala snake and a bit of science. Now, what I have done is, as part of my research, I was trying to fit in Shakespeare's text. Just a minute. I was fitting Shakespeare's text, and then we couldn't fit that in verse, but only when it is sung we could use it, because then you have the liberty to make some of the vowels longer. So that is what it is, and you can listen to this. And the lines are on the last page. It is from Shakespeare's play, Cymbeline.
Hark, hark, the lark at heaven's gate sings, and Phoebus' gleams arise. He steeds to water at those springs on choice flowers that lies. And winking merry birds begin to open their golden with everything that pretty my lady sweet, arise, arise, arise.
So that was set to classical raga, Indian classical raga, and it was Yaman, and it was actually done by my friends who wouldn't actually agree to do anything like this, but I had to pester them, and it was by Abhay Sopori, the very well-known Santur artist and one of the best we have in the country, and a friend Aman Nath. So that is what you listen to. And next slide, please. Could you please answer? They are one. So we're not talking about equality. Equality, we can talk about gender, male, female, equality. But here the question is not even equality. It is oneness. That is what the trust that I run, called O, we really are pitching to get that across as art and science as one, and not as two opposite ends of a spectrum. So that is that. So let's go back to our Indian education style, which is this. So thank you very much for listening to me. Thank you.
Thank you, Lakshmi. I don't want to even try and summarize. I'll take away. I think Ashish sir is going to speak after me, and he is going to definitely throw more light on the whole connection between mathematics and science and art. Kishore Mandya sir, I'll request you to come forward, and we have introduce you in the morning, but I would still like you to speak about a little bit about your journey. And we would like you to talk about the larger global context. UN is at the forefront, sustainable development, but the role that underwater plays there. Thank you, sir.
What can I say, actually, after such rich presentations? Dr. Shenoy gave us a broad traverse of the underwater domain and all the implications, both scientific and policy-oriented, which are under consideration. And then we had this wonderful interdisciplinary, multidisciplinary traversing the three great realms of knowledge which any university should help us to understand: the physical sciences, the social sciences, and the arts and the humanities. And I think there is a fundamental question when you pointed out that how do we return back to this notion of oneness of art and science, and whatever is in between we might call craft. I think we are born as children where we don't make that separation, because a child is pure intelligence. But somehow the notion of becoming analytical breaks our inner being into silos and segments. And I think for those who reach that threshold which you have in your presentation, you bring together and try to return to the early notion of that wholesome stream with trees and with flowers and with fruits and with life buzzing around it, rather than one symbol which tries to give an idea but really loses the whole picture. And I think that is the challenge you face in the undersea water domain. We can have tremendous discussions on policy, on technology, which is this panel, and then the subsequent panel on human resource development, skill development, and notions of community involvement. I mean, very frankly, I'm just about to embark on a Bharat Parikrama, driving about 30,000 kilometers in 2 days along the edge of India, the coast in the peninsula, both the east and west up to Kanyakumari, and then go around the borders of Bangladesh, Myanmar, and then the entire Himalayan arc up to Kashmir, through the trans-Himalayan states, and then come down through the desert borders, and of course Punjab. I've done this before. I've done the inside of India, the heartland, and now I'm just doing the skin. So I've gone through the organs, but I'm doing the skin. And I want to understand India. And I've done the whole world like this, whether it's the loop of Australia, I just finished last month, Europe end-to-end, United States of America, Brazil, Argentina. I do it with my daughters, because that's the only legacy I can leave them. That how the oneness of the world has broken down. Having worked with the United Nations, I felt liberated when I left the Indian Administrative Service. Because the notion of a country, the notion of borders, I never understood it. Basically segments you and destroys that oneness. And when I saw that blue flag, that my idea was not to serve one citizenship, but to become a global citizen and transcend borders, I felt liberated. I was 39 when I did it. Before that, I was doing other things. And I think if you are thinking of creating love for the sea, love for the world, we have to start with the notion of how do I love the sea and how do I break these borders? Because then you return to that oneness which you're talking about. And these days, if I may say so, we are in a competition to show that the white man is nothing. We were only exploited by the white man. And we were somehow the greatest ancients. And that creates another dichotomy, because we are creating a competition. Our search for excellence should be based upon the intrinsic search for the truth, not the truth compared to the West or the East or our own truths or competing truths. So I think we have to go within and discover what is the methodology to find that truth. Now for me, the love for the sea, I'm actually departing from the text which I wrote, so because your presentation really is so wholesome, so beautiful. I mean, it's the quest of my life, my children's life, is to find that truth, not a career, not an ambition, that you do to make a few $100, to build a house and be happy. But how do you create purpose in life? So I was thinking about it while driving up from Bombay, that how did I first come to love the sea? I came to love the sea when my dad used to beat me up for doing something wrong. We stay on Marine Drive. And I would disappear after he's beaten me. And I would go and walk across, sit on the edge on the tetrapod, and talk to the sea and the rocks. And that came from a very interesting exposure. On our lane, in our lane, there are 2 Jain temples. And the Jain monks every morning would come out and with their brooms sweep. And I would ask my mother, why are they doing this? They would wear these masks. They say, they don't want to swallow germs to minimize violence, etc., etc. I said, that's fantastic. So I can talk to stones and I can talk to the rocks, because you all don't talk to me, you all beat me up. And I'll tell you, it was fantastic. And my friends, sometimes we would collect when we were in college with our girlfriends from Jain College on A Road. And we were at that time into this whole thing, because one of my friends, Rajiv, he's in Colorado right now. His father had a great library on black magic and white magic and philosophy. I never understood it. I mean, I was a physics student. But I would go and look at these books, and he would say that, you will never understand this. If humankind put as much money into the understanding of magic, they would discover so much more than they would have put into the understanding of science. Because there are things which we will never understand. And if we systematically appreciate that, you will discover. So I sit on those rocks. I talk to them. And then I imagine what's at the other end. It is Kuwait, it is Saudi Arabia, it is Yemen, it is Aden, it is the Persian Gulf. And then it evokes in me this concept of oneness. I go to school, we are analyzing, we are deconstructing, we are identifying parts, we are reasoning, which has to be done. We are comparing. We are through inductive logic and deductive logic, trying to come down from propositions to outcomes and from empirical understanding to build propositions upwards. It's a great exercise. But if you do it habitually, it segments you. So the question is, how do you create interdisciplinarity? How do you create multidisciplinarity in life? And therefore, in the pursuit of purpose and in your professions and in problem solving. And I don't think there's a simple answer to it, because I think you're deeply embedded in a way of thinking which we have to begin to transcend. So then I asked myself, yes, that love of the sea came from that exposure. But then it also came because I loved sailing. There was a little club, Bombay Sailing Club. You get into a small little boat which is not machine powered, not technology driven. In a way, on a technology panel, I'm taking a position of a Luddite. Okay? But what you began to understand is when you go in this little sailboat, a Lightning or a, I forget the slightly bigger one, just sailed it the other day, but it'll come to me, is that there are three elements that you are actually manipulating. You have the wind coming through these high buildings on Colaba, creating funnel effects. You have land and sea breezes. You have currents, and you have tides. You have the tiller, and you have the wind sometimes coming from this direction and from that direction. And it's a great feeling because you're becoming one with the elements. Okay? And then you come upon some beautiful books with a great teacher, Flora Gonzalez. But that's chance. What are those books? The best book written on environmental science, Rachel Carson's Silent Spring. The most beautiful book written on the sea by her, called The Edge of the Sea, What Happens in the Intertidal Basin, from high tide to low tide. Her other wonderful book, The Sea Around Us. It's both a work of literature, it's a work of science, it is art and science coming together. The best of things are always that, without even making an effort. So I was overjoyed, actually, to see it today. I'm telling you. So you do that. I grew up, I joined the Royal Bombay Yacht Club, where the elite of India comes, where the boats of the top corporate honchos are parked. And then I begin to learn. They have yachts, but they don't sail. I begin to learn that we have 1,200 members in the club, the who's who of India. Only 35 use the sailing club. The rest come to eat. So technology becomes a product for these people. You buy a new cell phone, you upgrade, you get a Rolex watch, you get a car, you get all the technologies which have been talked about here, but they are never utilized, they are never internalized. Of course, they are there in the West, which created many of these systems. But somehow they have come to create a technological culture. What do I mean by that? My brother is married to an Irish woman. They are now in America. And her father was chairman of Carrier Air Conditioners, the largest air conditioning company. Now, when we were in the United States, or whenever we go, he passed away recently, if his car got punctured, this 91-year-old man would get under the wheel and change the tires. He wouldn't call AAA, the American Automobile Association, come and repair my tire. You go and have a coffee in the Dunkin' Donuts on the highway. He would do it himself. His daughter Susan, my brother's wife, exactly the same. What would I and my brother do? We would call AAA and say, come and repair. We would not get under the wheel. If it happens over here, ask the driver to do it. Or if I'm on the wheel, again, WIA, Western India Automobile Association. I am completely a broken human being in that respect. I use the technology, but I have no respect for it. And this happens across the class line. So how can I become one with that technology to create the interface between policy and human resources? How can I? That is the issue that we have before us. How do I create love for the sea before I can master the sea? Now, if you read Moby Dick, is there a novel in India which has been written for the love of the sea? No. If you read Samuel Taylor Coleridge on the poems of the sea, it doesn't exist. 8,000 kilometers of sea law. There is no swimming culture. There is no sailing culture. We have coastal zone regimes which have been watered down and diluted as we speak, and we talk about restoration and rehabilitation. We have this domain of almost 2.7 million square kilometers, a country by itself, 2/3 of our actual landmass. And today, if you want to buy a pamphlet in Bombay, and you ask the guy in Satpati, in Palghar, either place, in Sasundok, and ye machi kahan se aati hai? Sahab, almost at the edge of our territorial seas, if you want to buy anything decent. So, in many ways, your country is destroyed. My country is destroyed. Okay? And unless you create that love, you cannot apply the science. Because you have objectified nature for your subjective consumption. The domain just becomes the scope for development, which must be there. Development in a bottom line sense means livelihood and job, which is essential for life. But if something exists which you want to sustain yourself, you must, in all good ecology, make it reproducible in a way that it is efficient, equitable, and ecological. And that integrated form of thinking, which had existed with our ancients, does not exist. There's not a single multidisciplinary, interdisciplinary university that exists in this country. Ashoka and Jindal have just come out. In the IITs, excuse me, you get a module along with your science subjects to do, just to show that you did logic one semester, you did literature another semester, and unfortunately, that creates intelligent idiots. Because you have the vocabulary of that discipline, but you don't have the grammar. And because you have a legitimacy on account of your main degree, you will wax eloquent and bullshit on almost anything. Because in the Indian knowledge system today, if you have an IIT degree, you're brilliant. But you're brilliant only in aeronautical engineering. But just because you did one course in logic, that's very dangerous, because little knowledge is dangerous. It is better to be zero, because when you're zero, you can be infinity. But when you mark yourself 6, 7, then you are in dangerous land. So I think as part of the courses that we do, we need to reflect on the things of the unity of art and science, the oneness. It's only when you're able to do that. I mean, today, when you look at actually what's being produced under the name of science in India, it is shocking. In the citation of peer-reviewed journals, I think we are 2038. Singapore is ahead of you, Croatia is ahead of you, everyone is ahead of you. In the top technological universities, maybe IIT Bombay and one or two others come up. China has 11, and they only started 30, 40 years ago. China has set aside $1 billion fund for people to study English if they want to go to Harvard and study. While they're also trying to maintain their domestic systems and ancient systems. Because in different ages, different knowledge systems become dominant. You don't have to reject them. You have to develop on them. You have to integrate them with your own knowledge system. Now the Hindujas have opened at Columbia the East-West research, medical research system. The mind-body connect in medicine. That's great. But you cannot be locked that I was greater than them, but they conquered me, and therefore now I have to go back and recover my past. Of course, you must recover your past. You must be proud of it. But you have to go beyond it. You have to transcend it. You have to transcend it. Why do I say this? I spent 9 years in peacekeeping in Europe in a situation similar to Ukraine as part of the United Nations peacekeeping system to prevent the dissolution of ex-Yugoslavia. And then you had Croatia, Kosovo, Slovenia, Montenegro, Serbia, Bosnia and Herzegovina emerge. Now, it's very interesting. A lot of my translators were local people. Two of my translators, who were actually translators earlier of Tito, the president of Yugoslavia, and their children, younger, of President Mesic of Croatia, had PhDs in Sanskrit. My daughters, I pulled them out of the top American schools and I took them to Yugoslavia in the war. So Ankita studied in Serbo-Croat, which is actually very similar to Sanskrit. And she would sit down with the Sanskrit English dictionary and the Serbo-Croat English dictionary and try to find the connects. So smrit, death, priyateli, friend. She said, Papa, 800 words. Similar I discovered. I said, damn good. And these idiots are fighting over, this is a Serbian language and that's a Croatian language when it's a common language and it's similar to Latin and Indian, Sanskrit. Our ignorance leads to conflict. Therefore, the study of multidisciplinarity is essential. But what is multidisciplinarity? The school that I went to and I chose to go to do my graduate work, I went to do a PhD for 5 years. I spent 9 years doing it. My dad thought I'd gone mad because I realized the hollowness. I was an undergraduate in physics. I had gone to law school. Then I'd taken the IS exams in history. But I realized that I was hollow because the way Lakshmi spoke, I wanted to be that. So I spent 3 to 4 years running to the comparative literature class, although I was supposed to be studying international relations. I would run to a course at Harvard Business School because it was integrated with the Fletcher School and MIT to do a course not on technology, but technology, business, and society. Why? Because the big honchos wanted to do operational research, which you can do. But to understand the relationship of technology to corporate life, capitalism, and society, where technology becomes a product, was very important, and I would not have understood it had I not done that course. Professor Clemmer, who was in the Manhattan Project for the development of the atomic bomb, taught it to us. And there he brought in these notions that had we asked the questions while Oppenheimer was developing this, what is the impact of this on society? What is the impact of this on, as a 29-year-old, I'm being exposed to this. How many of our scientists ask this question? On a CV, they will probably say, involved in the development of atomic bomb. It's like, it's a macho thing. So I think in multidisciplinarity, it's law, it's politics, it's economics, it's history, it's governance in a substantial sense. And embedded in that, that's how the curriculum of the Fletcher School was structured. Are subcategories that you must understand the theory of a discipline, the methodology of a discipline, the institutions and the ecosystem which surrounds that discipline, and then the policy questions. So, are any of our institutions structured like that? Not at all. Not at all. And then you're given as your capstone seminar a problem where you integrate these. And it could range from a scientific issue, or whether it is seabed mining, whether it is that realm between the atmosphere and outer space, which is called near space. I mean, one of the most beautiful courses that I went through at MIT was taught by 3 Nobel laureates. The course was titled The Atoms, the Genes, and the Stars. And simply it revolved around one question, embedded in 3 disciplines: genetic, atomic physics, and astronomy and outer space. And the question that you got at the end was, if you were given $1 billion, how would you divide the $1 billion in the allocation to these 3 disciplines for fundamental research with 2 constraints? Number 1, how would it benefit your country, whichever country you came from, or how would it benefit humanity? Now just think, you have 30 students across the Charles River thinking about this, reading about this. I was a student of international relations. There was somebody from the Harvard Business School. There was somebody from Harvard Law School. There was a scientist. There was a literature student from the College of Arts and Sciences at Harvard. And that interaction. But here, if we put our people only in silos, you go do science, you never meet a literature student. So, we haven't understood what knowledge systems are and what applied knowledge systems are, which is what technology is, and how do we integrate it. In Croatia, I come back, Serbia, they have seacoasts. My driver, my chauffeur, my chef had a sailboat. Every Croatian family, Bosnian family, Serbian family, in their garage makes cognac and wine from their own little plot. They ski. That's why a country of 5 million can get 27 medals at the Olympic. And a country like ours, which is a rich country, it's not a poor country, gets 1 medal, 2 medals, and then overnight that person becomes a hero and an icon. So we are once again back into worshipping, अरे उसको Nobel Prize मिल गया इसके लिए. whether he's not Indian or he has gone 3 generations abroad. We are sycophants. And that sycophancy comes into education also. I'm being very blunt. So unless and until we create that love for the sea, all of this will be water over a duck's back. All of it. I'll conclude by saying the following, that policy is the art of the ideal. Politics is the art of the possible. And practice is the art of the real. So I've sat in many, many UN. I didn't want to go into the detail. I've been involved with the formulation of Millennium Development Goals, Sustainable Development Goals, the law of the sea, peacekeeping, development, environment, human rights. God took me there. He made that dream come true when I sat on that rock at Marine Drive, that I want to be one with the universe, and every discipline came by me. Where I was able to use my science, I was able to use the literature that I read, and I was able to use the humanities and the social sciences. But what I saw, that really, even at the highest level of the UN, although the Charter is an ethical document, the Constitution of the UN, although the attitude of the people who come to work is that it eventually becomes a bureaucracy. And that is the challenge which we have. I mean, I can talk a lot about the detail, but if we don't confront that as young people, as professionals, as individuals, then I think we will remain lost like this. So, policy is at this level. But you soon realize that when you're implementing even the most considered decisions, the political life enters every institution. Now, what I see over here are students. I see professionals. I see people who are genuinely interested in the undersea domain. But I don't see a single politician. But they are the ones who make the decision. These beautiful frameworks, this way of thinking which has been so beautifully articulated, if even 3 came, maybe they could tell the bureaucrats from the IAS who sit as secretaries and joint secretaries that I think I want to think about it that way. Have you thought about it that way? But they don't have the wherewithal. And of course, the bureaucrats, once they become joint secretaries, are thinking of retirement. And that's the most powerful position. And they have only 6 or 7 years left. So you can never take long-term decisions to build institutions and ecosystems. So I think we have to give that serious thought. And the third is, practice is the art of the real. Because even if you have a good politician, and even if you have good policy, in doing the thing, translating it from concept to actualization, there are so many things that come in the way. And that's where governance systems, the right mind, the right citizenship matters. So if my coastal zone is being destroyed and I'm living over there, and I just say I read it in the newspaper it's being destroyed, but you don't activate yourself and protest, then it will not happen. It will not happen. Then it's just another exercise. So I want to leave you with only one word at the end. That whatever you want to nurture, you have to love it before you can do anything else with it. Okay? I came in contact with I proposed to my wife on the streets of Marine on Marine Drive itself. She was 16, I was 17. I ran to the nearest rose shop at Jazz by the Bay, and I said, I love you. And it was only a nanosecond. I had never seen her before. And I would say that I will love this woman not only in this life, the same woman who comes to me 7 times in 7 generations, I will still love her. I'm saying this, I'm speaking as a person. And I said, we will see the world together. And when I was gifting her saris, they were not bought in a shop. I went to every museum as a 22-year-old, photographed a kalam, a patola in Andhra, or at the Calico Museum in Ahmedabad, the Gujarati patola, or the Kantha in Calcutta, or the Kanjivaram in Tamil Nadu. Went to the weavers and I said, this is what I want for my bride. Okay? The jewelry was photographed at the museums of the Mauryan jewelry, the Gupta jewelry, the Mughal jewelry. And I did it because I was in love, I am in love, and I wanted to sajao her. And I think if we want to sajao the world, we want to sajao the sea, that's the only way, because everything else is a product. But it can only become beautiful through the instrument of love. That's all. Thank you.
Ladies and gentlemen, that's Kishore Mandya, sir. I've spent a lot of time in Bombay listening to him, and at the end of it, he pays for the drinks and food. So, Kishore, sir, thank you so much. Couldn't have been better than this. We are not doing too well in terms of time. We'll start our next session because Ashish sir has to leave. We'll start our next presentation on high performance computing.
Good afternoon. So I'm going to talk about high performance computing and supercomputers. And this is the outline of my talk. It will reveal as we go along. So we'll begin with an introduction. And this was one of the first computers that was commercially available called ENIAC in 1947. And it was made for Department of Defense in the US. And it was primarily used for calculating the trajectory of missiles that were fired and based on various conditions. So that was its use. And that's how it all started, that we got to using computers. And here this graph shows how the speeds have increased over time. And the green line there, you have a pointer? Okay, so the green line shows that it was something like operations per second, which was integers, and the blue line shows that it is the floating point operations. So what we are seeing here is at the somewhere when the transistor was born, from that time, the earlier computers which used vacuum tubes and were not very good at calculations because of the limitation, they got to do more accurate calculations, and thus we have this blue line that now goes over to what we call as the fastest computer today is about 1 exaflop per second. So more about it later. So this supercomputers are actually used for doing floating point operations because they give good accuracy and they are used for purpose where accuracy is very important. And the way we represent them is like if they can do 1 into 10 to the power 12 floating point operations in a second, then they are called, the compute power is called as 1 teraflop, and then petaflop, and then we have 10 to the power 18, which is exaflop. So the top supercomputer today exceeds 1 exaflop operations in a second. And if you want to know which are the top ones in the world, then top500.org is the website that lists the top supercomputers in the world. And they have progressed like this over a period of time. The triangles are the ones which show what has been the top supercomputers at a given point in time. And what is interesting here to see is the horizontal blue line, which says that the supercomputer in 1995 or slightly before 1995, which was the top supercomputer at that time, becomes the 500th rank the square blue ones, which says that the supercomputer power is ever increasing, and the one that enters maybe as a top supercomputer leaves the list in a few years' time. So to give an example, the mobile phones that you carry in your pocket have got more compute power than the top supercomputer few years ago. So this is an ever-changing scenario. So where are these supercomputers used for? They are used for science and engineering. So in case of science, one of the very popular use is atmospheric science. Then to understand the earth, below earth, model the oceans, all of these is used in the form of earth science, and we have a lot of applications that do this modeling. Then space science, space observatories, they generate a lot of big data, and to process this big data, we need supercomputers. Then another application that touches humanity includes life sciences, and that's where personalized medicine, genome sequencing, these cannot be done without the use of supercomputers. And design of new materials, that is done under the realm of nanoscience. Then in engineering, design of automobiles have been greatly eased by doing crash simulations and other things like engine designs, etc. Then design of missiles and other such things that move rockets, that move through fluids, that is done through aerodynamic simulation using principles of computational fluid dynamics. Then design of structures, like you want to design a bridge and it's in a seismic zone, and you wish to know whether the design is safe. It can be analyzed using programs that are running on supercomputers. So before we go ahead, I'll just tell the principle on which the supercomputers work. So they use what is called as the principle that they work on is about taking a large problem and breaking into small problems. So that's what we do in our day-to-day life also. If you have a large problem to solve, we try to break it into smaller ones. The important thing is what comes next, that they can be solved concurrently. That is the important thing, that you have to have multiple processing elements to which these problems can be assigned. And that's where the parallel processing comes in. The multiple small problems that we have broken the big problem into has to be assigned to multiple processing elements. So parallel processing is the crux of supercomputers. And then you also use what is called as distributed computing. So this is slightly, the principle is same, but you can have heterogeneous systems. So parallel processing, distributed computing, these are the principles on which high performance computing works. So then comes, once we know that the basic element in supercomputers is a parallel computer, then we make use of this for running advanced applications. So this includes fast numeric simulations, modeling, data processing. If these are your requirements, then HPC is for you. And the important thing that it is good at, and I mentioned to you that the performance is measured using floating point operations, then it can be used for those applications that require a lot of mathematical calculations. And it's not that you just take an application that you have and run it on a supercomputers and it will run fast. No, it's not like that. You have to design applications that are meant to be run on supercomputers. So you have to design it from scratch. And then what is that? I just mentioned earlier that a supercomputer no longer remains a supercomputer after a few years. That's what is captured in the last point, which says that at this given point in time, like today, the top supercomputer or the top computers that we have, they will be called as a supercomputer. So that is the definition of a supercomputer. So now let's see what are the components in a supercomputing system. So first you have processors, and large number of them you will have. I will also show you what are the elements in that in the subsequent slide. You need good amount of memory because you are solving a large problem. Then you have these multiple processors that are connected, that are there, and each having its own memory, and they wish to work together. Then you need what is called as an interconnect, a network. You all must have used LANs, wireless networks, or Ethernet LANs. So this is similar, but it is a low latency and a high bandwidth network. Some of you must have heard about these GPUs, graphics processing units. So they are like accelerators. They speed up some of the tasks that the supercomputer is running. And then you need storage subsystems where the data and code resides, and you are going to have big data, and for that you need some very efficient storage. And there is a term called as parallel file system because you have parallel processors, each running code. It has to read and write, so you need a parallel file system. And of course, these are the hardware components. They have to be complemented by the software, which includes operating system, the compilers to compile your code, and then these processors which are running different processes, they need to talk to each other using some methods which are called as message passing interface, OpenMP, etc. And after you have all this combination of hardware and software, what runs on top of that is the application software that I mentioned earlier, the various uses that I mentioned. So let's look at how it is built. So if you visit any supercomputing facility, you will see that it is a series of racks that are present, like you might have seen it in your data center, or you might have seen a networking rack. So it's similar to that, and the individual elements in them, like this is one rack out of those series of rack, and what goes in this rack is a server like this. So this is a server that has got a height which is called as 2u. So in this, you will have, let's say the total height of the rack is 42u, that's the unit of measurement. Then you may have about 20 of these or 18 of these stacked inside one rack. And then what is inside this box that we see? It's going to be a motherboard. Many of you would have, if you have opened your desktop, you will see something similar to this, but it is much more powerful. You can see there a socket. So that socket contains a processor. So typically this motherboard would have two processors, and they are working together with the blue lines that you see there. Those are the ones that take memory. So I mentioned to you, you need a processor with good compute power. You need large amount of memory. So that becomes your basic element. And as I said, you have many such processing elements which are tied together using a system area network like InfiniBand. So moving ahead, this processor internally contains core. Like even you might have seen that, you would have seen that the processor that is the ARM processor that's in your mobile phone is a quad core, octa core. So basically internally, what is a core? It is an entire processor in itself. So because of Moore's law, you might have heard that you are able to pack more and more transistors on a processor. So what are they used for? They are making more and more cores. So here is an example where we have a processor with 2 cores. So you can have like this 4 cores or 8 cores. So inside the processor, there are cores. I'm sure now you're able to see the parallelism that's coming in, that you have cores, multiple cores. So each one of them can run a program. You have many such, like you have 2 cores. In this example, it is 2 cores inside a processor. And you have 2 CPUs on a motherboard. So if each processor had got, let's say, 16 cores, that's the norm, then you have got 32 processors on one motherboard. And let's say you have 20 such processors. So 32 into 20, 640, you can say 640 processors in one rack. So like this, you scale it up. And if you visit top 500 website, you will find that the top supercomputers have millions of such cores, right? So that's how you achieve parallelism. So that's the point I was trying to make, that when you are building a supercomputer, parallelism is an essence, and parallelism lies inside the CPU, on the motherboard, and the multiple motherboards that we connect. So this multi-core processor is, as I was mentioning, each of these is like a independent CPU, and you can run independent programs on each one of them. So now that we have understood that parallelism is the crux of supercomputing, so what do we achieve by doing so? There are two things that we do. One is that the sequential systems, if you were to run the code on a single processor, it would have run. You can write a code that runs on a single processor. But if you are, let's say, doing weather forecasting and you want tomorrow's weather, you better know it today evening. But if you would have run on a sequential system, might have taken 4 days. You would have got exactly the same result, but the time would have been lost. So that's the first advantage that we get, that more CPUs, and since you have distributed the work among them, it gets finished fast. Second advantage that you get is that each processor comes with own memory. So cumulatively, you have large memory. So the program that or data that would not have fit in one processor's memory now can be fit in the memory cumulatively of multiple processors. So what is that we get? We can save time, do task faster, and we can solve bigger problems because now we can fit in more data. So that is how parallel computing helps us. So to put it to actual use, I mentioned to you multiple uses like bioinformatics, CFD, weather forecasting. So it's always a set of or a team of domain expert who understands weather and a set of computational experts who understand how to make use of these parallel computers. They have to work together and they will design a parallel algorithm because inherently we are tuned or programmed to think serially. I will do this, like this. You form a flow chart of what you want to do. But however, here one has to think about designing parallel algorithm. Then write the code by making use of libraries that are tuned for this, and thus a application program is developed that runs on a high performance computer. Okay, so there are two parts into my presentation. One, which I covered just now about how supercomputers work. Now I will talk about what are the Indian initiatives in this. Okay, so the National Supercomputing Mission is a joint effort by Ministry of Electronics and IT and Department of Science and Technology, with CDAC and IIC being the implementing agencies. So it's a 7-year duration project worth 4,500 crores. And what are we doing in this? There are 4 things that we are doing. One is creation of facilities and infrastructure. I will show you some glimpses of that. And then what use are these systems unless they are some applications are run on them. So we are doing 5 major applications in the area of weather forecasting and urban air modeling. Then another one is related to bioinformatics, then disaster management. Like this, there are 5 applications. And then training is one of the deliverables of this, and we are planning to train about 20,000 HPC aware professionals. So coming to the first part, that is supercomputing facilities. So it's like we are trying to do a make in India kind of philosophy, that first we started with assembling in India, then the boards that you saw, that similar kind of boards are being manufactured in India. Now CDAC is designing these boards also. I will show you a picture of that as well. And as of today, 15 supercomputing systems with a cumulative capacity of 24 petaflops has been already running. 9 more are going to come, so that the total capacity becomes 24 plus 40, that is 64 petaflop. And as of now, there are about close to more than 5,500 HPC users in 100 plus institutes across the country who are using it. And on a supercomputer, you run what is called as a job. You submit a job and the supercomputer executes it. So about more than 70 lakh jobs have been executed, and 800 plus research scholars are using this. So here are the first 3 systems, the systems that have been made so far. Some of them are, it started with, the first one was at IIT BHU, which was inaugurated by our Honorable Prime Minister in the year 2018. And then IIT Kharagpur, there's one in Pune at ISER. Like this, these systems with varying capacities have already been established. This one, which is at CDAC, is called as Param Siddhi AI. This is a top-ranked supercomputer in India, and it's primarily used for artificial intelligence based applications. It comes with a set of standard programs, that applications that run on it, which are listed here. I will not go into details, but right from things which are related to bioinformatics, weather, disaster management, CFD, all the standard grand challenge problem applications are available here. Here, this slide shows some of the Indian development, like the diagram on the top right. That's actually a server motherboard, which is in a different form because it's a form of a brick, as it's called. And its USP is that it has got a very high density, so that you can imagine in the rack, so many of them can go. And taking out heat is a major issue here, so for which we use liquid cooling technology for efficient extraction of heat. And the other card that you see at the bottom is the HPC network card, which is used for connecting many such nodes together. So these are some of the examples of what is being done, designed, developed, and assembled in India. Okay, so sir, I take this opportunity to, thought we have a team at Trivandrum which works on strategic electronics. And I thought the audience here would like to know what we have done for the underwater things, because I thought it would be relevant to your theme. So again, I am not a subject matter expert on this. My colleague Rajesh, whose email address is rajesh@cdac.in, is the one whom you can contact if anybody here is interested. I will just flash some of the details that we have. And these are, as you would know, made for Navy and other clients. So here we have an eco sounder for ship, which is for Indian naval ships, and it follows this standard. It's a military grade thing that has been, and it's already 75 units have been operational for Indian Navy. Then there is one similar thing is made for EKM class submarines. Again, I'll say I don't understand much out of this. Sir sitting here who has designed a submarine would know what it means. Yeah, so he would be able to understand. Maybe in the post lunch session he can tell more about it. Then again, I'm sure you must have used this because you are the ones who designed the nuclear submarine. And these are some other products like electromagnetic log and RTU. This is the one that is used for speed and distance traveled by the ship. And many of these products are actually replacement for some things that we were importing earlier. So that is one of the good things that we are doing. And these may look like small things like transducer, but they have a very great significance in replacing an product that was very costly and that was to be imported. Okay, and there was some talk about noise being created by drones, but this has got some special use, like wherever a human being cannot go, and let's say there is a bridge, and the pillars of the bridge which are underwater, they need to be checked. If it's not possible for human beings to do it in a way, this can go and do, and it has got a good application. And you see the Prime Minister being demonstrated it, not demonstrated, but told about it in Digital India Week exhibition that we had in Gujarat last year. So then this is one more thing called as vessel tracking system. So this is again used for ships, and there is also an autonomous surface vehicle. So these all are strategic electronics team at our Trivandrum center are doing it. And one more is about, he gave me the slides, I'm just flashing it. Sorry about that. I'm unable to give you more information about it, but you can definitely get in touch with us if you are interested in any of these products. And then we would be happy to give more details about it. This is about this creates a Doppler velocity log. It's a simulator for submarine combat suite. Okay, so I come to the end of my presentation. What I wanted to say about HPC, apart from the few slides that I showed about the strategic electronics products, is that you might not see HPC being used, but maybe when you see a news at 7:30 in the evening, at the end of it, the weather forecasting is told. Weather is forecasted for the next few days or a next day. So it is the HPC that is in use for that. And HPC is very similar to your standard computer. It uses CPU, memory, IO. However, parallel computing is the important thing that it does differently. And apart from these basic elements, there are other things like parallel file system, the softwares that go on top of it. And then if you want to make use of it, you have to design your applications using the parallelization methodology. And there are some standard things like MPI, OpenMP, which are useful for writing those code. And if you want, if you have any questions, I can take them now. Sorry about rushing through the presentation, but I mean, I guess yeah. Yeah. No, no, not being guilty, but I also had a commitment. Yeah. And these are, Rajesh can be contacted for the last part. And for the supercomputer related things, I am there, I'm in Pune, so you can contact me over email anytime. Right. So what happens is that, like let's say you take your laptop, it is, or your phone, it is supposed to run on battery. So there the main optimization is done to make sure that it will give the frequency of the CPU and other things would be will be managed in such a way that you conserve on power. You if you needs like on a, you might have seen, if you are start running word processor or something on your laptop, you suddenly see the fan being revved up, because earlier when it was idle, the CPU was running at a very low frequency. Once the demand was there, it started running fast because you have to do the task. If you apply the same principle to supercomputers, they are optimized for power, the compute power, which means they sacrifice the electrical power. Which means that if you want to extract the maximum possible performance, then it is going to generate a lot of heat. And that is a big challenge in terms of how much there is these days. There was a time when it was like a brute force method, more and more power, compute power, just keep increasing the frequency. But now you would have seen that the emphasis is on conserving power. So what is done is frequency is reduced, which reduces the power consumption, but the number of cores are increased. So when you reduce the frequency, the power goes down by square. So you reduce the frequency by half, it comes down by 1/4. But you can put 2 cores. Then what will effectively happen by simple mathematics is that power consumption is half, but the compute power is similar because you have 2 cores of half the frequency, you can see. It's not that simple, but just to give an idea. So point that you correctly said is about making sure that the ratio of compute power is to electrical power is as low as possible. And newer processors like ARM, etc., they are good at doing this. Some processors are more good at giving raw compute power. So depending upon what your need is, you can use the appropriate kind of processor. But liquid cooling technology helps in removing the heat faster.
Mine is a little basic.
Yeah.
We are manufacturing these supercomputers, etc.
Yeah.
How much are we dependent on the components? Because that is a fab is a very weak thing in India. So what are we? Is there some plans or something on that on fab?
Yeah, I didn't mention it, but there is a program to make our own processor. But again, the processor will be manufactured in Taiwan or some other place. So as you rightly said, India does not have a fab other than Semiconductor Complex Limited at Chandigarh. But again, its capacity in terms of the capacity is decided typically by how fine you can make the transistor. It's called as a feature size. So the current technology, the best one is 3 nanometer that TSMC in Taiwan is doing. We are way behind that, and that is what the new plan called as fab setting up is being done by government, is being proposed by government of India, and we heard something like Vedanta is going to have it in, is going to set it up. So that again takes, I mean, if I have read correctly in newspaper, it would take something like $5 to $10 billion worth of investment plus other things. So it has a long gestation period and it will come up soon.
I asked this question 10 years ago to somebody who was also not from CDAC, of course, and it was same. But at that time, it was said more that it's expensive. The more we wait, it will become more expensive.
Right. So
The
yeah, sorry.
very idea that we are going for hyperprocessor computing. So what happens if we become very good? We are very good at service. We are very good at understanding languages. Very good at programming. Very good at even manufacturing. But the problem is, and that's one of the things even in underwater, the technology to do it in this country is important. And I agree with you. It costs a lot of money, but this is where the as he said, the politician, the political, the possible, to make it possible, that hasn't happened. I know that something people are talking about, but this is an area we should be. I believe I'm now old. I'll probably go, but the issue is this is going to strike us as we think we are going to be a power. That is important.
Yeah, you rightly said, sir, and that is what we need to. I mean, as a country, we need to reduce the dependency as much as possible. But there are steps are being taken in the direction. Hopefully, they will fructify in the years to come.
I think in the supercomputing domain, there are larger dimension of, I mean, you talked about cooling, you talked about power also. I mean, the whole, I think, concept in National Supercomputing Mission we chose for distributed setup.
Yeah, that is actually the, it's called as cluster.
Yes.
So the cluster is the de facto standard these days, because what happens is each of those nodes are like commodity products. Otherwise, earlier Cray and all, what they used to follow is they used to make a very dedicated systems. But then what happens is that the processor, other technologies change every 1 year, 1.5 years. So you can't keep pace with those changes by doing the changes in the hardware
Sure.
design. So that's the reason why this cluster kind of small node, lightweight node, but use multiple of them is being followed.
But also the power availability also was an issue earlier. I mean, in the initial days, probably it's a little better now, but still, that was also one of the major factors in terms of deciding the architecture, the way that you had thought.
Power is definitely one, and worldwide also there are. I mean, when exaflop was conceived, at that time the thing was given is in 20 megawatts we should try to do it. It was not possible, but such kind of goals are set so that and it needs right from processor design, memory design. Each component needs to conserve power in order to reach the budget that is set for the entire supercomputer.
Right. Thank you.
So I want to ask you, so we have a session on quantum computing next. So for quantum computing, how do they relate, quantum computing and supercomputers?
At the moment, supercomputers are used for simulating quantum computers. At the moment, okay, and as of today, it will be anyway revealed in that session. It is more of a theoretical thing that is being proposed, which is in process of getting developed into a tangible thing, where actually something will now components like quantum communication, quantum qubit, so many qubits kind of processing elements, they are being designed. But if quantum computers become reality, then that will be an extension of high performance computing. In a way, you can say.
Thank you, sir.
Thank you.
I just want to place it for reflection that how the world is changing. See, we are now looking at the world in terms of countries. But the fact remains, if you look at the demographics and the shifts, is that there are two vectors which are in play. Almost all countries in the world, particularly the large countries, shifts are taking place from the continental parts of these countries to the periphery of these countries along the coastal geographies. Now, if you look at the GDP of the United States of America, increasingly of Europe, increasingly of of India, higher proportion of GDP, for example, in the United States, almost to 85%, comes from within 50 miles of the band of the Pacific coast and the Atlantic coast. In Europe too, the shift from Scandinavia for energy reasons, for cheaper real estate prices, for lifestyle, the shifts are taking place because of a common European Union towards the Mediterranean coast. In India too, the similar shifts are taking place. If you look at the agglomeration of cities like Pune and Bombay, it's towards the coast, the Ahmedabad-Mumbai corridor towards the coast, similarly the Visakhapatnam, Chennai. So the interior of most countries is being hollowed out. And the world 30 years from now, 40 years from now, is going to be actually large city-states, not countries. Most of your GDP and employment will be in these areas. And therefore, the impact on the undersea domain will be greater. Now, if you look at Maharashtra, the shifts in Maharashtra are more towards the coast, the Konkan coast, the Mumbai agglomeration. Mumbai actually has a larger number of economic and cultural transactions with Dubai and Singapore in the same way Chennai has it, than with the rest of the interior of India. So it's a very interesting thing that your global economy is going to be an economy between cities and less between countries. And it is likely, and it's also getting increasingly reflected in the mindset. Where are you coming from? I'm a Mumbaiker. I'm a Singaporean. I'm a Bostonian. Not even, they won't say America. Somehow it's seeping into your identity. So these transactions, for example, between Bombay and Dubai, Bombay and Singapore, the external vectors will also have an impact on the undersea. Sure. So one has to be mindful that the geography is changing and that geography will have an impact on cultural and economic transactions and therefore on the physical domain itself. Thank you.
Thank you so much, sir. Ashish sir, thank you so much. We really appreciate. I'm sorry we could not keep the time very well today, but we really appreciate your presentation. I had the fortune of working with CDAC Trivandrum 15 years back, and they are doing phenomenal work for the Navy. In fact, the setting up of the underwater ranges, CDAC was very, very critically involved in that. Thank you very much, sir. We'll break for lunch and then we'll assemble back again. Thank you. A little later in the day, we'll get some time to interact. Today, I also need to hear from you and also clarify. Even we'll have some sessions specific to different entities. I mean, people coming from different organizations, we would be happy to answer. Whatever you feel you can share in the open is fine. Otherwise, I'll be happy to interact with you one-to-one also and discuss if there are any queries that you have, or we will be at the end of this workshop, we will be generating the concept note that you have got. Will be, as I had mentioned earlier also, it will be available to you. The report will be circulated with all the participants. So please register. Mehul will let you know how you can register so that your details are with us. And we will share the report also with you so that, and all the lectures that are going on are recorded. So they will be available to you later also. You can share with your, and even as you attend this, it is available online. So please feel free to share with your friends, colleagues, even young students, if you think they can benefit. We'll be more than happy if you share with them. So, because I mean, many of the lectures are very open. You know, it will help people to even understand life, I could say that. So please feel free to share it with anybody. And once we share or even if you go to our website, there's a lot of material. We have a separate platform called the UDA Digest, which at this point it has about, I think, 70 articles which covers different aspects of the UDA. We started 2 years back, and I think we have done well to have 70 articles. These are about 1500 words article, easy read. They are not highly technical thing, but which a general person can understand and appreciate. That is the whole purpose of UDA Digest at this point. But very soon, in the next 3-4 months, we will start a more serious version. I mean, serious, I mean, it'll be a 10,000 word report that will be put up to cover various aspects of UDA. So about, we have 10 research fellows who are working with us. Each of them will be contributing one aspect. You will get to know what they are. And also some senior people, another 7-8 of them are writing a little longer. I mean, as I said, 10,000 word article. These will be highly scientific, or not just scientific, sorry, they'll be very, very intense articles written by researchers with a lot of, like, 2 of them are professors in IITs. Somebody is a naval officer who has got more than 35 years of service, but also who has been a researcher for the last 10-15 years. He'll be writing, you'll be hearing some of them here also. So they are writing a very serious 10,000 word, we are calling it a short report. So we are looking at, and there will be a book release also for each one of them. So I think from the middle of this year, every month we'll have a separate event for that as well. So I have some PhD students now working with me to cover various aspects of UDA, and this number is growing now. And also our website has a lot of material. There are a lot of videos which are easy to listen or easy to understand, which covers various aspects of UDA. So some of my articles are now getting, I've been writing on in Sunday Guardian also. Now I think I have 15 articles in Sunday Guardian covering various aspects of the UDA. Otherwise, probably I have more than 100 articles, some journal papers, also 50 journal papers. So idea is to reach out, and no better way than to write. And I will also request all of you to write for us. One is all the participants who are here at the end of this participation, I would request you if you can put down your thoughts. When I say put down your thought, it doesn't have to be giving an experience of what you saw. You can pick up one particular idea that you think is something you would like to express yourself. You can write 1,000 to 1,500 word thing, and please write back to us. Send it back to us. We will have a surprise for you on that. I'm not calling it a competition, but it is just to connect with you. When you have taken the trouble to come all the way to Pune to attend this, so whatever you are hearing the whole day, and as I said, UDA Digest has so many articles. So if you just go through that, you will find something interesting in that, and you can pick up something that you would like to express yourself. And I'm available to discuss with you. If you want some inputs from me, and if I can be of value, I'll be more than happy to interact with you. For the younger students, this can give you an opportunity to join us as an intern based on whatever you write. And we don't want to put a barrier on language also. If you are comfortable writing in Hindi or Marathi also, we are fine. We have people who can translate that and make sense. I mean, we just want to know what are your ideas. As I said, idea is to connect as many more people into the UDA framework, and you can contribute in whatever way possible, right? You'll be getting to see some of our young students also, I mean, young fellows who are writing. Thank you, Venkat, for joining us. And without taking much time, Venkat, I would hand over to you. I will request you to please introduce yourself, your journey, both personal and professional, whatever you would like us to know, and then you please start your presentation.
Okay, great.
Over to you,
Thank
Venkat.
you.
Thank you.
Thank you so much. Yeah, hello everyone. So I'm Venkat. I'm part of IBM Research. A part of my journey coincided with Arnab, Dr. Arnab's journey also. So, you know, so that's how I'm also connected with the underwater communications and underwater signal processing. So we both did our PhDs from IIT Delhi from the same lab. Since then, I have been with IBM Research. I've worked in areas like artificial intelligence, machine learning, natural language processing, and most recently, I've been working in the area of quantum computing. And right now, I'm the IBM Quantum India leader. And today, what I'll do is I'll talk to you about what is quantum and maybe how it can be applied in various areas. And for questions, I guess we can ask anytime, you can stop me and ask. I think you can also write on chat. People can, maybe let me know when there is a question. Okay, so I hope you're able to see my screen. So today what I'll do is I'll give you an introduction to quantum computing. Okay, so I don't know how many of you are already know what is quantum computing, but this talk is going to be quite basic. It's going to be an introduction level talk about what is quantum computing and related areas of quantum, right? So, so the goal here is, we want to bring useful quantum computing to the world and make the world quantum safe. Okay, so there are two things here. Quantum opens up a lot of opportunities because it's such a powerful computing paradigm. Secondly, because it's so powerful, it also, opens up gaps in today's encryption standards. Okay, so that's where what we mean by quantum safe. So I'm going to talk about both of these things to some extent here today. Now, this is a graph of people, where all people are using quantum computers of IBM from. Okay, so these are IBM quantum computers are available over the cloud for free. Any of you can go open an account and start using a quantum computer right now. And this is where all the users of quantum computers today are, right? And over 1 trillion circuits have been run on quantum computers since they were, put online about in 2016. And as you can see here, India is one of the major areas where people have started using quantum computers. India now ranks among the top 5 to top 10 countries from where people are using quantum computers. And this is despite the fact that quantum computing is not a regular subject in many universities today. Maybe just 4 or 5 or maximum 10 universities in India offer even a single 1 semester course on quantum computing. Despite that, India is among one of the top users of quantum computing, and that is driven by students, industry people. And very excitingly, even 12th class students today are very excited. And from India, whenever we see any, sort of a course or anything that we offer, we see that school students register in large numbers for quantum computing. So it's a very exciting area. And today what I'll give you is an introduction to this field and what all is possible using quantum computers. So before we go on, any questions so far? Okay, I guess no questions. So can you raise your hand if you know anything about quantum computing? Maybe somebody can tell me how many hands are raised in the room.
Not too many.
Okay. Okay, good. So that's why I said I'll keep it very basic because it's an emerging area. Now these are, worldwide network, quantum network members from across the world. Okay, from India, there are a few. For example, there is Tech Mahindra, there is IIT Madras somewhere here. Also, you'll see that there are naval research institutions in the US who are now using quantum computers. Especially, there is this military university and there is the Naval Research Laboratory in the US. Okay, so several universities and labs have now started exploring how quantum computing can help in different domains, right? And we're going to touch on some of these areas today. So there is a, I didn't put it here, but there is this Nobel laureate who said that, quantum computing is as different from today's computing as an abacus was from today's computers, right? So it's a very entirely new method of computing which can sort out huge problems, huge computational problems, and that's what I'm going to be talking about. So what is the quantum promise, right? What is it promising us? So for the first time in history, okay, now we have two types of computing. A quantum computer is not the next generation of supercomputers. It is an entirely different kind of a computer. Okay, so for those of you who, I just want to make it very clear that quantum computers are completely new from whatever computing we are aware of today. For example, the mobile phone, or for example, the laptops that you have, or for that matter, the best supercomputers in the world, which have now touched exascale computing. All of those, they are very different from quantum computing, and we are going to go into very briefly as to why is it different, what is different, right? So why do we need quantum computers? Okay, so one is, Moore's law. As you know, Moore's law is the law that, you can pack more and more transistors into the same small chip, and it has been doubling every 2 years. Okay, every 2 years, Moore's law has shown us that computing power has doubled, but we are now seeing that Moore's law is slowing down. Okay, so anything exponential in nature cannot last forever, and Moore's law is an exponential law. It is reaching a point where Moore's law is now slowing down. Why is that? Because, as you reduce the dimensions of your your chips, it is now reaching atomic scale. Okay, what does that mean? You're now reaching levels where you are now having, the width of that to be one atom, and as soon as you reach that, you've stopped. You can no longer, use that chip, because it now reaches other kinds of realms. So what is the new Moore's law? Many people believe the new Moore's law is what is called the quantum volume. We are now seeing that quantum computing is, the power of quantum computers is almost more than doubling every year. It is expected that it will settle down at doubling every year. So that's the new Moore's law, where you're having these, the earlier classical Moore's law is slowing down, but at the same time quantum volume has come in, and that has shown that it is now taking over, and it is doubling the performance of quantum computers every year. What is it that quantum computers do special? Okay, so let's look at the coffee molecule. The coffee molecule is a very, it's a simple molecule. It's not even one of the bigger molecules. It is something we all know. We drink coffee, and it is, if let's say we want to simulate the coffee molecule, okay, what do we need to do? Okay, and this is important because if you're able to simulate molecules, not only can you simulate coffee, but you can also use the same process for discovering new drugs, for discovering new materials, like, for example, new battery materials. We are now having electric vehicles. You can look at how can you, find carbon neutral processes. All of these, they are all very important molecular processes, just like modeling the coffee molecule. Now, if you were to try and approximate the caffeine molecule, you would need 10 to the power 48 bits to represent it on today's computers, okay? And that's even impossible. You can't even do that. Why? Because to do it, you really need about, 1/10 the total number of atoms on the earth. It is not expected that our classical computers will ever reach that level of number of bits, okay? So it is something which is impossible, and as I said, caffeine is not even one of the larger molecules. But if you were to do this on a quantum computer, all you would need is 160 logical qubits. Okay, so bear with me, I'll tell you what qubits are. But you can think of a qubit as an equivalent of a bit on a classical computer. Remember, to represent caffeine, you needed 10 to the power 48 bits. But on a quantum computer, all you will need is 160 logical qubits, okay? So that's sort of the talking about the power of the quantum computer. Also, just to let you know, today, we all know about deep learning, AI models, and all of these. This table, you don't have to go into it, but what it is basically saying is that if you were to reduce the error rates to very small numbers on tasks like image recognition, natural language processing, all of these tasks, your economic cost is going to grow exponentially. Why is that? Because you're going to need more and more number of these GPUs, which will reach a level where you'll need so many that you can't fit them into anywhere on earth, right? So you're reaching levels where today's deep learning methods or AI methods are sort of plateauing out in terms of the computational power. So for example, if you look at this, deep learning is growing exponentially and the hardware performance is not keeping up, okay? The hardware performance is slowing down, and that's because of Moore's law and various other aspects, like I said. So we need a new kind of computing to be there, right? But our quantum computer is faster at everything. Let's look at multiplication, P into Q, of two large integers. On a classical computer, it will take you 0.0025 seconds, but on a quantum computer, the same operation will take you 75 seconds, over a minute. Is there a question?
No, please continue.
Okay, thanks. So multiplication, definitely our classical computers are faster. This is P into Q equal to N. But what if we were trying to factor the N into its prime factors? What are prime factors? What are the prime factors of 15? 3 into 5, 15. What are the prime factors of 49? 7 into 7, 49. What is the prime factor of 100? You can keep going, right? Now, if you make this number large enough, you make it 2048 bit integer, 396217996. I give you a large number. To do this, it will take you 4.7 billion CPU years on a classical computer. On a quantum computer, the same operation can be done in a few hours, okay? So here is an operation, factorization, which can take exponentially large amount of time on a classical computer, but it can be done very easily on a quantum computer. Does anyone know where this is used? N equal to P into Q. So all the encryption for our banking transactions, for example, all our internet, all your photographs, all your Gmail accounts, they're all secured using this factorization, RSA. Okay, RSA, it's going to take you, it's based on the fact that a classical computer cannot do this factorization in finite small amount of time. And as a result, we use this today. But in future, as quantum computers become more and more powerful, the same operation will be broken. And so today in government circles, there is a fear that, our enemy countries, whether it is our, China, Pakistan, all of them, could be just collecting our data, storing it, waiting for the day when quantum computers become powerful enough to look at our secrets. National secrets, defense secrets, these don't last for 2 3 years, they last for 10 years, 20 years. So as a result, any secrets which, data which is secret today, even if you can break it in the next 5 10 years, you could potentially expose yourself to, some certain dangers, right? So this is one of the things that quantum computers are expected to do in the near future, which is break factorization, break our current encryption schemes, right? So all our banking, all of this data becomes insecure as quantum computers become more and more powerful. So here are a class of problems, the problems that classical computers today can solve. So what can they solve? They can do multiplication well, they can do this video conferencing well, they can do databases well. So all of those problems sit here. But there are a class of problems which are very hard for our today's computers. For example, factorization. For example, molecules, like I said, simulating molecules. And for those class of problems, quantum computers can be used, right? So this is the class, and there are a class of problems that quantum computers will solve which will never ever be possible for classical computers also. So these, I'll just delve into some of these. But meanwhile, is there any question till now? So what are the problems that, quantum computers can impact? Okay, so today, if you look at it, today the world's population is 8 billion. Do you know how much of that population is supported by, all of that is, of course, we all eat grains and food. But if we were not to use synthetic fertilizers, only half that population could be sustained. Only 4 billion people could be fed today if, we were not using synthetic fertilizers. You would have seen Sri Lanka, they tried to impose, a law saying that you can only use non-synthetic fertilizers there, natural fertilizers, and you saw how their economy tanked, right? So, but the fact is that today fertilizer making is one of the most polluting industries. So we all know about climate change, carbon dioxide. Delhi is polluted. The pollution levels are very high in our cities. A lot of this is caused by processes like producing fertilizers, which are very, very, polluting industries. And so what can quantum computers do here? Like I said, they can simulate molecules. They can help in finding better synthetic nitrogen fertilizers, which will help in creating, non-polluting synthetic fertilizers, right? So, which is, basically it will improve the nitrogen fixation process by creating ammonia-based fertilizers, right? Reduce the carbon dioxide in the atmosphere. And these are, this is just an example, right? It can also, for example, help in looking for new battery materials. With electric cars, you would have seen what is the major problem. The battery needs takes a lot of time to charge, and once it's charged, it only lasts you for, let's say, 400 500 kilometers maximum. How do you increase the life of the battery and reduce the charging time? Again, a molecular process. You want to find new molecules which will help in coming up with better battery materials. And same, whether it is new aircraft material, whether it is new materials for cars, in all of these, you're looking for strong materials which are strong but lighter, for example, right? and which require less maintenance. All of these, and also, for example, looking for new classes of antibiotics, all of these are molecular processes which we can simulate using quantum computers. How do we do it today? Today we take two test tubes, we pour the two molecules, we observe how it is, interacting. That's how we do it, and that's why it takes a lot of time and effort and energy. But in future, it is expected that we will be able to simulate the properties of materials much better. In defense, what can you do in defense? So quantum radar. So this is a normal radar. This is how the SNR typically works there. In high SNRs, quantum radar and today's classical radars are similar, okay? But as you reduce the SNR, the quantum radar is, works even below 0 SNR, it is going to work, okay? So it's going to, give you detection. And in fact, people believe that not only can it detect objects, perhaps it can even help you detect the payload, okay, which means that, let's say today we can only say that there is an aircraft coming, but using quantum radars, it could be possible that you could say that, okay, this is a aircraft coming, it's got a nuclear missile, of this with this much grams of whatever, and all of those, right? So these are highly sensitive, materials which will help us in coming up with new materials and new sensors, which are going to completely change the way today's, sensing and defense applications are done, right? Um, So there are multiple, areas in which this can be used, whether it's quantum radar, whether it is underwater lidar or imaging, submarine communications. In all of these, there is there is the potential that quantum can change the game completely. And this is, it's not there yet. It's still a scientific problem, but there is a lot of mathematical and theory which has shown that it is possible to get there, right? And that's why today, for example, many governments, including the Indian government, have come up with what are called the national quantum missions, where, for example, India has committed 8,000 crores to scientific research and development in the area of quantum computing, right? And this was announced in the 2020 budget by the finance minister, and it is likely to, and already a lot of funding has gone to several research institutions in India, and this is only expected to accelerate. Several countries, among them China has invested the most, $15 billion. And in fact, they are the first to launch what is called a quantum satellite for communications also, okay? So in our neighborhood, there is a lot of quantum activity going on, and that has sort of made our defense and our government establishments also take note and start investing in this area, because there is a lot of potential and there is a scope for us to do things which were never possible. It is going to completely change the game, as it were. In any questions? Otherwise, I'll keep going. Please feel free to interrupt me. Okay. So quantum, you need.
Another question.
Yeah,
Venkat.
please. Yeah.
Sir, just prior to this, we had a lecture on supercomputers. Now we're talking about quantum computers. I mean, I do understand this particular thing that you brought out, that whether it is with regard to factorization, with regard to simulating of molecules, or for these new technology devices. But what exactly is there in this particular computer which helps us achieve these particular things? Like, for example, like you brought out that, okay, you have a multiplication. In case of multiplication, that it takes that much more time. It takes about more than a minute to carry out a multiplication, which a normal computer is able to do it much faster. So what is the crux of the whole this thing of that it is able to achieve these particular things in a much faster manner, and how is it different from this supercomputer things? If you could please throw a little light on this.
Sure, sure. I'll do that. I'm just going to check whether okay, so I put it in annotating mode, looks like. Okay, sure. I'm just looking if I had a slide on that. I'm just going to. Okay, looks like I did not add. Okay, no problem. So what? So the question is, what is so different about this, right? Because, like I said today, it's a new kind of computer. It's very different from any kind of computing that we have been used to. So supercomputers, as you know, still use the 0 and 1, right? So they put the bit into that 0 or 1 state. What is special about supercomputers is that they use parallelism, right? So they are able to parallelize computation in a way that you can carry out multiple computations at the same time, right? So that's where the power of supercomputers comes in. But like I said, there are processes in nature which can never be done even using the best supercomputer. So what is different about quantum computers? So I talked about qubits, right? The equivalent of bits on a computer is qubit on a quantum computer. Okay, what is a qubit? Okay. So qubit are realized using subatomic particles. So what are subatomic particles? Things like photons, things like electrons, things like neutrons. These are, particles which exist within the atom. And these are the particles which are used in the computation, okay, which form the physical qubits. Okay, so you can realize a quantum computer using photons as the qubits. Okay, now this photon can be put in different states. Okay, so similar to your 0 and 1 state, the photon can also be put into the 0 or 1 state. But what is interesting about the photon is that it also has all the intermediate states. Okay, so what that means is a bit can be either 0 or 1, nothing else, right? A qubit can be all possible states within that 0 and 1. So it's like you toss a coin. When the coin is in the air, is it heads or tails? It is both heads or tails. Okay, so and that is called the superposition property. So the qubit can remain in this superposition state of 0 or 1 simultaneously, and only when you observe it, when you observe it, it is 0 or 1. Until you do, it is in both the states. The second property is called, okay, I'm now blanking out. But anyway, you're trying to, let's say toss a coin, right? So when two people toss a coin, me and you, we both know it is independent, right? But if two coins are put into this quantum state, what happens is they remain correlated, and that correlation is irrespective of the distance. Okay, so I'm tossing a coin, you're tossing a coin in Pune. If they are correlated using quantum properties, you looking at my coin, I know exactly what happened to your coin. Okay, and this property, whether I'm sitting here and you are in Pune, or I'm sitting here and you are at the other end of the universe, it remains true. Okay, so what happens because of these two properties? Quantum computers use these properties, okay, to do the computation. So to give you an example, what are all possible routes from here to Pune? Okay, so if I ask you that question, you'll say, okay, I can go from here to Jaipur to that place to that place. I can go from here to Bangalore to that place to that place. So I can go, multiple routes I can go through. How does a classical computer find out the right route? It searches through all possible routes. Okay, and then it says that, okay, the shortest route from Delhi to Pune is this route. Okay, it searches through all possible routes, 001, 010, 0111, all possible routes. Okay, it searches through them and finds out the right route. But on a quantum computer, what happens is, because you can put them into the superposition state, You can put it simultaneously into all possible states, and then through a process called interference, you eliminate all the incorrect states. So within one shot, you now have the answer. Whereas on a classical computer, you had to go through all possible states. On a quantum computer, you can do it immediately. Okay. And this is a property which has confounded, scientists from long ago. So I don't know if you know what was the Nobel Prize this year for. And 2022, it was for just this property. In 1935, Einstein said things like God does not play dice with the universe. He called this property of tossing two coins, at two distances. He said that this is spooky action at a distance. He said we don't understand quantum mechanics well enough. When we do, we will show that these are not possible. But today, 2022, the Nobel Prize went to these three scientists for showing that Einstein was wrong. And the fact that, superposition, entanglement, all these properties are in fact possible and they happen in nature. Only thing is, we cannot observe it because it's happening at a molecular, level. So as a result, it is now proven that, quantum computing through the two properties of superposition, which puts it in all intermediate states, and entanglement, where, two coins or two qubits can be put into this state where they both behave similarly. So these are the two properties. And when you start looking at how do you compute using quantum computers, you use these two properties to write your algorithms. So when I talked about, that molecular simulation, or I talked about the factorization, which can be done so much faster on a quantum computer, all these are things which use, things like superposition and entanglement to write those algorithms. Okay, so that was the long answer to the short question. Okay, so we are now looking at how do we, so the goal of the government of India is that we should become leaders in quantum computing, So I don't know if you know, by 2024, India will have the largest number of software engineers in the world. We will surpass US that year. So as you can see, we have done very well in the software area, but in hardware, we have done very, very badly. Nothing to show, whether it is in computing, whether it is in communication, technology, all of those. And we're trying to, fix some of those things. But in quantum, the goal is that not only do we do well in quantum software, but we should also do well in quantum hardware. Okay, so we're trying to, look at how can you drive up industry adoption, how can you build services on top of quantum computers, what kind of, advanced quantum computing can you do, and how can you build ecosystems where, industry, academia, startups, and all of these can come together. So this is a very thriving area of research, several research papers published, several of them from India also. Qiskit, okay, so those of you who know how to program using Python, Qiskit is a programming language which is a Python library. So you can very easily, like I said, quantum computers are available over the cloud. And India, as you can see, is one of the highest adopters of quantum computing today. We have some of the largest number of quantum scientists, quantum software engineers, students who have learned quantum and who have certified themselves, in quantum computing. So in all of these, we in India, we are leading, and Qiskit is the open source software development kit for quantum computing from IBM. And you can use this, like I said, as a Python library and start writing programs today. So just the way you write machine learning code or anything, or data science code, or whatever you're doing using Python, you can do the same thing using Qiskit and run it on a quantum computer. Okay. Several industries have started using it. Like I said, IIT Madras became the first quantum network member from India only 3-4 months back. There are over 200 plus across the world with actual, physical systems of. So quantum computers are not there everywhere today. There are only, 4, 5, 6 locations. One of them is in the US, Germany, Japan, Canada, South Korea, and some places in Europe where they have also, started looking at quantum computers, right? So very few quantum computers today. Many of the IBM quantum computers are kept very close to 0 Kelvin, which is like colder than the average temperature of the universe. So you have to cool it down very low temperatures to make it run, because today's quantum computers are noisy. Several scientific challenges that need to be fixed, right? So I'll not get into this, but here are 3 areas where quantum computers are now getting used. One is in simulating nature, like I said, coffee molecule, drug molecules, electric vehicles, all of these. How do you simulate nature, right? So that's one. In mathematics and data processing, so I talked about the factorization problem, but you can also look at various other complex mathematical problems. Also search and optimization and machine learning. So that's the other area, and several industry partners are now working in some of these areas, right? And this is just a sort of a short list of areas where people have started looking at some of these things, and as I said, in naval research also, there are at least 2 or 3 places in the US that have started looking at how to use quantum computers in in the naval field, right? So, any questions before we move on?
We can go ahead.
Okay, fine. So here I'll give you a sort of a glimpse of how the technology is improving, right? I told you it's sort of doubling every year right now. This is IBM's journey. Many others also have quantum chips. So in 2019, it was 27 qubits. 2020, it was 65. Right now, it's the 433 qubit quantum computer. This is the roadmap. So later this year, we are going to see the 1,000 plus quantum qubit computer. And by 2025, we expect that it's going to reach 4,000 plus. Okay, so why is this important? Like I told you, the factorization problem, the molecular simulation problem, all of these require larger number of qubits. Okay. Now, I also told you that with just 160 qubits, you can simulate the coffee molecule. So can you do it today? No, you cannot, because this 433 is noisy qubits. Okay. So today's qubits are noisy. Scientists are working on how to reduce the noise and make the quantum computers more effective, right, in terms of doing their computation. So even though it is 433, these are noisy qubits, so they are not as effective as it can be, if it were noiseless. So what are the focus areas today in terms of research? One is to increase the number of qubits, right? So that's one. The second is, how do you do better error correction, error suppression, error correction, all of these to make the number of qubits more effective, right? Because as I said, today we're at 433, but it doesn't behave like a 433 yet, because these are noisy qubits, okay? And then on top of it, we are building many software and algorithm layers. Okay. So in terms of algorithms, people have already developed several algorithms, whether it's in machine learning, natural sciences, optimization, but there is a lot more scope. And there is a scope for figuring out how to take care of the noise while still doing some of these operations well, right? So that's one of the major research areas today. And then on top of it, the top layer is, there are several libraries available, and as I said, you can start using Qiskit today. You can go online, create an account, and start running very simple programs, just to familiarize yourself as to what is a quantum computer, how can I use it, because this is in a state where we were with classical computers in the 50s, maybe, in the 50s or not even 60s, right? But today this is accelerating very, very fast, because we already know how to build classical computers. So the speed at which quantum computers are getting built is much, much faster than the classical computers were getting built at. So we don't expect classic quantum computers to take 60, 70 years to reach this level. It's going to happen much, much faster. And with the kind of money that governments like Indian government, US, China, several in Europe, all of them are putting in the money, it is expected that this acceleration and the amount of researchers working on this, the number of developers working on this is going to speed up very fast, and we are going to start seeing applications in quantum. So there are two terms that you might hear. One is called quantum supremacy, and the other is quantum advantage. So what do these terms mean? These terms mean that using quantum computers to do something which a classical computer will not be able to do, or will be much slower, or it will be very, very costly or things. I gave you some examples, whether it's deep learning, whether it is factorization, whether it's molecular simulation. But the day we are able to do any of these things, we will say that quantum supremacy or quantum advantage has been achieved. Okay, so that's what that term, I don't know if you've heard that term, but you will start hearing about it in the near future, because as quantum computers become more and more powerful, they are going to start solving some of the toughest problems, or some of the most impossible problems from our world today. And by then, you'll see that headline that quantum computing has reached quantum advantage today, or quantum computer has reached quantum supremacy today. So that on that day you can say that, okay, quantum has reached a level of technology where it can solve a problem, a business problem or a real problem, in a way that it can do it exponentially or quadratically faster than any existing supercomputer or even future supercomputers, right? Um, yeah, so I will not go into this. I'll just say that, quantum computers today are built in the form of small chips. And these chips, like I said, they have, interconnections. And what you are now seeing is, quantum computers in their very, very early era, where they are noisy, where they have to be super cooled, where they are, placed in these refrigerators, and they are this size, they're very, very small at this point. But as I said, that scaling is occurring by interconnecting some of these chips and going to a point where you are able to put all of these together to build this quantum supercomputer. So that actually was a quantum, data center basically. You've all heard of data centers, so a data center is where you place all these computers, and today everything is on the cloud, so we don't get to see these data centers. But that picture which you saw was of a quantum data center. It does not exist right now, but in future you'll see that multiple processors will be super cooled and they will be kept in these large data centers where you will be able to build these large processors, and that's what will take us to quantum advantage, as I said. So I'll stop there and we can open for any questions or any comments that anybody has.
Questions?
So during the course of your presentation, you mentioned about the synthetic aperture radars.
Yeah.
If I'm not wrong, sir. So does this also use quantum computers for this technology?
No. No, it does not. Okay, and the future radars, so I didn't go into the maths of it, but information theoretically, it has been shown that quantum, radars will be, the mutual information there is much higher than what is possible in today's, radars. And that's where, you saw that SNR curve, which I showed you. Today's radars will not work at 0 SNR, but in future it is expected like that they will be able to, the quantum radars will be able to. And not only that, they can possibly also detect the payload that is there in that aircraft.
Right. Thank you.
Anybody else? Venkata, I have a question on a little larger spectrum. As you mentioned today, the governments are spending a lot of money on the quantum revolution. But if you remember our student days, the communication revolution happened more by the private sector, right?
Yeah.
But there are several advantages of an open system where the private sector drives things. I think the collaborations become much easier. But now things are probably getting into more of a strategic dimension. So there will be a lot of restrictions also, right? If the governments invest heavily, then they also put a lot of restrictions.
Yeah.
So what would be your thoughts on this aspect?
Yeah.
Because it will not be available for a common user to that extent.
Yeah, so I'll tell you, so the government, especially the Indian government, is getting into this because what the government has observed is that the Indian industry is usually not very keen to do R&D. Okay, so they've observed that if you look at our software industry or anything, we are more focused on the services opportunities today, right? When it comes to product development or research and development, our industry has not always stood up and invested big. Okay, so one of the reasons why the government is investing big is to do this, to ensure that even if the private industry does not come in fast enough, India does not lag. Okay, so that's one. Secondly, the other thing the government is doing is it is now investing in startups. Okay, it is saying that okay, the big industries, okay, they're taking their own sweet time, they're not coming in. How can we enable startups? So a lot of this 8,000 crores is also going to go into startups. Okay, to enable them to solve point problems. So tomorrow, if there is a startup which wants to build these quantum radars, the government is going to invest in them. So you're right in the sense that if you remember supercomputers, it was a technology which was not given to India. We had to build. CDAC came about just to build supercomputers in the 90s. Nuclear, 2007 we signed that, and still a lot of that technology is not shared with us, right? Rocket technology, rocket engines and all of those. So the learning has been that we need a local industry, otherwise we don't get a seat on the table, right? So that's what the government of India is trying to do, which is to build capacity, build skills in these areas and build technology, so that this time, we are on that table when, nations are talking about quantum. We don't, we are not the people who are sort of told that, okay, you can't use this technology. But that to do that, as I said, we are a software nation. In hardware, we have been struggling. It is still a struggle. If you wanted to build a hardware lab today in India, 90% of your components you are going to have to import, and there are various restrictions placed by various countries on those components. So it's a very hard thing to do, but that's where this is. But to your question, Arnab, it is very true that as more and more governments get into this is going to be technology which people are going to keep very close to themselves for the next 20, 30 years. Even the companies which have built quantum computers, for example, IBM, Microsoft, Google, they are not sharing that technology for any time soon, right? We are happy to build use cases on top, happy to have people use it, but that processor technology is going to be protected. And so one of the things the government is doing is pumping in money into some of the, for example, TIFR, where a professor is actually building a quantum computer, India's first quantum computer, right? So yes, I mean, there is a need. There is also, regulations which will restrict us. There is also the fact that, local industry hasn't kept up in certain areas. So we need to especially, give it a push in that.
How do you compare the national supercomputing mission to the national quantum mission that you mentioned?
Yeah, see, the national supercomputing mission was somewhat easier, because what did the supercomputing mission do? They bought processors off the shelf, okay, from whatever NVIDIA and Intel and all of them, and they interconnected them, right? So these were what did the supercomputer was built using components which were freely available. Okay, nobody said that you can't buy a Pentium. What did they do? They put all these Pentiums together and built a large supercomputer, right? That's how they did it. But in quantum, that processor today is not freely available. If you were to go to the market and say, give me a 100 qubit processor, there are 4 companies which know how to build it, and they are not sharing it with anybody, right? So we are now but in the software area, India is very, very well placed. Okay, like I showed you all those usages of quantum computers across the world, Indians are shining, right? Indians are the people. Every company wants Indians to use their computers, because they know that if Indians don't pick it up, nobody, it will be a failure. So if whether it's Java, whether it's Python, unless Indian software engineers get behind it, it doesn't succeed, right? Same way for Qiskit or any software language in quantum. But it's the hardware technology which is protected, which is at a very, very nascent stage at this point. And that's why, you need government support, because it requires crores of rupees, which private industry is not willing to put in, at least in India. And we don't have well-funded startups. So in that sense, this mission is much, much more early. It's early stage in that sense, because the technology is still developing. And if India were to, one of our scientists were to develop technology, it can suddenly put us in front, right, in front of everybody else, right? So there is an opportunity here as an early mover to make a dent. And that's why, all these governments have put in these national quantum missions, because you have an opportunity to shape the future here. Okay, and anything else?
Venkat, I have a question.
Yeah.
Or an observation, or whatever you can call it. Thank you. It's a good thing for me. I've been reading about quantum, but I didn't understand. Today I understood. Thank you very much. Now my question is, we haven't done very well in uh, you know high speed computers in the fabrication area. We haven't done well. If some effort is going on, it's just started. So with that kind of a thing, by putting by government putting money for in this area, where are the people who are going to do it?
Yeah. Actually, that's a very valid question and it's a tough question. Okay, so
Because you're in the line, so I'm just asking.
yeah, yeah. So I'll tell you, for example, in IBM, we have spent billions of dollars. Okay, we've spent 30 years developing this technology. And what is the government saying? It is saying $1 billion, 8,000 crores is 1 billion basically. And saying that with that 1 billion, build a super, quantum computer for me in 2 years. Okay, so that's sort of the timeline. It's a compressed timeline, smaller money. And like you said, there is no existing backbone structure in India to support it. Okay, so everything has to be built from scratch. Yes, there is a superconductor, policy that has also come up in India, where we are setting up all these fabs, superconducting fabs. Sorry, semiconductor fabs. Okay, where we are saying we will build these chips, and all these are very much necessary components to build a successful quantum computing industry around us, right? So yes, I mean, there are, so how, 8,000 crores, it just flies away, like that. It's not enough for anything. But that is where the challenge is, and I think that's where the government is also struggling, to say that in any deep tech area, there are a handful of experts. I can take the naval thing that Arnab is trying to do. So how many experts are there? There are a handful of experts, and all of these people will have their own views. All of them will want some money for their pet projects. So it's a very, very tough thing, and really honestly nobody knows the answer to your thing, but everybody wants that India should succeed in the next 10 years, that we should be up there in terms of quantum computers. And yes, we are all trying, those who know anything about quantum computers, the government has all these committees and it has all these funding agencies through MeitY, through DST and all these, where it's trying its best. But yes, I mean, it's a very, very tough thing to achieve at this point, given that we have not set up the basic infrastructure.
I'm not. I don't expect that something will be achieved today or tomorrow, but even to set the roadmap and the small steps, there has to be, as you rightly said, some fab, there for you to start off. I don't see that happening unless, of course, you're again bringing from outside, which you yourself said in this area it is, not, it will not be given.
Correct.
So therefore, while we want to be there, I totally agree with you. 8,000 crores is pittance. I don't know what they're going to do with it. And as you say, the Indian industry is not going to put anything in it except use this, whatever grants are coming. I see that, as you said, no, there are extremely willing people like you, but the issue is, I think the means are not enough. This is my thing. The means are not enough, and it may not be enough today. But is there a roadmap? Is there a thing to
There
continue?
is a definite roadmap. Yes, there is, and so the government has come up with a roadmap with the help of some of the top scientists in IIT Madras, TIFR, all the top people, brains in quantum, have come together. They are also, there have been interactions with the U.S. government, U.S. scientists, Finland, Europe, all these areas. There are things happening. Okay, so in Pune, there is a place called iHub, Quantum Technology Foundation. It is in ISER Pune campus. So there is Sangeeta Maini. She's the CEO of this new company called iHub QTF. It's a Section 8 company where the government has put in a few crores, a few hundred crores there. So they have actually set up a physical space there and they have actually built some things also. Okay, so whoever is in Pune, feel free to reach out, and I'll be very happy to set up a meeting with Sangeeta and her team there. They're doing some very nice work. Yes, I mean, so the point is to start somewhere, and they have made that start. Similarly, the government is coming up with 4 more hubs in India. Okay, just like iHub QTF in Pune, there will be 4 more across the country, and CDAC Pune could be one of the contenders because they have successfully run the supercomputer mission. So they will also get some role in this quantum mission also. Okay, so all of that is happening. It's not all pessimistic, it's all, there are positive things happening, and I think we need a lot of young people, especially people who want to do startups, people who can, because the government is really, really willing to give a few crores to such startups which demonstrate value and which say that I'm going to solve this one problem, and I'll do it sincerely. I think then the government is willing to back them.
Very good. Thank you very much. It's a very, very, what do you call it, heartening, and to see that there is a mission, and there will be continuity.
Venkat, that was Admiral Varma, who has worked with Professor Behel very closely. He was also part of CARE many years back. So
I see. Okay, nice.
So 3 of
Yeah,
us.
I'm also a care person. Okay, so by induction, I know a bit about the Navy. Yes.
Actually, when I was doing my MTech, Behel had just come from IIT Kharagpur and Anshul Kumar from Delhi. So these are my team, Shane, etc. were there. But what I want to basically say that once I finished my MTech, I was retained like Arnab, because there was a project which the Navy had given. We were working on that project. And while doing that, Professor Indresan said, let us do something for the Navy. And that's where we set up CARE. I was in the initial stages of setting up. So I'm not from CARE. I'm, one of the involved in setting up. But then I continued for another year and saw that the CARE was set up and the first batch of people had come in.
Yeah, you did a great service, I must say. I did my PhD from CARE from Dr. Behel. It was great that you set it up and future generations like ourselves could, graduate from there and learn and contribute.
No, before I, take all the accolades, I was one of them. The professor was involved and Navy was kind. And DRDO gave me the grants to start that. Otherwise, I would have been as anyone. So I got a lot of PhDs from there.
Yeah, thank you.
I think, Venkat, we all agree that it's an ecosystem which has to be created.
Yes.
And an ecosystem is always created by many people. It's never an individual. And
correct.
Because not only many people, it also takes a long time to evolve.
Yeah.
So I think we all can take pride in.
Yeah, and Arnab, great work you've been doing. I follow you on LinkedIn. Okay, that's where I get all my knowledge about you. But great work, and we really need this kind of effort. So thanks.
Thank you, Venkat. Thank you so much. And you were definitely going to be part of many of our such workshops, because this is a very important component of the UDA framework. I mean, the whole computational infrastructure, the computational computing backbone is extremely important. And I'm not sure if you know, we had Dr. Ashish from CDAC before you in the morning today, who spoke about the supercomputing mission. And it's so good to hear from you, because you have been part of this and you are at a very top level of decision making and the whole shaping up of quantum computing in India and globally. Thank you so much, Venkat. Really appreciate you joining us.
Thanks a lot. Bye.
Yeah, bye. So we'll break for tea and we'll come back. And before we start the next session, we'll have a small interaction with, because we have not had a interaction with our participants. So I'm sure you'll have some questions and some queries and some administrative requirements also. So we'll go for tea and come back quickly, and then another 5-10 minutes, and then we'll start the next session. Thank you so much. Okay, welcome back. Sorry, in the morning we didn't have enough opportunity to interact with all of you and welcome you. There are many more people who are supposed to be joining us, but for various reasons, they will be joining probably as we move on. But at some point, we took a call that we should just continue. It's difficult because people are coming from diverse places, diverse locations, diverse organizations. And some people have their, this is also an exam time that is going on. So some students have a difficulty in that, although they have been deputed by their institutions, but they've not been able to make it. But we at some point took a call that we'll continue with the proceedings. Everything is available, it's going to be available online as well. So if you have missed any time in between, you can always catch up. So what I will do is I will start from one end, and I will request you to kindly introduce yourself. Don't have to get up, please. Please continue to sit. Just tell us about who you are, where you're coming from, any expectations that you came with. And I think we are close to the end of the first day. You can also give your impression of the start that you had. And also what we will do is we will have the online registration done by you. Where's Mehul? So just the link can be shared with them so that they can register online. You have to just fill up your details, and then you are in touch with us. So whatever information is required, that will be shared with you. Or if you have a query, you can also, get back to us with whatever queries you. So can we start from the other end? Can you just speak out your name, as I said, your name, where you come from? What you are doing right now, and what were your expectations when you came here?
यहाँ से मतलब जब मैं यहाँ पे मॉर्निंग में आया था, तब मैंने जब स्टार्टिंग में देखा कि सब मरिंग के बारे में जब जो भी इंफॉर्मेशन दी जा रही थी, तब मेरे दिमाग में यही थॉट्स है कि मतलब ये हमारे फील्ड के रिलेटेड नहीं था, लेकिन जैसे जैसे लेक्चर्स होते गए, सेशन 1 by 1 होते गए, सो ये कनेक्टेड हुआ. जैसे कि आने वाले भी कुछ सेशंस लाइक मेटावर्स, डेटा साइंस, और जैसे कि सुबह कंप्यूटिंग के बारे में जो भी इंफॉर्मेशन दी गई, वो सब.
Thank you. Next.
My name is Dattu Korde. I'm from Modern College, Ganeshkin. I'm student of Strategic Studies. I came here to know more about Indian Ocean region and the recent developments and future in region and future of Indian policy and study related there.
Okay. Thank you. Yep, go ahead.
Yeah, my name is Sumit Kumar. I'm from Delhi, but currently living in Pune, and I'm pursuing MCA from DY Patil Universities. When I came in the morning, and I saw there are many sessions which are going, and these sessions is related to the IT, like cloud computing and the quantum computing and the data science and metaverse. And these session will organize. It will be help in future for the related to the deep knowledge. Thank you.
Thank you.
Hello, sir. My name is Aditya Raj. I am from Pune, and I am the student of Master of Computer Application from DY Patil Institute of Technology, Akudi. This session is so interactive. I can learn many more. I can learn many more things about it. I can also learn about supercomputer, custom computing, and this also enhances many types of information and also beneficial for the future. Thank you, sir.
Thank you.
Hello, my name is Nandini Parkache. I am from DY Patil Akurdi. I am pursuing MCA. All sessions are very informative and useful to us. Thank you.
Hello, this is Mr. Vaibhav Kulkarni, MBA faculty from MBA department, DY Patil Institute of MCA Akurdi. I also was feeling the same, that what is my or our domain's relation with underwater. But after coming here and attending this session, I feel very happy and finding multiple opportunities, particularly for even for MBA students even, and as a parent again for my child even future. Thank you.
Thank you.
My name is Naveen Shaju. I'm from Kochi. I'm a final year BTech student studying marine engineering. And since we are representing the Institute of Marine Engineers, I'm a student member of Institute of Marine Engineers India. And the program here over here is since related to our occupation. It's very useful and helpful for my future plans.
Thank you.
My name is Vaishak Menon. I'm also coming from Cochin, Cochin University of Science and Technology. We three are coming from Camp School of Marine Engineering, studying in the, for the final year. I felt it is good to have a workshop like this, which has all the topics. I think all the topics that the MCA students, ourselves and all feel helpful. Thank you.
Thank you.
Good evening. I'm Anupa Roosha. As you said, we are representing Kunyali Marikyar School of Marine Engineering, KUSAT, and we are members of IMEI. And as this whole workshop is related to marine industry, we are really happy to be here. Thank you.
Thank you.
So we are from marine industry. Can you hear me, sir?
Yes, sir. Please go ahead.
Yeah, sir. We both are masters. My name is Captain Paramjit Singh Gutra, and we are from marine industry. And right now we are teaching and giving training to the future students of marine industry in Chitkara University, Punjab.
Yeah, myself, Captain Ajay Bhardwaj, and I'm the course in charge for the nautical science over here. And we have about 90 students for the nautical science. And I have sailed about for 33 years at sea. And out of which about 16 years was in the captain level. And we have come across many of the topics what were taught in what were going on, and we have been monitoring this one. Your session, they're wonderful, and lot of information we got it from this workshop. I would require that in future more and more such workshops are created and we can join that. So we have certain things related to the problems associated with the sustainability and regarding the topics of this underwater domain. So my friend will go ahead with this and we can have your answers for this one.
Like instability of the government, which gives changes in policies and which slows down the process, increases the cost with time, and lesser involvement of the marine people, seafarers, for taking decisions or making policies or anything connected to this. Then we have seen that
take them into consideration.
Yeah.
For decision making. Only a suggestion.
And we what we feel is that under major body we should have some small committees or bodies which can take various tasks individually and explore or make more research on that, like initial surveys of various states, all the states, and we should be able to go and make the locals aware of the system or whatever is going on, whatever the government is trying. This is a very good system which will give us a lot of opportunities. Okay, here we can use this one and conclude this one by doing some smart shipping to lessen the impacts on the environment, like fuel to be used by the ships and all on the coastal region whenever they are flying. Like some of the countries in the world, when we have traveled, they have told to change over from the diesel oil to the just less than 0.1% diesel oil to be used in the generators and everywhere. So they are monitoring the pollution by the laser guns in some of the states like Los Angeles and all. I mean the port authorities. And if the exhaust from the gases from the funnel of the ship is exceeding the limits, pollution level, then the ships are fined for that one. So it's so many ships coming and going in the ports. So the technology over there being used for this one is some kind of laser guns, and then they monitor the pollution from the ships. It will definitely harness the renewable energy also should be there. Then it will create jobs and reduce the poverty and what my friend has said. So from the coastal states, when such a things are done, then it will create jobs, reduce the poverty and all, and end the hunger also of the coastal people. That's it from my side. Thank you.
Thank you. Thank you, sir. I take your point, but I'm sure you will appreciate policy making has multiple dimensions, and that's what we have tried to cover in our previous workshop also. And what you are saying is true. There are some gaps to be covered. There are some distances to be covered. And I think the awareness of everybody, I mean, as I mentioned in the beginning, the government is also very conscious. This is a very big country with a lot of diversity. You make a particular policy, there will be winners and losers. There will be some communities will be extremely happy that their issues have been resolved, but then there would be certain communities which will be on the losing side and they will be not so happy with that. The idea of governance is to minimize the number of losers and maximize the number of winners, right? So, but at the same time, now how do you decide who are winners and who are losers? What is the time frame that you're looking at? Are you being short-sighted that immediate winners and losers you want to declare, or you're also looking, like when we talk about sustainability, when we look at climate change, it has to be a long-term perspective. So we have tried to cover as many aspects as possible. We are not here to claim that we can solve all the problems. We are only giving certain tools or certain directions, or we are probably providing a platform where more and more people can come and participate in the discussion, which will make it a better world. So that's our effort. And sir, I take your point. We will continue with this discussion. We'll be happy more and more of your students and faculty join this. There'll be many more events MRC is going to do. In between, we had, because of the pandemic, we had gone into the online or webinar mode. But now we have started the physical and the hybrid mode. There will be a UDS summer school, which will be done in the summer. We'll be happy if some of your faculty members and students come and join that. It's a 5-week program, which will be very intense, but I think people will gain a lot out of it. So we'll continue with this conversation. Very happy to have you and give your comments, sir. Thank you so much.
Thank you, sir. Thank you.
So we'll continue from this side. I think they've just come new, so we can start from here. Were you there in the morning? Okay, sorry, please go ahead.
Myself, Anurag Pulikotil, and I'm a first-year MTech thermal engineering student at COEP Technological University here itself. The sessions conducted were great and very diverse. We got a lot of exposure and very informative regarding underwater domain awareness and how we need to still dive into blue economy. That is, we need to utilize the resources which are available under the sea. And great session, great initiative by Maritime Research Center and as well as to COEP University for arranging for the arrangements. Thank you.
Thank you. Okay.
Yeah, we all are from COEP Technological University.
Okay, sure. Please do register your name in the online platform, which will be shared with you.
My name is Vijay Chauhan, Senior Intelligence Officer, Maharashtra State. Workshop is good. Yeah, I take a good knowledge. Yeah, UDI is very helpful to our branch.
Thank you, sir. Thank you. This is the beginning of our conversation with your organization, and we'll be happy to interact more, sir. Thank you.
Jan sir. Sir, I'm Captain Varma, sir. I'm coming from 75 OMC Bhuj, sir, Gujarat. Sir, it was a very enriching and eye-opening experience for me, sir, to hear from various dignitaries and speakers here, sir. Got to know a lot of information which I was not aware till today morning, sir. A great initiative by MRC, sir.
Thank you.
Jain, sir.
Thank you. Thank you for coming all the way from Bhuj. Thank you so much.
Jain sir, I am Lieutenant Commander Amit Kumar Tiwari. I have come from Weapons and Electronic Systems Engineering Establishment, Delhi. Sir, my association with Navy since 2016, I was the commissioning crew of ASW Corvette. So again, I am into the underwater domain. Then I have done my MTech again in underwater signal processing from the IIT Delhi. And now since past 6 months, I have joined VESI. There I am working with the CMS and the Saransh group, again the underwater. So sir, this is the very good platform for all of us, including the naval personnel and my army course-mates and the colleagues, juniors. So sir, I am also looking forward to this opportunity where I can also share my experience and I can learn from the dignitaries and the very senior colleagues here also.
Thank you so much. I think you brought in a very important point. See, the idea of getting so many diverse set of people also is a peer learning format. And see, nation building cannot happen in isolation. So I would also request all of you, I mean, senior people like all of you coming from the different services and various other backgrounds, but also the young students. This is an opportunity for you to make friends. These are people who have very diverse understanding, like as he mentioned, but even in the Navy, you'll find different people we have different branches in the Navy, and not just branches, everybody will have a different experience also. Navy is also a very big organization, and Army is much bigger. You know, the numbers are very, very different. It's unimaginable. I mean, even among the three services, not just the color, but the way they function, the way they deploy themselves, the way they conduct operations is very different. So please use this opportunity to talk to them. I mean, whenever there is a break, please go reach out to them and understand where they are coming from, what kind of requirement, and it is possible that you may find an opportunity. I mean, youngsters from COEP and other colleges, if you are looking at a startup idea, they are your clients, right? They are the users. So they will be defining what you need, what they need, and what the nation needs. See, finally, it's a nation building process which all of us are trying to contribute to. Irrespective of who you are, I mean, somebody in the Navy, somebody in the Army, somebody like us trying to, come from outside and contribute. And you young students have a much bigger role to play. I mean, you are the future generation. So please use this platform to interact. I'm not sure if we can share but it is better that you take the contact details. It may not be appropriate for us to share everybody's contact detail across the platform. Probably we'll not do as an organization, but when you meet them, and if you can find a good connect, and if they are willing to share their contact details in future, you'll find a contact in these organizations. So please feel free to reach out to them, talk to them, and 5 days is a very good time for you to build those connects. So young people and even senior people, you can also take a feedback what the environment thinks about our service and our organizations. Is there something, some positive inputs that you can get? Your turn, please.
So Jain sir, I'm Major Sumit Kulkarni sir. I'm coming from Trivandrum sir, representing my formation Indian Army sir. I've been detailed to attend this cadre sir because my formation is a amphibious formation sir, where again as you have mentioned that we have to work together like my battalion will be deployed with the Indian Navy, where from this cadre, sir, I am expecting that I shall be able to understand the nuances and dynamics of the water per se, sir, so that the same can be implemented at tactical level, at junior level in my battalion. so that the same can be implemented on ground, sir. And again, the same thing, sir. This is the first exposure. Today is the only first classes which I am attending apart from land and air, sir, about sea and water, sir. So now my mind has already started. I'll keep this opportunity for asking questions, sir, because by these 3-4 days, sir, I will be able to gather much more information, and I will be able to formulate my questions, which may be definitely required for me to get them along, sir, and to my battalion, so that we can implement on ground effectively, sir. Thank you, sir.
Thank you so much. I really appreciate, because in fact, while you were speaking, I got this. As I mentioned earlier, I would request all of you to write something. It would also be some of the issues you think are relevant to your thoughts on UDA. If you write it to us, and we have this platform UDA Digest also, and if you can write it in a form of an article, we can also publish it there, and there is no restriction in publishing in that. Maybe you should definitely, people from the services must inform their organization before you put it, but we would welcome this kind of a thing. And our naval regulation actually says if you're not criticizing your organization, or if you're not putting your organization in poor light, you're free to write anywhere actually. So if it is a very open pursuit of knowledge, or sharing, because see, this is a platform where we share ideas with each other. So please feel free to write to us, and we would, if it is relevant to publishing in the Underwater Domain Awareness UDA Digest platform that we run, please feel free to put it there, and we'll be happy to. But it is also for us. I mean, the idea that I'm inviting you is not to, give you gyan. I think you all have your own ways of getting information and knowledge, but it is also to learn from you. What is it that we can do with you? Like, you have people coming from the Marine Police also, and we have reached out, and we are so glad that, your leadership has, because I know it's not easy to spare people at this seniority and it's this level to come and spend 5 days with us. I've been part of the service for a long time. I fully understand. So I really appreciate your leadership's vision, and also your effort in coming all the way and attending this. But I would like to take it to the next level. Please feel free to write to us or even interact. And I'm here. All the days I will be here. Please exchange. And even when we have resource persons, all of them are very close to me. If you ask any questions, nobody is going to object to your question, whatever it may be. Don't feel, no question is stupid, let me tell you very frankly. Please feel free to ask questions, and not too many people are there, so it's better, you have the opportunity to ask as many questions. And I'm also available all the time to answer whatever, or find an interpretation from the UDA perspective to whatever our honorable speakers have been speaking. And I think you will appreciate, Venkat is leading IBM's. I think these are the best people one can ever get to speak on certain topics. Even Dr. Ashish is heading the CDAC thing. So we have tried to get people from different. Tomorrow, Dr. Vijay will be speaking to you. Vijay is my coastmate in the Navy, but he is a professor in IIT Chennai. And again, somebody who has spent a lot of time. He's been part of the Navy, but he did his master's from IIT Chennai, and then did his PhD from IIT Delhi, spent another 10 years in IIT looking at R&D for the Navy and the DRDO. And now he's a professor in IIT Chennai. And today also he's part of a very important department in IIT Chennai, doing something very, very important. So please use this opportunity, and we are here to facilitate whatever we can. Right? Please, sir.
Sir, I'm Captain Bhatia. And thank you so much. First and foremost, this is a very, very great initiative by MRC. Very frankly speaking, when we come in the morning, we thought probably it'd be a series of lectures. But here, after coming to this place, you realize this is a workshop which is totally on a different, the setup of the whole thing is absolutely different. You got online people who are available. You got lovely speakers. You have people from various diversities of various fields. Navy definitely is a big stakeholder as far as the underwater domain awareness is concerned. And I have been attached with this particular thing for the last couple of years. But then what I realized after coming here also is their scope is very, very vast. It is not that, it is in fragmentation or something. And this initiative of yours to get so many, various facets of people together under one particular workshop to start off, I mean, this is a very, very great initiative. And we are at the very, very beginning. If you look at it, yes, definitely we're at a very beginning step of it. It's a long journey to go ahead. And but the initiative that has been taken is certainly, it's a great initiative, and looking forward to the next 5 days or the days to come. And thank you so much. And lovely, I mean, the speakers have been giving those talks. I mean, very informative. Thank you so much.
Thank you. Really, coming from you makes a lot of difference. I think we have the same seniority in the Navy, and so it definitely means a lot. Thank you so much, Captain.
Good evening, sir. I'm Commander Swapnil Totre. I'm an anti-submarine warfare specialist, and I'm posted at Maritime Center for Doctrines and Concepts under FODC in Karanja, Mumbai. At the outset, I want to echo sir's thoughts and appreciate the Maritime Research Center for being at the forefront in organizing these workshops and bringing UDA to highlight what are the various actions and plans and various issues in place, and bringing all various stakeholders together, sir. Sir, whilst we are discussing in the today we discussed the UDA framework as well as the various technological aspects. I want to request that if in case possible, could there be a session which discusses the UDA frame roadmap of the nation towards building a UDA framework, and what are the various plans and in place by government or certain other agencies. This would help us to know that, okay, how the UDA framework is going to be established and will shape in the next decade or so.
Yeah, great. I mean, that's a very important question. We have less time now, but although I don't represent the government in any way, but I'm very proud to say that we are definitely interacting with the government at very different levels. So I will be happy to share whatever initiatives that we have been part of. But I know, like Navy itself, there is a massive there is a lot of activities going on, which is probably not in the open domain. So I cannot definitely talk about that. But similarly, there are other organizations also which may be having their own thing. I will share a broad perspective that I have with probably only advantage I have that I've been driving this in a very focused manner. So I get to meet people, hear from people. So whatever is possible for me to share officially, I will definitely do that. Maybe not today because there is another presentation after this, but your point is extremely important. And I think people who are attending this workshop deserve to know that. So I will definitely talk about it. Yep, definitely in the next couple of days, because you'll also get to hear General Khandare joining us from Ministry of Defense. He's advisor to the Honorable Raksha Mantri. He has been the military advisor to the NSA before, so he has been in the forefront of decision making at the top level as far as the strategic security is concerned. You will hear Mr. Avinash Mishra from Niti Aayog. He's a senior advisor looking at water. And he's the one who was instrumental in driving one of the projects that we did for Niti Aayog in terms of capacity and capability building. So you'll hear from him also. So let's hear from them, and then I can probably piece it together in a more comprehensive and inclusive manner. And we'll also hear Admiral Ajay Kochar, sir. He's a senior naval admiral, so he also has a perspective at the top level, what the thinking is in the Navy. I don't know what all he will be happy to share or what he would think that can be shared. But let us hear from him also. But I will definitely piece together various aspects that we have been working at. And I mean, last week we had Mr. Hemang Jani, who's the Secretary Capacity Building Commission. So that is another very important organization. Then globally also, the UNESCO and we had representative from UNESCO, we had representative from Intergovernmental Ocean Commission also at the top level. I mean, Vladimir heads IOC. So I will try and piece together, what we heard and what we, because it may not be appropriate for me to give an official kind of a thing, but I'll try and give you a sense of what is going on. A very good question. I keep note of it. Thank you so much. Yes, sir. Divya, can you? Okay.
Good evening, sir. I'm Deputy Commandant Samir from Indian Coast Guard, and I've come from Coast Guard Air Station Daman. And my unit basically specializes in search and rescue missions and also a bit of pollution response. So coming here, I'm expecting a lot to learn with respect to the maritime security and maritime disaster management also. And if there could be sessions on understanding marine environment so that pollution response measures can also be chalked down and policies can be made which are still in existence. However, it can be refined further. So expecting to learn more of the underwater domain environment so that can broaden my vision and help the organization.
Thank you so much. We will definitely talk about underwater search and recovery. I'll use the word recovery, not rescue, but I will relate it to the mandate of Coast Guard. I've served in the Coast Guard for more than a year, and also marine pollution. We will definitely address that. Right? Thank you so much.
Hello, good evening everyone. Myself Aditya Thakre from CYP, second year project management. सर डे 1 से ये वेबिनार में अटेंड कर रहा हूँ. यहाँ पे मतलब राधिका मैम का जो सेशन हुआ था वो काफ़ी अच्छा था और ओशियन हिस्ट्री और ओवरऑल हिस्ट्री जो उन्होंने एक्सप्लेन की थी वो काफ़ी अच्छा था. और प्रफुल सर का जो सेशन था कि ओवरऑल लॉजिस्टिक्स अराउंड द वर्ल्ड वो काफ़ी अच्छा था, जो कि उनका जो एक कोट था कि समुद्र भारत और समुद्र भारत, अगर ये जो सेशंस चल रहा है अच्छे तरह से इम्प्लीमेंटेशन होता है इसी के बारे में जो डिस्कशन यहाँ पे होता है तो डेफिनेटली वी आर अचीविंग अ समुद्र भारत एंड समृद्ध भारत. Thank you, sir.
Thank you. Aditya is more qualified because he has attended from day 1. Thank you, Aditya. Yep.
Hello. Hello, everyone. I am Dipali Patil from the Vishwakarma Institute. I am from civil background but interested in marine engineering. This workshop has been an eye-opener for me. I got to learn too many things. Thank you.
Thank you.
Good evening, everyone. My name is Shri Wagmare. I am also from Vishwakarma Institutes and I am in final year of civil engineering. I have been attending from day 1 from the workshop 1 also. So at the beginning, I didn't know about the marine engineering and all related topics. But from day 1, I have been learning about MRC, what is MRC doing, what is UDA. Even I have been through the UDA digest also. So got to know about the various projects, and this workshop is letting us know that what is actually required right now. So the need of our India, need of the country. So I hope to learn more from this technology intervention program, and we'll attend all the workshop series. That's all from. Thank you.
Thank you.
Hi, sir. A very good evening. Sir, I am Karthik Binu. I am coming from Kerala, Ernakulam. As a student representative of Institute of Marine Engineers India and Kunyali Marikya School of Marine Engineering. I'm a final year BTech student in Marine Engineering and I'm having 2 publications in my name. So I will be considering writing for your MRC Digest also. I haven't heard of it before, but yes, sir, I will. Sir, just a suggestion from my side. Not a suggestion, but a question from my side. Like we are marine engineers and as Captain Ajay sir have suggested, said that there is little to no engagement of the sailors in the policy making or the decision making of whatever it may be for the UDA, especially for the UDA, because it is concerning the matters underwater. Because we are trained to this course which we are studying and our entire life we are dedicating it to operation and maintenance of ships and just ships. Not submarines, not other, not even the diving support vessels. Some like the engagements which we are having in the underwater domain is really limited. But still, we are one of the major role players in this sector. So, what do you think that, or how can we actually be more involved in this thing with the limited amount of power that is vested upon us? How do you think that we can be involved in the underwater section?
Okay, thank you. It's a good question. See, we are a democracy, right? We are the policymakers. Who else can drive a policy? We all are involved. I mean, what is MRC? It was just an idea some time back, then it became an organization, and now you see we have so many people coming from all over the country. It is just about getting together, getting everybody's view, coming out with a balanced approach, and then reaching out to the government. See, government cannot, I mean, we are what, 1.4 billion people, 1.4 billion plus. Government cannot reach out to, you should have heard what Mr. Hemang Jani said. There are 30 million civil servants in this country. I mean, as far as you are concerned, or I am concerned, what is government for us? If I have a problem of I need a license, I go to the RTO office. The person whom I deal with first is the government for me, right? That is, a government doesn't have, it has several faces, and there are so many different people who deliver the services of the government. I mean, finally, the government is delivering certain services, right? And also there are private entities which are engaged by the government to deliver governance or to seek inputs. So initially when we started off today, the government is also giving us an opportunity to reach out to the government and suggest. See, finally it will be the government's prerogative or whosoever is at the key person. So even say we as MRC, we can write a policy paper and reach out to the government. Then the government will consider all these options, and not just us, probably another 10 organizations would have also petitioned the government to say, something. Many of us feel that nothing will happen, so we don't do it. See, when I started MRC, many people thought I'm a mad guy, right? But you have to still, I mean, if you love the nation or you want to do something for the nation, you have to start something. Even what is underwater, or there are so many people working on cyber, there are so many people working, like Venkata is working on quantum. There are so many, and nation requires so many different dimensions, right? So none of us are small or big. All of us can contribute. We have to have a focus. We have to continue. We have to show some credibility also. How does the government know that you are serious? You'll not run away after 2 days or 2 years or 5 years. So what we have built up is over a period of time, right? Now people think that we are not going to run away. We are going to contribute. So that is how it happens. I mean, it's not just me. So many other people. So, like I said, UDA Digest, we have put 60 articles in the next. Now we are putting almost 10 articles a month, which is, I think, quite a lot. I mean, when I started off, that was my biggest worry that will we have, but now we have more than 10 articles a month coming. So my editor is not able to even complete the editing part to include 10 articles in a month. But, it grows. And now we have started this physical form. So when we have more and more people spending more time with us, they will have ideas. They will come back to us. Now, what you write to us, we are going to do some deliberations. You met Admiral Varma. They are some of our core advisors. We have some very senior people who are advisors, different advisors. If you go to our website, you'll see who all are there. So we will get them all together. We'll put it in front of them. They have people with experience, and also they know the government system. So they will give us advice. Then it will go to the next level of starting some projects on it. Now, whatever we say, it takes us at least 3 to 4 years to come out with some tangible answers. It goes through multiple, we get about 300 applications from IIT for internship. BITS Pilani also sends a lot of people. So we give them different projects. In 2 years of projects, something progresses, some ideas mature to some extent, then another set of people, and these are multidisciplinary. Earlier, some technology student does, then a geopolitics student will come and add that particular dimension to it. Then some social science student can come and do something else. So over a period of time, this becomes, then we look at a policy framework, what kind of enabling technologies can come in there. We also look at traditional knowledge, how it can empower. So it takes a couple of cycles to build up to a level. Once that happens, then we reach out to the government to say, oh, these are the ideas that we have, and please listen to us. So right now, I can say there are about 10 different directions that we are pursuing very seriously. But it has taken, each of those projects have taken at least 15 to 20 top caliber students from IITs, or even we get students from TERI, BITS Pilani, who have come and worked with us, and even many other institutions. I'm not just naming them. And who come and work with us, and over a period of over multiple iterations, they mature. And we are a truly multidisciplinary organization where all kinds of students come and work with us, and then it goes to the next level. So, I mean, I must assure you that I think truly in this country, there is democracy and people are listening to us. I mean, in this itself, if you see the number of senior people who are coming to us, what are we? We are a private organization, but they feel that we are doing something serious. So they are coming down. Even government officers are coming down, senior government officers. And you see the senior people from the services are coming to attend this. So it is not about that they are coming to learn alone. They're also here to understand the ecosystem, what's going around. They're also to tell the ecosystem what should be done. And then only we build up something which is more formidable, more strong, more comprehensive, more inclusive. I mean, they're all in, some of them are in very senior decision-making positions in the Navy and the Army and other places. We have Marine Police also. They also understand, what is the scientific community doing? What is the industry doing? What is the private sector doing? What is the academia doing? What are others thinking? They also go back with all this. And then when they sit in their chair and decide, it gives a far, they also will. That's why I'm telling all of you, please interact with them. You will, because when they are sitting in their decision-making chair, they will remember, oh, this is something which is happening. And many big organizations also have certain blue sky interactions. Like I put Lakshmi here. Somebody may say she has got no connection with this, but don't you see a connection? So that's all, is the effort. Even Kishore Mandya sir has been in the UN for 25 years, but he has a larger perspective. He is seeing the globe differently. So he can connect a lot of things very differently. But it is also to tell him about this, because when he interacts with people at the top level, he thinks of UDA. That is important. Because everything has a connection. So I hope I have answered your question, and we'll continue with this interaction. So I'll hand over to Rishika. Are you ready?
Yes, sir. Yes, sir.
Okay, great. So Rishika, please introduce yourself and talk about the project. These are a series of projects, as I said. There are more than 10 different specific projects which have matured to some extent. And I'm happy Rishika has come back to us. She was with us in her second year, and now she's in the final year in IIT Delhi, and she's back to us. Rishika, over to you, please.
Thank you, sir. Hello, everyone. My name is Rishika Khanna, and currently I'm a fellow at MRC, and I have done my undergraduate from IIT Delhi in mechanical engineering. So I am working at MRC on understanding sediment transport in tropical waters, and today I would be introducing you to some of my research directions. So I would start with discussion on what is sediment transport study and why it is needed in tropical waters. The process of sediment transport, how it is carried, importance and consequence of sediment transport from environmental perspective, the technological interventions which are available and which can be utilized in sediment transport studies, the pathways of sediment transport studies which we are pursuing at MRC, and skill development in sediment transport. So sediment transport is mechanism by which coastal erosion proceeds. In tropical water, sediment transport and distribution at land-water interface has significant impacts on overall water dynamics, such as in coastal zones, rivers, and estuaries, navigation of waterways, as well as it also has impacts in the water quality levels and related issues such as aquaculture. There are already many scientific studies going on Nordic countries. However, the problem is they are not curated for our tropical waters. So applying these frameworks directly from other parts of the world will not work. As tropical waters have very unique climatic conditions, sediment composition, aquatic ecosystem, socioeconomic conditions, as well as we need to take into account different stakeholders' perspective. So we need a targeted approach on several issues, including marine traffic, waterway navigation, as well as shoreline vulnerability. And the technological revolution has provided us with with a lot of low-cost tools for in situ studies, like sensors and getting like sensors and remote sensing for getting satellite data. And so it makes it easier for developing our inbuilt sediment transport monitoring and management system, which will benefit the tropical countries at the global level. So I would be starting with the process of sediment transport. There are three main categories which is defined in sediment transport process. First is the force which initiate the sediment transport process. So there broadly, the forces are categorized into 5 different categories. The energy input is given by tides, waves, winds, and currents on the beach and ports, also, which induce coastal erosion, sediment transport, as well as the accretion. So, these 5 natural categories I will explain briefly one by one. First, the sea level changes. These result in emergence and submergence of coastline, which start the process of erosion and hence the sediment transportation. The second are tides, which are oscillations of ocean waters due to gravitational forces exerted by sea and the moon upon the oceans. So they move and they are capable of moving enormous amount of water 4 times a day and and hence are capable of playing an important role in nearshore dynamics. The third, the waves are mostly created by winds, and the wave energy is usually dissipated in shallow waters by frictional interaction and seabed. The fourth category is the currents, which are created when wind blows over the water surface, producing stress on the water particles and causing their movement in the direction of the wind. The last category is the streams, which are important for providing sediments and building depositional features. Now we come to the second part, how grain size is important in sediment transport studies. So generally, the sediment particles are divided into 2 categories, cohesive and non-cohesive. Cohesive particles contain mud and silt, which have sizes less than 4 micrometer in diameter, while the non-cohesive particles contain sands having size greater than 64 micrometer in diameter. And these two types largely differ in the sense of their interaction amongst themselves. Focusing on cohesive specifically, the cohesive sediments typically aggregate to form flocks in the process of flocculation, which are of the sizes of approximately 100 to 200 micrometer in diameter, and the flocculation process causes the sediments to settle down faster on the bottom. And they are usually initiated by chemical or biological external forces. Now, how the movement of sediments takes place. So, there are two methods by which sediments travel. First is as bed load transport, and second is by suspended load. So, bed load generally consists of coarser particles like sand or gravel, which formed the non-cohesive category, and they travel by rolling or sliding by remaining continuously in contact with the bed, while they jump in short trajectories along the bed. The suspended load consists of finer grain particles like clay or silt, and they generally float in the water column and are generally carried by the turbulence. Now, the movement, how the movement is caused, the main cause of the movement is the frictional force between the flowing water and the seabed, which generates the sufficient shear stress to overcome both the gravitational force as well as the friction between the sediment grains and the underlying bed. And this shear force is directly dependent upon the average current speed. And the direction of specifically in the coastal zone, the direction of the next coastal sediment transport is usually perpendicular to the shoreline. Now we come to the importance and consequences of the sediment transport. So sediment transport and deposition are a lifeline for many ecosystems, either directly or indirectly. They build an aquatic habitats for spawning and benthic organisms. They're also essential for replenishing nutrients for aquatic plants and vegetation in nearshore systems. And sediments which are transported from watersheds to downstream, they are deposited in form of deltas and mudflats. This helps in maintaining the wetlands and protecting against the coastal erosion, as well as affecting the maintaining the sea level rise. However, there are certain downsides too. Too much sediment is responsible for contaminating the water and promoting excessive algal blooms and blockages of waterways, or sometimes also altering the direction of the waterways. They can also disrupt the migration cycles of many aquatic organisms and can harm their organs organs such as gills of the aquatic animals. Too much sediment is also responsible for decrease in the oxygen level, as when the water temperature rises in because it increase because the increase in sediment level causes the temperature to rise as sediment absorbs more heat than water. So for maintaining an balance between balance of the sediment transport, there is a measurement given by total maximum daily load (TMDL), which establishes a limit for measurable pollutants in the water body. Now we move on to the technological interventions which are there. So as I mentioned before, the bed load transport, the shear stress is directly proportional to current velocity, and the bed load transport is proportional to the shear velocity. So for measuring the shear velocity, we need the measurement of average current velocity of our water system. For this, we utilize an instrument called acoustic Doppler current profiler, which measures the average current velocities as well as sediment concentrations to get the bed load and suspended load transport of the sediment. The direction of the sediment transport is detected by either by geomorphic indicators or by tracking the movement of sediment via artificial tracers. The next is our wave refraction studies. So these studies determine the places of wave convergence and divergence, providing the quantitative measurement of the littoral drift and direction in local as well as regional areas. Sedimentological methods analyze the sediment profile and analyze the sediment transport, which include the beach profile as well as sediment budget. And sediment trap study is employed to measure the quantity of suspended sediment which sink in an aquatic system over a period of time. Apart from these, we also have remote sensing studies going on, coastal platforms which provide reliable long-term littoral drift information, and the advantage is that they can be conducted quickly. There are also sediment transport monitoring and modeling in place, which are gaining importance in recent times because theoretical field and laboratory analysis often prove inaccurate and misleading due to complexity of the whole process and large number of controlling parameters. Now we take a look at one successful example in sediment management, the Mekong River Commission in China. So it has developed a discharge and sediment monitoring program known as DSMP, which obtains high quality sediment measurements of Mekong River. So it is responsible for recording daily water levels, weekly, bi-weekly discharge levels, collection of suspended sediment samples, bed load and sediment grain size, as well as cross-sectional channel surveys. And all of their data is available freely online on their website. So why this case study is important? Because the Mekong River closely resembles the tropical water systems in India, and their results and methodologies could be directly applied to our tropical system. Now, why do we need the three different pathways which we are studying at MRC, which we are pursuing at MRC? So we are mainly pursuing the river, coastal as well as port systems separately. It is essential because it helps in effective resource management, such as development of separate monitoring systems, prediction tools, as well as intervention strategies. As also the sediment transport studies is extremely critical in tropical waters due to their high siltation rates in them, and each of these three systems have different siltation type. So desiltation efforts require precise information separately on these three pathways pathways and difference in the sediment deposition type. So the separate understanding of these three systems will through three different demographically important case studies will address the diversity as well as the similarities of these systems, and we are focusing on delivering policy and technology interventions, acoustic capacity and capability building for these three different pathways. Now, why we have chosen Brahmaputra in tropical river system? There are the Himalayan rivers usually have higher siltation rates, and 80% of sediments are originated from higher Himalayas due to the rugged terrain, fragile geology, and uneven but intense rainfall and supraglacial debris. These cause problems such as riverbank erosion, blockages of river channel, damaging the turbine, degrading the water quality, and disturbing the riverine ecosystem. So, Brahmaputra provides an ideal case study because the sediment load in Brahmaputra is also higher than as compared to other Himalayan rivers like Ganga. The Brahmaputra river flows through three different countries, making it of national importance and making it crucial in maintaining international relations as well. Brahmaputra is highly dynamic, and the region surrounding it contains dense and largely poor population, so making the river the center of economic development. In tropical coastal system, we have chosen Konkan coast and the JNPT port which lies on it. It is marked by rugged terrain with seasonal rivers which drains the coast and carries the silt load, especially in monsoon. And the whole of the Konkan coast is marked by different sediment features like sea cliffs, dunes, caves, and shore platforms. The higher sediment rate in Konkan coast causes problems such as severe coastal erosions due to shifting sediment transport patterns, obstruction of waterways due to siltation, and also the ineffectiveness of sonar for sensing in tropical waters. So the Konkan region provides an ideal case study because it has 500-kilometer long coastline, which covers the economically important areas of Goa and Maharashtra. The JNPT port, which lies in the Konkan coast, is one of the largest container ports and handles significant part of country's sea trade. And these studies will form a prerequisite in coastal projects like ports and harbors, fisheries, coastal protection, as well as land reclamation. Now, what is the way towards skill development in sediment transport study? The first step towards it is categorizing the different skilling level as per the requirement of the industry. This will include people who are directly who are operating instruments on ground to the people who are in the who are in the data analysis section and logging the data into the computers. And it requires building modules separately at different skilling levels for each of these categories. The third step would be identification of stakeholders who will implement these skilling modules. The fourth will be delivering the modules as short-term and long-term courses, and as well as supplementary courses to some major maritime degrees. And it will also include training and education in dredging, which forms an important industry in sediment transport, in sediment transport industry, and other desiltation, and including other desiltation industries also in the skill development program. Thank you.
There are many aspects to the sediment transport, and a lot of scientific study is required to be done, followed up. And it is not just the technology intervention, but it is also the policy intervention that is important. How to manage communities, how to manage different other possibilities. Are we going to use the river only for transportation, or there are other opportunities also that can be kind of looked at? So Rishika is working on the sediment transport, but you'll also hear other MRC researchers looking at various other aspects. So this work, she started earlier, and now, because the sediment transport is a very, very important aspect, but there are difference in the way the Brahmaputra siltation behaves, the way the kind of issues or complexities which JNPT port management will face, and also the coastal. I mean, if you know, the Konkan coast is really suffering because of coastal erosion, and that is happening across various other places. But we thought this is an important. This was a thriving coast, but there's a lot of issues that the coastal communities are facing. So if there are no questions, we'll move on to the next. Thank you, Rishika. It was a good presentation. Any questions on the chat box? I'll just read out. I'm Commander Amila Prasanga from Sri Lankan Navy. My present appointment is Military Research Officer at Institute of National Security Studies under Ministry of Defense. I am Anti-Submarine Warfare Specialist acquired from ASW School, Indian Navy. I was there online throughout the day. It was very informative seminar. Looking forward to attending upcoming sessions also. I would like ask what possibilities that the Maritime Research Center can make collaboration with Sri Lanka or my institution where I'm working now. Commander Amila, thank you so much. I was in Sri Lanka last year on the 9th of May when the country was burning. I was there. We have a MOU with the Pathfinder Foundation, and the visit was particularly to build the collaboration with the various Sri Lankan institutes. I'm in touch with the Ocean University in Colombo. I'm in touch with various other organizations. Pathfinder was extremely gracious to ensure my interaction with various, even the military university. Also, we have been interacting with them, and their students have also joined us for internship online. And your High Commissioner in India, Milinda Moragora sir, has been extremely kind, and he has facilitated this collaboration with Pathfinder. I think we are waiting for the situation to get better. It's already better from what it was earlier. And as things get better, we would be also establishing physical contact of exchange programs of students going there and coming here. And but we are open to more collaboration, and I would request you through your office, many more people can join online. It's a free workshop. You can just share the link the way you are joining. Many more people can join and give us your word of advice and encouragement, and we'll be happy to take it forward. So happy that you've joined us. Thank you so much. And I think Pathfinder, I must thank, I don't know how you have got the contact, but I have also shared. In fact, Ambassador Gunathileke sir was supposed to join us last week, but at the last minute, he had a little difficulty, so he could not join. But we are in constant touch with Pathfinder Foundation, and we'll be happy to interact with many more organizations like yours. Thank you so much. We can discuss more details of the collaboration in a one-to-one interaction. Thank you for your comment. So we'll move on to the next presentation.
So hi everyone, Sanskar this side. So wait, let me just share. So I hope the presentation is visible.
Please go ahead.
Yeah. So hi everyone, Sanskar this side. So I am a research fellow at MRC. Previously I was an intern working on passive sonars, and now I'm working on a broader aspect of marine ecosystems and marine spatial planning. And basically I'm working on the technological interventions that can be there. So I came from a technological background. I am a third year undergraduate at IIT Delhi pursuing chemical engineering. So I will go through the deeply into the marine spatial planning, what marine spatial planning is, what are the different stakeholders, and what are the current projects going on around the world, and what are current developments are going on around the world, what are the technologies that are currently in use, and what MRC is doing, and what are the challenges in implementing all those. So when we go through the content, so first we will go through what is MSP, then who are the different stakeholders in MSP, who are the different technologies that are currently in use, different fields in MSP, and what are the challenges. So when we talk about MSP, the Marine Spatial Planning, the first word came into our mind is the balance. Balance between the stakeholders, balance between the ecosystem, balance between the economy, balance between the cultural values of the people around there, cultural values of the general public. And the second thing is the integrated management. What MSP promotes is the integrated management between all the stakeholders and all the people, all the technologies, policies which are directly affecting the things, and it deeply promotes the integrated management of the stakeholders. And other thing is the conservation. Like recently we had a session with the assistant general director of UNESCO, and what he basically describes in his PPT is basically depends on the sustainability and the conservation of the resources we have, and what we are using now. And MSP deeply covers the conservation part of the marine ecosystem and the marine life. And the fourth is a collaborative process, which directly depends on the stakeholders, collaborative process between the stakeholders, transparency and the accountability. When like transparency is a basic concept, so it depends like if when we take all the stakeholders along with us in a same path, then it automatically increases the transparency among the stakeholders and also increases the accountability of each stakeholders. So what for what they are doing and what is its result. And the last and the most important thing is that MSP is accepted worldwide. Like it is accepted now in I think 38 countries, and it is accepted by the Australia, it is accepted by the European Union and many more countries and unions. So this image basically describes whole what is MSP. When we see there's a extraction of oil going on, we can see the marine life here, we can see the fisheries going on here, and we can see the transportation part also, which basically covers all the parts of the marine spatial planning. When we talk about who are the different stakeholders in MSP, like we talked previously about much of the stakeholders, like it increases the balance between the stakeholders. It is a collaborative process. It provides integrated management and many things. So who are these stakeholders? So first, when I describe the stakeholders are those who have a stake in certain task or a process. So first and the most important stakeholder, what I think is the government and the regulatory agencies, because whatever we build, whatever the software we build, whatever the policies we make, whatever thing we are doing, we have to pass it through the government and the regulatory agencies, because the things like marine environments, marine ecosystems, coastal areas comes deeply under the government and the regulatory agencies. Second is the private sector actors. Like mostly the private sectors are deeply engaged in the marine spatial planning, as we see that there's a lot of recreational and the tourism are there. There's a lot of oil extraction going on by the private companies. There's a lot of fisheries are going on along with the help of the private companies, and we have to control it at a certain level. Third is a non-governmental organizations. These are the organizations who work in the area of conservation of the marine ecosystems, who work in the conservation of cultural values, who work in the sustainability towards the oceans. And the fourth is a scientific and the research institution. The most important for me and for the MRC, I think that we are deeply attached with the scientific and research institutions. We are deeply doing researches into the area of marine life or marine ecosystems. And I personally belong to the technological institute, and that directly affects me. And the other one is the coastal communities, the communities which lives there around the coastal areas, and their livelihoods are depend on that. Other one is the recreational users. Recreational users are those like us who are there for for some kind of enjoyment, for the holidays or for the tourism, right? Like I am going for a surfing there, I'm going for a fishing there. Then this also directly affects the recreational users. Our policies will directly affect the recreational users. And the other thing is the environment and the conservation group. It is a narrow aspect of the NGUs. Basically, environment and conservation groups basically works on the conservation and the sustainability part of the oceanic resource and the marine resources. Other one is the international organizations like European Union. We see the many countries which are now accepted the MSP. These are the international organizations, and UNESCO. There are these kind of various international organizations which are directly affected by the MSP, or which are playing a role in making policy for whole the world and the new technologies, intervention of the new technologies in the field of MSP, and of course the general public, the most end user of the all the policies and all the technological aspect we are gonna the technological intervention we are gonna make. So these are the final users of that. So these are the most important stakeholders what I personally feel I listed here. Now, as it is a technological or what say technological intervention workshop, so what are the current technologies that are currently in use in which are going through the MSP and which we are using extensively in our softwares or in our products. So first and the most important is the geographic information systems. When we talk about a mapping part, when we talk about the part which is which takes care of which help us to analyze things geographically. Where here comes the geographic information system. Second is the remote sensing technologies. These are the source where we get the geographic information systems. Third is the autonomous underwater vehicle, which are non-manual vehicles which are used to get the data at certain data of ocean like salinity and the temperature, which we will use in certain projects, like if we have to calculate the transmission loss, if you have to calculate the noise at a certain place. Then fourth is the URN monitoring technologies. We will discuss about it later. This is a current project in our in MRC. And the fifth one is the real-time monitoring technologies. Like as a current world, we see that there's not much work going on a real-time monitoring or the real-time mapping of the things, where we are getting data delayed and we are having a delayed results of it. So we will work upon the real-time monitoring technologies and we will talk also about it later. Other one is the modeling and the simulation tools. When we talk about the modeling and the simulation tools, so these are like what we are like, we can't do certain things there at the physical level or at the on site. We have to simulate some things in our labs, we have to simulate something in our softwares. So that's the modeling and simulation tools. Other one is the blockchain technology. Like we will work upon a certain blockchain technologies which are really good data structures, I say, to store data safely and securely and for a long time. And not the last but very important, artificial intelligence. This is the, I think, base for all the technologies we are working on, or all the technological softwares we are working on. As we see, there's a current in current world, there's a lot of work going on in artificial intelligence in many sectors. Now, what are the different fields in MSP? When we talk about the technology, when we talk about the stakeholders, where we can apply it. So these are some different fields in MSP which I listed. That sediment management is the first, URN management, freshwater management, habitat protection and preservation, shipping and transportation. We will talk in detail about all these, and we will see certain case studies which are being done, or certain projects which are going on in MRC. First, when we talk about the sediment management, the first thing is comes in our mind is like when we go to a certain, like if someone visited Brahmaputra, someone visited Ganges, we see certain silt at the coast, and we see that sand kind of thing, and we see there's a bad load there in the rivers, and that's like not basically but certainly describes what sediment is. And like we have to work on the sediment management because of certain decisions for the conservation of the marine life, certain decisions for the sustainability, and to analyze and to analyze the change in the sediment deposit at certain places. So these are some case studies I am going to talk about. So first case study is a total sediment load in rivers. This is a case study done So what total sediment load is, first I describe. Total sediment load is the summation of the bed load. The bed load certainly describes the big chunks which flow with the river and settle down at the bottom, and the suspended sediment load, which are the small cell particles, and how we are calculating the total sediment load effectively. So where it comes is we are using two models in this case study, which is MLR and the SVR. MLR basically is multilinear regression and SVR is support vector regression. So we are using these two models, and we are using it, passing through it the PCA, where we are using PCA. As we see, for a certain things to happen, for a certain value to calculate, such like we want to calculate the total sediment load, then there are certain key drivers for it. There are many key drivers for it. To minimize that key drivers, or to extract who are the main key drivers, who are the most important key drivers who are affecting the variability of the TSL very much. So here PCA comes, principal component analysis. This helps us to get to know who are the major key drivers for a certain variable. So we use principal component analysis, and what we get is we get 10 dimensionless parameters identified as the key drivers for TSL using principal component analysis. And we will then pass these drivers to the MLR and SVR model. So what we did is we used two things, a stepwise and a tenfold. So stepwise PCA based MLR and a tenfold PCA based SVR model. What stepwise, we do stepwise regression of the data set. We divide the data set, and what tenfold is like we divide the data set which we have into 10 parts, one for 10 equal parts, and one part is used for the testing the model, and 9 parts are used for the training the model. We do for each data set 10 times, so as we cover all the data set. So these are certain terms which I want to define to get more better understanding of what this case study did. So what we find in the results after we get the p type or the r squared values are that the PCA based SVR model perform very good in the simulation. So this is a I think current best technology to calculate the TSL, the PCA based SVR model. So this is that case study for the total sediment load. And this graph shows us that how PCA based SVR model performed very well. So when we see the second graph, you see there's a red line which is the observed data, which is the calculated data at on site, and now we see this blue line which is just overlapping the observed data. This is our PCA based SVR model. When we when a certain model or when a certain model results overlap the observed data, it means it is a very good model, and it is overlapping observed data, it means it is very accurate. When we see the PCA based MLR model, it is very far away from the observed data, so it is discarded. So this is the prediction of total sediment load. And the second case study, and the most important thing most important project I think is the sedimentation mapping, because it is really important for the conservation of the environment, and it is really important to keep track of what's going on and how it is being transported and how it is being changing. So what it does is like we use this case study uses the Sentinel-1 satellite images, and we go through the certain data pre-processing algorithms, and we get to know that the wetland habitats at certain place decreased by the 87% in just these 4 months, and the sediment deposits are increased nearly by the 171%. So these are some technologies which help us to determine or analyze, or it helps us to take decisions in future. So these are two images which directly came from this case study. When we see the right side of the image, there's a low sediment, and when we see the left one, there's a high sediment is there. So this directly shows that how the wetland is very rapidly decreased, and the sediment is increased very high by 117%. So by these types of projects, we analyze how the sediment is changing, and we can take decisions so far. And now when we go through the URN management, so URN, what is URN management? What the URN management is basically the underwater radiated noise management, and why it is important. Like the animals like dolphin, there's a marine organisms like dolphin and whale which do their talking with the certain frequencies. It is directly affecting the hearing power of the organisms. It is proportionating a disorientation, and it is a result of death of the marine ecosystem. So what we need to do is we need to generate some quieter technologies. We need to change our shipping routes. We need to noise we need to map the underwater radiated noise. So that's what we are working on. We are working on mapping of underwater radiated noise at a certain location. So what we are doing is we are doing a certain project in Arabian Sea and Indian Sea, and what we are doing is we are plotting the receiver points 0.25 degree apart from each other. And when we see the data, we are using the AIS data for the ships, for the ship's location and for the ship's source level, basically the noise generated by the ships. So what we are doing is at the each receiver point we are targeting the ships which are under 200 kilometer of each receiver. We have almost 5,000 receivers. So we are doing this for each receiver, each 5,000 receivers. And for the each receiver which are the ships who are under the 200 kilometer, then what we do is we calculate the transmission loss, or we calculate the noise of the resultant ship on that particular receiver. Then we do the sum, then we get a matrix of 5,000 cells and each cell contains a total noise at a certain receiver, and then we map into the 3D environment. So what we are this is a huge data set, or there's a lot of data set as there. So what we are doing to minimize the computational power, or to minimize the storage of the data set, and to increase the running time of the software. So what we are using is we are using the R-tree, the most efficient storage systems for these kind of data sets. As we are having the spatial data sets, it means the distributed data set at certain places. So what we are doing is, what RT do is, it basically cut the rectangles for the certain data sets, and you can see there are three rectangles, R, S and T. So what we are doing is, there are in T we can see that A6 and A2 are there. In S we are seeing that A3 and A4 are there. In R we are seeing A1 and A5 are there. So for a set, if we are having that a certain coordinate, there's a receiver coordinate, then we don't have to iterate through all the shapes and we calculate there are less than 200 kilometers. We just have to look at a certain rectangle and all the values which are overlapping it. So this is how we are doing the data management and making efficient algorithms. Now, when we come to the freshwater management, there's a current need of freshwater management very deeply in the Indian system, or we say at the whole the world, because there's not much freshwater are there for our future generations. So we have to manage it and we have to map it basically. So technologies like remote sensing and geographic information systems, which we talked about previously, are having major role in the freshwater management, as we can predict where the fresh water is there's a lack of it, and where it is more, where it is used negatively. Now, these are some case studies which have been done previously by some institutions. So, first case study is for the predicting the water quality. So, what they are doing is, like, they did certain project in Illizi region of Southeast Algeria. They use some 8 artificial intelligence algorithms like multilinear regression, random forest, M5P tree, random subspace, and so on. So, and the key drivers for the water quality index is for the TDS and the TH. TDS is the total dissolved solute in water, and TH is the total hardness. So what we see is like the MLR model has the highest accuracy in the first scenario, and the random forest model has the lowest error rate in the second scenario. This is the result of this case study. The second case study is a improvement in the first case study. It's like it declares that we can't just focus on one section of the river, as rivers are the fluvial systems, and they change. They are very dynamic kind of system. They change rapidly. Their data changes rapidly. So what they are doing is they are doing their study at multiple sections of the river, and what and which technologies they are using are they are using CNN and LSTM. So when you see this image, this is the combined system of CNN, which is convolutional neural network, and the long short-term memory layer. So what we are doing is we are providing some input data. We are providing some input data, or we say the images of some sections or quality of the water. What convolutional layers do is convolutional layer just get some extract some important things or important edges or important values from the data, which helps to predict the future things. Now what pooling layer did is pooling layer just divide the data into the windows, and from the each window it chooses the maximum value, and that's the value of that window. Now we have the data reduced. Now we have now reduced the data, and it is now easy to process. Now we have the flatten layer. What flatten layer did is, like you see, there are multi-dimensional data. There are 5 layers we see, but in flatten we see just one layer. So what flatten do is it just compress the data from the 5-dimensional layer to the 1-dimensional layer. Now this data is easy to process by the LSTM. So what LSTM is, like currently you are seeing the lot of work going on the writing part, and a lot of work going on the language estimations, like current project which is going on by the OpenAI is the ChatGPT, which uses the LSTM. So what LSTM is, it has the 4 things: input gate, output gate, and the memory chamber, and the forget gate. What memory chamber is, it stores the data which is the input in it, and now it predicts the input. Now from the memory chamber, the output gate predicts that which certain results I have to output, and the forget gate forgets the old data which is now not in use. So this is how LSTM works, and this is how this whole project works. Now the most important thing we talked initially is the blockchain, and as we all know that blockchain is a current very efficient or very secure, or we say the most efficient way for storing the data. So what this case study do is it integrates the data distributed storage systems and the blockchain technology to promote or to have a secure and a transparent way to share data, promoting it, and collaboration between the stakeholders. So what is the need of the blockchain? So we see in this map, like we get the data from the water quality sensors. Now what is the problem? There's an energy consumption. Hacking can be done of the data. Time bound storage. Like if I want to use the data by 10 years of now, there's no surety that I got the whole data and I got the data very clearly. This is the problem. Now this is the data integrity, basically data management. Storage issues are there. Then there's a lot of data. If we see particularly in India, there's a lot of vast data here. So there are certain problems. So now what blockchain is doing is we have data from the Internet of Things, IoT. Now what we do is we create the hash tables and we encrypt the data. What encryption is, it doesn't change the data, it just changes the language, so no one can have a sense of it. Just a software can take it to that side so that normal people can understand. So this is the broad, very broad, I think. This is not detail. This is very broad thing what blockchain do. Now when we go to the habitat protection and the preservation, this is a major issues what comes under the sustainability and the conservation part. So there's a lot of oil extraction going on. There's a lot of fisheries going on. This is the cause of many disbalance in the ecosystem. So what we can do is we can minimize the we can implement certain policy interventions. We can have certain technology interventions on it to protect it. Like we can certain define certain regions where fishing can be done or where fishing can't be done. And the other thing is the shipping and the transportation. So shipping and the transportation, I think, is an essential component, because like as the shared in the previous workshops, is easy to transport things by the oceanic route rather than the road route. It takes less time, or it takes also it also cost us less money. So what the problem is, it is there's not proper synchronization between the ships. So what we have to do is we have to optimize the shipping lanes. We have to implement certain speed restrictions. We must see the environmental impact assessments and many more. Now we talked about a lot about the things, and we talk about what we can do, what the things are going on, but what are the challenges there can be. So when we talk about challenges in the policy interventions, so jurisdictional conflicts and the governance gaps, as we talked about, there's a major stakeholder is the government and the regulatory agencies. So we have to go on through these jurisdictional and governance things to pass through the path of things. This is the, I think, major challenge in policy interventions. Lack of clarity in legal frameworks and the regulatory mechanisms for MSP, inadequate funding and resources to support MSP. Like there's not much funding going on in this part. Lack of long-term vision and the planning horizons. Like we are currently working on it. We are using blockchain, which is for the long-term vision, and we are doing URN management, and we are predicting the sediments. So we are truly focused on the long-term vision. Till now, there's not much work done for the long-term vision and the horizons. What are some challenges in technical adaptation? So when we see, if I want to work on a certain project, if I want to go through the data, then I feel a lot of difficulty in availability and accessibility of data, as these are available on certain specific sites, these are available on certain coast. So these are some accessibility and availability and the problems in the data. Second is the complexity and the dynamism of. So we go through the challenges in technical adaptation. So difficulty in balancing the multiple and competing objectives of MSP. As we see, there are different stakeholders and there are different stakeholders which comes from different parts. Like we have government, we have local public, we have environmental groups, we have recreational groups. So these are some challenges in basically we can't define a technology, or we can't define a software for all of them to have common to be at a certain page. And the fourth one is a limited integration of emerging and the innovative approaches. And we are deeply focusing on the innovative approaches and the current ongoing technologies like blockchain, and we are using certain data structures. So we are on the right path. So, and the next one is the topic of constraints on marine spatial planning implementation. When we talk about the technical and the policy interventions, these are certain things which are broader aspect. But when we talk at a certain ground level or on the on-site applications, we feel certain challenges which are climate change, which we talk about. There's a dynamic environment and it is dynamic systems. It is so hard to get a exact value what is going to be in the future. Second is the coral reef degradation. The coral reef is very important for the marine ecosystem or the marine life to survive, and there's a lot of coral reef degradation. And the coastal development, there's a lot of development going on the coastal side, which is difficulty for the cultural and the conservation part. And the last thing is the limited resources, as there are not much labor we can get, as there are not much skilled labor we can get for certain data collection and certain projects. So this is the end of the slide, and I just want to quote a thing which is said by the Carmen Vela, who is the European Commissioner for Environment, Maritime Affairs and Fisheries, which is marine spatial planning is not just about the mapping, it's about the balancing competing demands for ocean space and resources and ensuring sustainable use for the future generations. As we talked about in whole PPT that certain projects we are focusing on the long-term vision and sustainability of the resources. So thank you very much, everyone. This is a part of it.
Thank you, Sanskar. Any questions?
Hi, Sanskar. Can you please share the name of the simulation software which are used in the name of the simulation softwares?
No. What I talked about is like we have to build certain simulation softwares, and certain PhDs. What I researched about is make the simulation mechanically. They are not such software built, and we worked up. I personally worked upon the passive sonar thing, and what that simulation does is it predicts that how much from how far a passive sonar can accurately predict the noise. So that's that kind of simulation tools I was talking about.
We have been working ground up using Python code for every application. So what Sanskar is building is the larger framework, and he's working on a specific project also. But if you see all the projects in MRC now, we are going in for an MSP. I mean, whether it is freshwater management, whether it is sediment transport, whether it is sediment classification. Tomorrow you will see the presentation by Romit also. Across various dimensions, MSP will become the de facto tool. There is no such work in India as far as I know. Globally also, I mean, I'm talking about underwater. There is a National Center for Sustainable Coastal Management. Dr. Deepak had joined us from there. He's a deputy director there, and he presented. But what they're doing is only on the coast. As part of the coastal management, yes, using GIS and various remote sensing applications, people are talking about MSP. But underwater per se, there is not much that I'm aware of. And it is nothing but the spatio-temporal mapping that we've been working on for some time now. But now we have started using this fancy word MSP. But it is nothing but a spatio-temporal map. And I want to highlight something on that. When we talk about spatio-temporal map, your scale is extremely important. When I say scale, now if you look at the Brahmaputra itself, if you want to really do the management of Brahmaputra, you have to look at the multiple aspects. So when I say spatial scale, it has to cover the entire, if at all you want to do climate change modeling, it has to cover the entire space right from the oceans to the Himalayas. So the scale has to be appropriate to make sure that you are able to cover all inputs, because the factors that affect the river or the basin will have to be taken into account. The second is the time scale. The time scale has to be at least 100 years. So when you run a prediction model, it has to cover at least 100 years in future. Otherwise, it makes no sense. And at the same time, you have to really understand the depth of what we are saying. I mean, do you have the wherewithal? Do you have the data? Do you have the know-how to be able to map it for a spatio-temporal scale of that order? So what we are trying to do is we build it ground up. Every aspect is taken into account, and we are trying to, and it's a lot of work. It's not yet that we have done everything, but that is the approach we are taking. So in some cases, we've already done it. In some cases, it's work in progress. So you will see, like what you heard, Rishika also, the final product that will come out is a MSP like that. And that's a real-time map. So it will give you right now what is going on, and it will also give you in future what will happen. So in this, as I said in the morning, when I say to see, to understand, and to share, when you share, if it is a policy maker, he wants to know the future. What will happen 100 years later, or what will happen, and so that his requirements are totally different. But then if it is a mid-level manager, his requirements will be different. If it is a ground level operator, his requirement will be absolute real time right now, what is going to happen. And how am I going to manage what is going to happen? So that is the larger thing that needs to be understood. So it's a very big thing that one needs to understand, and it will be always a work in progress. It will evolve. But what we as MRC are trying to, and there is also an issue of data. A lot of data is classified. Now, if suppose there is a naval application, the Navy cannot share the data with us. So what we are going to do is build this framework, hand it over to the Navy. The data will be, I mean, the actual algorithm will be run by them. We should have no access to that, even what is being input and what is. Yes, we will have some sense of, or say a person like me, I have some sense of what is the possible requirement. So we build a framework, then it goes through several iteration with the specific user, and then it will evolve into a much more finished thing. Similarly, say army, if they have to deploy, now he is talking about amphibious thing. Can you launch an amphibious operation in a particular area or not? Don't you think you need something like this? Even at the top level, like suppose in the Navy, at the top level, if they have to deploy certain assets. So right at the top level, what is the first decision? Is it feasible or not? Even for that, you need certain inputs. So the MSP has become a de facto tool for everything. I mean, it can be a strategic security application. It can be a sustainable blue economy. It can be a conservation operation. It can be anything. MSP is just a broad tool which will, so that's a policy, a technology intervention that will enable policy making. But having said that, there's a lot of work to be done. Every aspect will have to be taken into account. The application has to be understood, and even for the communities also. What is it that the community benefits out of it? What is the role of the community? How in the long term? Now when government say Manrega, like we were that day talking about, Manrega is a thing, but Manrega today is more land-based. But even say dredging now, don't you think Manrega should apply? There are communities there, even they should be involved. What is the larger focus of Manrega? That the community should get involved in a project. So today Manrega is like, suppose there is a road construction, there is some work there, the local community, so government has an instrument where fund is available, you can involve unskilled people so that the local community gets connected. So now there is a proposal that we are also now talking about it. All the community-based activities in the coastal and the riverine community, like dredging is one aspect. So can we not, but it will require some modification to the Manrega mandate itself. But now, instead of creating another instrument of providing, money for such activity, Manrega is an instrument just that it needs to be aligned to this. And that's what we have been a proponent of, not starting a new scheme. There's no new scheme required. Already existing instruments should be customized or kind of aligned to a particular specific requirement. Right? I hope I have answered your question. Right? Any more questions? Anybody else? Yes. In fact, what you are saying is, so the URN, I mean, are one of our flagship contribution, if I may say, what I mentioned in the morning about the URN underwater noise. So underwater noise, how does this get generated? So what we have done is divided the entire area into grids, and for each grid we find out what are the ships, and from AIS you get all the data, I mean the static and the dynamic data. So we use the static data to find out what the ship is like. The specifics of the ship, but then the dynamic speed of the ship, the course it is making is required, so that we can, in the next second or next minute, where will it be, right? So we calculate that data and find out what is the radiated noise of the ship in that location. Now, once that is calculated, we also then pass it through the underwater channel, because it has to pass through the underwater medium before it is received at some place, and that's what brings the uniqueness of that area, of the tropical waters. So their sound speed will make a difference. So the entire aspect of, the sound speed profile and the whole aspect of, how temperature will affect. Like in the city of Pune, the minimum to maximum temperature difference is 20 degrees in a day. So what will happen to the sonar performance? If you deploy something in the Khadakwasla lake, with 20 degree, with every degree centigrade, it is 4.6 meters per second of difference. So all that is calculated. So this map that we have done, we are updating it every 6 minutes, because the AIS data gets updated every 6 minutes. So accordingly, the ETOPO database gives us the underwater medium parameters, which includes computation of the sound speed profile. And that will affect what is the noise, but it will also impact the sonar performance. So what we have done is that same map, now this gives you the noise, so you can easily calculate the SNR. So you can, with that SNR information, you can find out the range, possible range, right? Now we have taken it a step further. Now, if you want to deploy a submarine, what are the two conditions that are required? What is the detection capability of the submarine, and what is the vulnerability of the submarine, or any underwater platform or any military platform? Now, as far as the detection capability is concerned, with this particular SNR, you can always predict at that particular time, what is there will be far more precise because it gives you the local condition at that point of time. Or you can also predict using AI. Suppose you have an operation after 10 days or after 50 days or 100 days. In that area, today, you have a track record of data of the last 100 years. You can use that to find out what would be the detection capability, plus minus 3-4 dBs here and there. You will now, if you know the underwater ranges we were talking, if you know your own signature, you pass it through the channel that we've been discussing. How will your adversary see you in that particular scenario? And as we discussed, the sonar performance degrades by 60%. So it is very, very specific to the local conditions at that point of time. The underwater framework that we have built gives you the local conditions. So when you send the underwater radiated noise signature of the submarine through this channel, you will know how it will be seen by the adversary. So both the vulnerability of the platform can be done in the same by the algorithm. Now the context changes if you are talking about a strategic submarine or a conventional submarine. Now for a strategic submarine, as I know, vulnerability is more important. Even if it can't detect, but it should not be detected. But the same thing is opposite to some extent in a conventional submarine. Vulnerability can be compromised a little bit, but we would like to definitely get better detection. Now, this or that depends on the commander also. He may like to, so the algorithm has been made in such a way that you can play around with this. With these two factors, which can be customized depending on the commander's decision, you will get a heat map where we'll know where you should position yourself to get the most optimum, answers. So don't you think it's very fantastic to have such a tool on board in a manner that you can operationally use it? But the same thing can be used at a higher formation also, where different platforms can be assessed depending on the. And as you know, whatever it is, in the last couple of years, the computational, the infrastructure or computational has really enhanced significantly. So a lot of it can be done. Even in the hierarchies can be changed. At the top level, you want a specific information, but you want exclusive information. You don't want that to be available to everybody else. Even those can be built up. Like Sanskar is here, or we have many technology. They can build up that kind of hierarchy. That certain information which should not be available to everybody, even the hierarchy of, because in a structured organization, there are certain information which should not be available to everybody. So all those can be easily built up. So that was the share thing that I was talking. But it should be easily available. It could be available on a handheld device, say captain of the ship, or fleet, the fleet, or at a much higher level, say war room level. What is it that you want that you can define, and it can be easily done. Typically what happens is when you buy something from outside, these kind of flexibilities will not be there. And that's why, he was asking, what is the software? We don't use a software. We build our own programs. So that if you come to me and say, no, this is not what I want this, instantly our team can, so we can do a proof of concept sometime when we sit differently. We can modify it. Because everybody will have some specific customized requirement. But since it is not a black box, it is our own creation that can easily be changed. And today, things have advanced so much that it can easily be modified. It can be either done instantly, or maybe we'll say, okay, give us a day, we'll change it and give it to you. But in the long run, it will evolve over a period of time. And there will be certain standards that will evolve, and which will be very much, user-friendly. And, finally, you want the person on the ground to have a visual impact quickly. He should be able to decide. So all those can be evolved. I mean, I can imagine to some extent, but somebody like you who have been in operations for a long time, who can, or even things keep changing, every time. So all that can be easily done when it's not a, like when you use customized software, they are canned solutions that you get. So that is what we feel very proud that we can change things. So you'll see some more, presentations like this. We may not be able to show all of them, but these are the way we are working, because we are building certain core areas, and we are also building certain application oriented things. Like this is the core stuff, MSP is required across. We did a project on the channel model itself, like when you have to pass the underwater channel and whatever signal has to pass. So we have built that in a very, very structured way now. So that is more or less solid now with us. So any signal, whatever it is, depending on the frequency, that can be now used like a black box. And then, so now Sanskar doesn't have to work on that. That is available to him. He builds up on the larger framework. So that is how we have been, last, I think 6-7 years, we've been trying to build those basic blocks. So now we feel very confident that whatever be the applications, we can quickly give you a solution. I showed you in the morning in my presentation. Yeah. So that's the larger, it's a spatio-temporal map, and it is done across the depths. So I showed you. Yeah. So yeah. That's the URN thing that I showed you in the morning. But we'll be happy to discuss this even further as time permits. Any more questions, anybody? But see, you can see that there are so many more projects that will get created in this. Every application will require, now even for URN, we are taking it to what is the acoustic habitat degradation that will happen in the region. It can go into, then what are the chemical and biological, pollution or impact of that? What are the climate change impact on that? So there are so many studies that can be done. So each of them can be looked at differently. Now, like I mentioned, International Maritime Organization has given us this project, but I'm discussing with the government that India should take a lead rather than follow what the IMO is saying. Of course, IMO has given us a mandate. We'll perform that and satisfy what the mandate is, but it should be a larger thing. So in that, so much more work will be required, and to cover the entire Indian Ocean on multiple aspects. So the whole MSP will have to be populated for various users, various stakeholders. Navy will have their own requirement. Coast Guard, like marine pollution you talked about. MSP will give you a marine pollution. But when you say marine pollution, there are so many dimensions of pollution. Oil spill is different, chemical pollution, biological pollution, even underwater noise is one. I can name 10 more such things. You'll require those kind of maps. Now, if you have to go to the government now, see this shipping thing, you can't ban shipping, right? But we can also say that, because this noise is creating stranding of big whales. So we can always say that in certain ecologically critical period where the breeding is happening, then we can at least do some correction. That so many more well-informed decisions can be taken. Like now you talk about carbon credits and all that. What does it mean? Now, like what Venkata was saying, IBM has got this supercomputer and all. The supercomputer creates a lot of carbon, no? So they have to trade carbon points. They have to buy carbon credits for the pollution that they do. And who will trade that carbon? If there is a sustainable farming going on somewhere, he gets carbon points. So a farmer, or suppose one of you have a great idea and say that I've got a sustainable farming model. You get yourself registered. There's a carbon exchange. So you get yourself registered, and there'll be there's an assessment system, and you get, say, 1,000 carbon credit points, and each of them is traded against, say, $10 or $15, and there are grades of that. So for each carbon point, you get so and so money. So who pays you for this? These giants who are creating. So IBM or whatever, Google or somebody will have to buy that points. That's what is decided in all this COP and all that, right? Global players will come together and say, okay, I have done pollution, but it is required for development. Even for weather prediction, you need computing, right? So it's a necessary thing. But then the corporates will have to buy those many carbon thing. And if anybody has an alternative where he is contributing to minimizing the carbon, then he gets that money. So even there is a concept of blue bonds. We are working on that. Who pays for such a big project? So there's a concept like countries like Seychelles have gone in a big way in terms of blue bonds. Now, if you have to build something sustainable, it costs much more money, right? If a project is there and if you add the sustainability tag to it, the cost can go up to few times. How will you fund a project like that? So the concept of blue bonds has come. Earlier, there was a concept of green bond. Right? Green bond is still there, but there's a concept of blue bonds. So you can issue bonds and start the work, build the project, and then because you need money, and the money can be raised through that route. So you'll get a paper on blue bond. In fact, 2 papers on blue bonds in UDA Digest. Please have a look. So there are so many different ways the global community is, and that's the reason I'm emphasizing that whatever we do, it has to be a component of the local aspects, the uniqueness of the local, but it has to also be connected to the global thinking also. If you do not know this concept of carbon points, or you do not know the concept of blue bonds, you will do something in isolation. You'll never be able to scale up and work on a global scale. So it's very important that we appreciate these aspects. So young students must know, I mean, there are so many of the students who are working on these carbon points itself. There is the Blue Smart cab aggregator in Bombay. Their running is on carbon points. There are some people who invested on the capex, but the opex is done by the carbon points. But they claim that they are sustainable. So they earn points compared to the normal diesel. They are sustainable, and so they're getting credit carbon points. So the basic running of the company is on carbon points. I mean, there are so many such concepts. So we are trying to build it in a comprehensive. So UDA will also require this, right? You need the money. You need these kind of opportunities to connect to the global system. So if you look at the variety of things that we are doing, you'll find such issues also. And I think it's important that we are able to kind of be aware. We may not be able to use 100%, but at least it's a good idea to throw these ideas. Young students can work on it. Even if they don't use it today, they will use it in future. Or at least there's a platform which has all this information. So I'll encourage you to look at this, and it can be even for the domain experts like all of you who are coming from the stakeholders. It can be a good idea for you to look at a future direction, right? I mean, everybody needs a purpose. So this can give you a purpose. Something may interest you, and you may like to just take it forward. And we are absolutely open for you to just connect even on a personal basis. We are a private organization. So any one of you can connect with us in your private capacity and just do a project. There are many people who are doing that with us. Irrespective of, you can continue to do what you're doing in your office. You can continue to pursue that. But in your own, like a hobby, you can always run this with us. And we are happy to support you in whatever way we can. Yep. Any questions? No more questions. I think people are tired. Thank you very much for the day one. I was happy interacting with you, but it's an ongoing process. Tomorrow morning, please be here at 9 o'clock. Tomorrow we have a panel discussion, and I think you will love interacting with the people who are there. It's a different perspective that you'll get. Yeah, just go on if you go to social media also, or you go to our website, you can just log in, or you will get all the information about this workshop and whatever information is required, right? Even the concept note is uploaded in our website. So if you go to just Maritime Research Center, my promise is first hit should be MRC, a Maritime Research Center, which is ours. So Maritime Research Center or MRC, if you Google, you should get our thing. And in that, you will get about this workshop also. And even in social media, all of it, whether it is Facebook or LinkedIn or anywhere, if you just look for Maritime Research Center, you will get our thing. And all the information, login details also, you can share it with your colleagues. They can join in, like the way we had a gentleman joining us from Sri Lankan Navy. You can also pass it on to your colleagues who want to join and just see what is happening here. Or even your family members and friends can just log in and join. We have a capacity of 1,000 people can log in into our WebEx platform. So there is no limitation at all. And please log into our website, UDA Digest. As I mentioned, you will get some important information. Is that okay? Thank you.